Yeah, okay. Now we got it going.
Yeah,
Disclaimer, I'm a
okay. Now we
motherfucking
got it
philosopher.
going.
That's just what the straight facts are. And right now you are entering my quantum tunnel. Thank you for coming. What the fuck?
You have your period and suddenly, what the gush? You need this pad. Only Always Ultra Thins have rapid dry technology and they absorb 40% faster. The gush happens
You know who
fast.
got
That's
rapid
why
dry?
Always absorbs faster.
Well,
My
Wilford,
old
the
band
news
teacher, he
came
got the dry ass humor.
after the speech was already over, as it so often does, when one of our colleagues over at NBC shouted out a question at Biden asking if he supports the $2,000 stimulus checks. Biden said that he does. Now, during his speech, Biden also highlighted the importance of FEMA in ensuring a smooth rollout and distribution of the vaccine. And he
FEMA.
said that defeating COVID
Wow.
is going to require building a coalition of like-minded partners.
Oh, man.
We've learned so painfully this year the
Pain.
cost of being unprepared for a pandemic that leaps borders and circles the globe.
Sorry. Whoa, hold up. What?
We've learned so painfully this year the cost of being unprepared for a pandemic that leaps borders and circles the globe. If we aren't investing with our partners around the world to strengthen the health systems everywhere, we're undermining our ability to permanently defeat COVID-19.
Wow.
We're leaving ourselves vulnerable to the next deadly epidemic.
Oh, god damn.
Now, Biden
It's just toxic. Entertaining though, but fuck. I can't believe. Like, literally, they have this man on video sniffing children. That's fucked up. I don't even sniff children. And you don't have a video of me doing that. But that's what the fuck they have of him. It's insane. I don't get it. And then I'm already in the clear. Trump said grab her by the pussy. So, like, fuck, yo. What else can I say that's, like, worse than Kanye West? Presidential vote. Got some votes. What?
Hey everybody, I had a message the other day.
What is this
the
one?
message asked me
Holy fuck, this is a good one, maybe.
whether or not you had to show a receipt whenever you left the store. And I thought that was a great question. And I wanted to answer that question today and give you an idea.
BJ's
about
Wholesale
your
does
rights
that near us.
that you have whenever you're leaving a retail store. Now, before I give you my answer about leaving a retail store, I want to tell you why these greeters or receptionists.
First of all, in India, everywhere you go, Hyderabad, grocery stores, fuck, dude. It's green, couldn't tell you the name of it. They got mad shit where basically, yeah, people are fucking doing that there. And it was awesome. I always love doing that because it's like the foreigner's the least person they want to do that to. There's already enough pressure just looking and different and being in there in the local grocery in the areas I went. So I just felt like, yeah, if we have people there doing it.
Or receipt checkers are at the stores. And it's not to catch shoplifters, okay? That's not why they're there. The studies show that for every shoplifting event, there are 13 employee thefts, okay? So the greeter slash
Whoa,
receipt checker
for every
is there
holy
to
fuck.
make the event, there are 13 employee thefts, okay? So the greeter slash receipt checker is there to make sure that the employees aren't stealing. That's what they're there for.
No
An
shit.
example of what they're
That's
looking for
definitely India.
is
Holy
you've
fuck.
got somebody that's doing the checkout person and an accomplice. The accomplice comes in, buys $500 worth of stuff. They it goes through, looks like it's rang up, and they give $100 for it, and then they leave the store. That's an example of what they're trying to catch. So that's the real job of the greeter / receipt checker
Wow.
at these stores.
No
it's not
shit.
to catch shoplifters, it's to catch employee theft. Okay? Now, my answer applies
Employee
to that.
theft.
It applies to
I've never owned a business.
regular retail stores, not club stores. Okay, not your Sam's, not your Costco, that kind of thing. Those stores are club stores, they're member stores. You have
BJ's
a
the member store.
agreement
Right.
that you sign.
Right.
And it may allow them, or it may say, as a club member, I'm going to let you look at my receipt whenever I leave the store. What my answer today applies to is regular retail stores, okay?
Like Walmart and stuff like that. They used to be on it.
Like Kohl's, that kind of thing. Now, there is no legal receipt whenever I leave the store. What my answer today applies to is regular retail stores, okay? Like Walmart, like Target, like
What?
Kohl's.
It's a
that kind of thing.
retail store.
Now, there is
I like
no
Kohl's.
legal requirement for you to show your receipt when you leave those regular retail stores. Okay?
Interesting.
Now,
You have to be a club
the way
member.
it works is
Wow.
that, think of it this way. There's no legal requirement for you to show a receipt to the store greeter or checker
But
to prove that you legally bought your property, okay? Because the way it works is when
Whoa,
you're in the
hold
store
up, what?
shop, the way it works is that, think of it this way.
there's no
There's
legal
no
requirement.
legal requirement for you to show a receipt to the store greeter or checker to prove that you legally bought your property, okay? Because the way it works is when you're in the store shopping and you pick up whatever you're buying.
This
put it in-
gets ugly. If we're gonna get into the real details of this, yo, how do we determine whose property is what? We have zoning and land, but for fucking... Are you trying to tell me that for every single outfit I have and piece of clothing, I'm supposed to carry some identification, it's mine, and I purchased that? I mean, technically, you know, I know for a fact that some companies, like, they put serial codes on it. Off-White is one of them. So, like, you could check and see what number shoe you have, but to purchase, to prove you bought it? Whoa.
That's really the store's property. Now, when you go through the checkout and they give you the goods,
So when does
in
the
exchange,
transfer of ownership...
and you pick up whatever you're buying, put it in your
Occurred.
cart, that's really the store's property. Now, when you go through the checkout and they give you the goods in exchange for payment, once you've paid, those are your goods, okay? They're no longer store merchandise. They belong to you, okay? So
When you
after you
purchase
pay
it.
for them, they're your property. The store has no right to stop you and make you show a receipt to prove that you own that property. They have absolutely no legal right. It's the same thing
Wow.
is, let's say,
They have no legal
if they
right,
wanted
so
you
you
to
could just...
prove that your cell phone belongs to you when you leave the store. They can't do that. Okay, they have no legal right to do that, to stop you and look at that receipt. Now, they can
So they have
ask
no
you
right to look through my phone and tell me that this is who I am because it's just what I am through a piece of fucking glass.
for your receipt.
And if people didn't feed off of the energy of what's in these and what's going around on this fucking the web, like they wouldn't need it. They'd see bigger things. They'd be farming and shit. They'd be literally how they are living in developed
You
countries.
don't have-
Or yeah, how it's scheming to go is more people are getting phones, playing games.
Have to show it. That's that for your receipt, but you don't have to show it. That's the way it works at the stores, okay? And that's regular retail stores, not the club stores like Sam's or Costco, because there may be a member agreement that you sign saying that you will allow them to look
Right.
at it. But regular stores like Walmart, Kohl's,
So what do you do, sir? You just back people that
Target,
shoplift?
these kind of things. it
Why do you
applies
just
to them perfectly.
bring things
They have
up like
no
this?
legal
I
right
get it, but
to stop
it gets
you
really-
and make you show a receipt. And the way
Has
it's
this
worked
done
now, it
anything?
used to be, the greeters would say, "Hey, how you doing?" whenever you came in the door. Now, when you leave, they want to see your receipt. All right, and it's gotten worse than see your receipt and look through your cart and this kind of thing, like they believe, like they're actually checking something. Now, because, in my opinion, because people have let them get away with this, and they stand in line. There'll be 6, 7, sometimes 6, 7, 8 carts there, people standing in line to show them their receipt. Now they've actually got scanners. So they're going through and scanning stuff again, making you prove that you own the property.
How?
Can't do it.
Right,
Cannot
no
do it.
shit.
Now, even the police, they have no right to stop you and force you to show a receipt without reasonable suspicion to stop you and probable cause to search you. That's the way it works, okay? Now, my advice is if you don't want to
Right.
stand like sheep in a,
But how would
in a
they
line or cattle in a
determine
line,
that?
if you don't want to do that and have your property checked and, and checked off and looked through to make sure you can prove that that's your property, okay? If you don't want to do that, my advice is just say no thank you. Walk on by, smile, be nice, friendly, say no thank you, and just
No
keep
thank-
walking.
Wow.
All right? The greeter, the receipt checker, they have no right or ability to require you to show that receipt.
They'd enforce policy.
Okay? So my advice, whenever if you
What's it
don't
like
want to
in a
stand
mall?
line, if you don't want to be cattle there, and just blindly have to prove that it's your
A mall
your
would
stuff
help
you
that,
just
and
paid
it's like
for,
you see
that
them leave the
belongs to
store
you
and
no
they
longer
technically
the
can't
store.
leave you from
If
leaving
you
the
don't want to
store.
do that, just say
But
no
they
thank
can keep you in the mall.
Smile and go out the door. Keep walking. Okay, that's my advice. to
kinda
you.
why we
Now,
need
this
malls, no
advice
shit.
applies to regular retail stores like Walmart, Kohl's, Target. Okay, it doesn't apply to club stores. Okay,
Wow.
Sam's, Costco, that kind of thing.
You get a club, you
All
pay
right?
for it.
Thank y'all.
Oh man, good video. That's crazy though. If we want to fix that, we got to make sure that everything has a serial number. Wow, I just smoked some lemon apricot. Yeah. See it, I gotta see it, yeah. I gotta see it, envision, and then I be it, yeah. I gotta see it, meditate, K-point, meditate, no wait, it's K-Pain 8, yeah. Point oh, you already know, no wait, if I see it, yeah. If I see it, try to be it, yeah. If I see it, try to plot the plan, then envision who I'm gonna be when I be it, yeah. Smoked so much trees just to see it, yeah. Took the time, had to unwind, and then now I be it, yeah. Now I be it, yeah. Ain't afraid to do me, yeah. I'ma be it, yeah. I'ma be it. In all reality, ain't nobody could screw me but myself. I be it, yeah. I be it, I see it. I be it, I see it. Yeah, ayy. If I see it, I want if I see it and I like it, damn, I wanna be it, wanna 3 it, yeah. I'm thinking with the Holy Trinity, I wanna 3 it, gotta see it, wanna be it, and I swim in the ocean like I see it, yeah, see it, I don't wanna be it, can't clear it. Yeah, Eminem, oh yeah. Hey, see it if I wanna see it, and then I be it, yeah. See it if I wanna be it, yeah, I got to be it. Michael Myers, I ain't afraid of smoking so much weed, then my brain gon' turn right into fryers, yeah, fryers. I went to college, got some knowledge from the friars. I'm just dropping bombs, I'm acting like I'm Michael Myers, but I'm rapping. Yeah, and you know that I'm thinking about everything that's happening. Yeah, and I'm mapping Cool. Yeah.
I didn't order a pizza.
I know. But that Parker promo saved me so much in my insurance. That little something.
Yeah. Hey, okay. What? Yeah. And we got the sticky jack, yeah. Got the sticky jack, yeah. What we doing? We about to smoke up and not relax, not relax. We can't chill, we can't chillax, yeah. We just trying to get up, we trying to stack the meals and put up a bat, yeah. I'm up to bat. Now it's time to go and hit the next rhyme. I got a spliff, just to take my time and unwind because that's what I like doing. Yeah, I don't have to have a choice. You know that I'm screwing up my body. Yeah, up my body. It's the same bullshit that I was hearing about my parents saying you can't hang out upstairs swearing in the Call of Duty lobby. Nah, yeah. You fucking up your body, yeah. Playing video games ruin your eyes, yeah. But I got my third eye open and I realize inside, yeah. Realize inside that I can't go and hide, yeah. I face it every day when I'm going out to school, yeah. Something like that, we got to realize. I've been around some real guys, yeah. I've been around some real guys. Now I'm real fried, yeah, real fried. I just even took the Geoja, yeah. Yeah, got the meal fire, yeah. You know that we smoking on that sticky Pluto Jack, yeah, Jack, yeah. Ain't no chilling up in where I'm at, it's just really, yeah. Ain't no chilling up where I'm at, yeah. Headed to get everything that's unsolved up in a rap, yeah. And then that, yeah, hey. Think about that, we ain't, hey. If I could figure out how to open up around people, I already, in my heart and my mind, treat everybody equal, but there's a thing called a sense of humor, yeah, humor. When I'm in a bad mood, I got tumors, yeah, they lagging, they taking a toll, they lagging, they sagging, tumors. What was I rapping about? Humor, yeah. Sometimes it comes in at a bad time, yeah. Cause everybody equal, even though bottom down in the heart, yeah, we people and we got something to laugh about in our head, yeah. But it's all good, we can't take it when we're dead, yeah. Laugh now, yeah. Cry later. Now you don't even have to cry, even if you're not a hater. You could cry, yeah. You could cry, it's okay, you could see what it's like on the Chris side when I'm, yeah, really fucking high, losing my mind, yeah, crying inside, but I'm just still getting high, so I fly, yeah, way above all emotions, yeah, you know I get plans in motion, keep me floating, but sometimes I gotta cry, you won't see that unless you really close up on this side, yeah, catch the vibe,
When the only thing that matters is being together, why not bring the holidays to a Vrbo vacation home? Somewhere with more space to get even closer to the people you love.
I'm not a gangster. I'm not a gangster. Yeah. I'm not a gangster. Nah, I'm not a gangster, but I'm still hanging with the gangs, yeah, biting like some snakes, and we got the fangs, yeah, pull up right to South Korea, North Korea, Pyeongchang, yeah, we wanna bang, we wanna, boomerang, come right back around, yeah, you know we holding it down, up on this ground, we got the sound, yeah, coming out the vocals, yeah, you know that we, got the vocals, everybody that I know. Well, no, I never really met somebody only with one eye other than Fetty Wap. Yeah, Wap, what you know? Wap was the title of a song that went viral, made the fucking charts, and it stopped, yeah. And it stopped, but it started up some shit that was toxic. If I were dark, right? Yeah. Megan Thee Stallion. Hey, jump right back down the throat, yeah, you know that I'm just trying to seal up the float, yeah, like I'm the GOAT, yeah, lil body, I'm lil, yeah, I remember 2 years ago, I remember like 3 years ago, listen to Lil Yachty, yeah, Lil Yachty, yo, like who the fuck is this Shotty, yeah, Shotty, he just shooting up the bullets, yeah, bullets, I'm growing up around some homie with the mullets, yeah, he sounded nice, Lil Yachty, but he really caught my eye with the boat, and I was like, yo, I gotta come in with style like him and float, Oh, there we go. Hey guys, I got it open.
Building your business online takes effort, and when it's ready for the world to see, that's where Google Ads helps. Say you're an online fashion brand with this season's hottest hats. When she searches for one, your ad will appear alongside her Google results, making sure that what you offer is seen by the right people right when they need it. Have a new collection? Show it off to your next customers with beautiful banner ads running on the...
We're all over the place. Okay. One more rap, maybe, dude. I got to. It's practice. Wow. Got a friend in the, his name is Gunny. Yeah, you laughing right now, but you think that it'd be funny. New bitch, and she cute, yeah. And she 20, yeah, and she 20. Right now that you laughing, that you think it might be funny. But my boy got a German Shepherd puppy, and his name is Gunny. But I like thinking about things that be gummy, like the gum, plastic, yeah, it's where it really came from. Add the sugar, add the fructose, sounds nice, yeah, suit those that like to use the science lingo. Whenever you get in the books, it's just how things go. But when you get to the details, yeah, things slow down when you really hold it down on the ground in the terms of other people right before, like Einstein, yeah, he was like numbered something, I don't even know, yeah, I'm coming in worse than Einstein, yeah, and I'm coming on my Einstein, yeah, Einstein captured a quantum tunnel, yeah, I grew up in college, you didn't drink, I drink funnels, yeah, something like that, yeah, you know what I'm doing, and I like to do it fresh, yeah, I don't even have to think about my next step, why, cause I'm just rapping on my breathing, on my breaths, yeah, getting up the reps, yeah, getting up the reps, like I'm playing on the benches, yeah, bench press, yeah, do another rep, cause I'm working on my chest, and I grew up in the trenches, is what the some will say, yeah, I grew up a little bit different way, yeah, so I'm just coming out here to play, yeah, rapping out is what I do, almost every day, yeah, yeah, We're just gonna get nasty at this shit.
2020, that's it. Calling anyone with grit. Change this, change that, but don't ever quit. 2020's done. A new era has begun, so keep pushing forward, because this is 2021. The future is still ours to win. Make a different future. Start different at GoDaddy.com.
GoDaddy. Yeah, GoDaddy. 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 Go. Yeah. Go. GoDaddy. Go. Yeah. Go. Yeah. Go. Yeah. GoDaddy. Go. Yeah. When I was watching the Super Bowl, I saw GoDaddy. Go. My dad made a joke. Go, daddy, go, yeah. It was something about a girl. Oh, she had big tits. Yeah, I'm getting lit. You know, we flow, go, daddy, go. Build a website on the web. Sounds real nice, but you gotta pay yearly, yearly, yeah. Go daddy go, go daddy go, go daddy go, go daddy go. Ayy, trying to find my peace, I'm smoking up on leaves. You know that I'm just trying to do it for relief. Trying to come in, I don't wanna laugh if I'm thinking about the queef, but I gotta get out sheets. Gotta get right out the sheets, yeah. You know that I'm practicing the shit up right at week, yeah. Coming with the strong bond, but I ain't got no time for the week, yeah. This week got like 4 hours of sleep, yeah, every night, every day. I was working out, yeah, something like that. Go daddy go, yeah, go daddy go, go daddy go, go daddy, go daddy, go daddy go. That one's fire right there. Go daddy go, yeah, go daddy go, yeah, go daddy go, yeah, go daddy go, yeah. Go daddy go, like the river you can flow. Go daddy go, yeah. I remember watching the Super Bowl. Go daddy go, my dad made a joke, yeah. Go daddy go, talking about the commercial. Go, yeah. Go, yeah. I don't even think you really wanna see what I know, no. They just manipulated my mind, yeah. Watching Go daddy go, all up on the Super Bowl. They just used a girl with big tits and drop my jaw, yeah, you know that I'm Jewing, I'ma pop it off, yeah, pop it off in the rap game, but I'ma just talk my shit until I talk it off, yeah, cause I'm fired up. How the fuck you gonna let that shit be on TV, yeah, how the fuck you gonna let that shit be on TV? I've been out in Spain and India, and they see me pulling up in the CD, in the street, yeah, in the street when I'm rapping, and I got the music behind me, you know, I'm hard to beat, yeah, cause I'm just pulling up. I don't want no beef, yeah, don't want no beef. Look at me, I barely got no meat, yeah, all up on these bones, and I'm using my phone, trying to use my dome to get the guap, and I wanna stack it up real big, yeah, I don't even know what I want, but just put me at the top, yeah, put me at the top, and I don't wanna have to stop rapping, cause I wanna mix about how I'm fired up, yeah, I wanna mix it up about how I'm fired up, yeah, you know that I'm just trying to show you that I'm living it up, not expired up, but they really can't have the commercials
Do you want to build
on
a cybersecurity
TVs.
product to prevent email phishing? Join me on this episode.
I've been out in places they wouldn't put that shit on TV. Let's watch this shit right now. Asymptotic freedom. Let's exercise this. GoDaddy Super Bowl. 2013 maybe? 2005? Shit. Yeah, let's check this out. This shit might be it.
Ms. Capelli?
Yes, I'd like to be on a commercial.
What will you be advertising?
GoDaddy.com.
Oh.
It's a website where you can register .com names for only $7.95 a year.
And what exactly will you be doing on this commercial?
I could do a routine where I went like this.
Yo, and I'm watching this shit.
You realize that you're upsetting the committee.
I'm sorry. I didn't mean to upset the committee.
May I suggest a turn?
Oh, man, that shit is nuts. Wow. That shit's fucking wild. Yeah. Yeah. Yeah, yeah, yeah. Go, daddy, go. Go, daddy, go. Go, daddy, go. Go, daddy, go. Yeah. You already know.
Yes, I'd like to be on the commercial.
Yeah,
What will you be advertising?
GoDaddy.com.
Go, daddy, go.
It's a website where
I
you can
remember back in the day, I watched the Super Bowl. Yeah, go, daddy, go. Yeah, go, daddy, go. Go, daddy, no.
On this commercial.
I could do a routine where I went
My
like
dad, he
this.
wanted to crack a joke. Yeah,
Surely by now you must realize that you're upsetting the committee.
I'm sorry. I didn't mean to upset the committee.
Go, daddy, go.
May I suggest a turn?
Go, daddy, go. Go, daddy, go. Go, daddy, go. Go, daddy, go. Yeah, you already know. Rapping on the beat, yeah, I'm a flow. Go, 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 daddy, go. Go, daddy, go. Go, daddy, go. Yeah, I remember back in the day, I watched the Super Bowl. Yeah, go, daddy, go. Yeah, go, daddy, go. Go, daddy, no. Oh, man, no. This will be hilarious. Yeah, yeah. Yeah, yeah, yeah. Go, daddy, go. Go, go, daddy, go. Go, daddy, go. Yeah, I remember growing up watching the Super Bowl. Go, daddy, go. Go, daddy, go. Yeah, go, daddy, go. You know that I'm rapping with the beat in the background. Yeah, and I steady flow. Go, daddy, go. Go, go. Oh, daddy, no. Bubba mad. Yeah, 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 yeah. Oh. Go, daddy, go.
I'm sorry. I didn't mean to upset the committee.
Yeah. Go, daddy, go. Go, go, daddy, go. Go, daddy, go. Yeah, I remember growing up watching the Super Bowl. Go, daddy, go. Go, daddy. Nope, that was trash. Go. Yeah. Yeah. Go. Daddy, go. Go, daddy, go. I remember growing up watching the Super Bowl. Go, daddy, go. I remember my dad with a joke. Go, daddy. Oh shit, oh daddy. No, what they putting up on the TV? Yeah. Go, daddy, go. Yeah. Manipulate my mind with a girl who's got huge tits, yeah. Huge tits, just to prove you, even back in 2005, they were lit. Go, daddy, go. I already had the road paved out. Let's go, go, daddy, go, yeah. Go, daddy, go. I remember growing up watching the Super Bowl. Go, daddy, go. Oh, yeah. Oh, daddy, no. What you even gonna do? Go. Yeah. Go. Daddy, go. Go. Daddy, go. I remember growing up watching the Super Bowl. Go. Daddy, go. I remember my dad made a joke. Go, daddy. Oh shit, oh daddy. No, what they putting up on the TV? Yeah. Go, daddy, go, yeah. Manipulate my mind with a girl who's got huge tits, yeah. Huge tits, just to prove you, even back in 2005, they were lit. Go, daddy, go. I already had the road paved out. Let's go, go, daddy, go, yeah. Go, daddy, go. I remember growing up watching the Super Bowl. Go, daddy, go. Oh, yeah. Oh, daddy, no. What you even gonna do? Oh, yeah. Oh, daddy. Daddy, go. Oh, yeah. Oh, daddy, no. Go, dad, he made a joke. Go, daddy. Oh shit, oh daddy. No, what they putting up on the TV? Yeah, go, daddy, go, yeah. Manipulate my mind with a girl who's got huge tits, yeah. Huge tits, just to prove you, even back in 2005, they were lit. Go, daddy, go. I already had the road paved out. Let's go, daddy, go, yeah. Go, daddy, go. I remember growing up watching the Super Bowl. Go, daddy, go. Oh, yeah. Oh, daddy, no. Daddy, go. Oh, yeah. Oh, daddy, no. Go. Yeah. Go. Daddy, go. Go. Daddy, go. I remember growing up watching the Super Bowl. Go. Daddy, go. I remember my dad, he made a joke. Go, daddy. Oh shit, oh daddy. No, what they putting up on the TV? Yeah, go, daddy, go, yeah. Manipulate my mind with a girl who's got huge. Yeah. All right, that was insane.
Foraged.
Oh yeah, I like this.
You know, they gab.
We are a place where creative dreamers go to learn their craft. We are the people who fill the world with energy.
They fished, they hunted, they practiced whole animal cuisine. You know who I'm talking about? You guessed it. Them. My ancestors. The enslaved Africans of the American South.
Yeah, they did real human shit.
One
they didn't
side,
use phones.
my great-great-great-grandmother Hattie, born a slave in Alabama.
Alright, this is already
the other
too much
side,
out of context.
my great-great-great-grandfather Edward, born a slave in Virginia.
He's talking about food, though.
Now, what do slaves have to teach us about food in 2016?
You need
Their
slavery
culinary
for food?
knowledge
That's
has the
huge.
power
Hold up.
to say, what do slaves have to teach us about food in 2016? Their culinary knowledge has the power to save lives, to empower the oppressed, and restore financial and cultural capital to people of color living today. To learn this tradition, I spent 10 years to become the first black antebellum chef since the Civil War. I had to go to the Old South, which is not very different from the New South, but we'll leave that alone. You know, the place where flags and statues don't come down without a fight. But the bottom line is, I began a project called The Cooking Gene. Yes, I picked cotton for 16 hours, it sucks.
Wait, what is this?
Lives, to empower the oppressed, and restore financial and cultural capital to people of color living today. To learn this tradition, I spent 10 years to become the first black antebellum chef since the Civil War. I had to go to the Old South, which is not very different from the New South, but we'll leave that alone.
Antebellum chef.
You know, the place where flags and statues don't come down without a fight. But the bottom line...
What's this right here? Wow, right here, no shit. Taste Southern food. Good for this guy. He's on a mission. What is this right here? The Curse of Salem? I live in Salem. What the fuck? Why is this coming up? It's a mystery. This is an ad, hopefully. Alright, let's focus. Don't let what? Impatience? Oh, fuck. No shit. What is this? The mystery box. Jing-a-ling-ling-ling. Don't let what? Don't let her out. Oh, fuck, dude. This shit creepy, yo. Hell no. Fuck this. Fuck that. Fuck that, yo. Ah! I have no trauma of dolls, but, like, fucking, those movies are good. Not those movies. That one, yeah, that one might be a good one. Emotion. Cardinal. Alright, let's... Oh, yeah, that shit's crazy. Alright, we're just gonna start over. Go, daddy, go.
You know, the place where flags and statues don't come down without a fight.
America.
But the bottom line is, I began a project called The Cooking Gene. Yes, I picked cotton for 16 hours. It sucks. I began a project called The Cooking Gene.
16 an hour? Shit.
Where I explored my food and family routes across.
Damn, bro. I fucking went to India and I was with the... I explored a potential property for cotton and have video on my social media with it. Basically, $16 2 days or a day.
Down without a fight.
It's fuck.
But the bottom line is, I began a project called The Cooking Gene. Yes, I picked cotton for 16 hours. It sucks. I began a project called The Cooking Gene, where I explored my food and family routes across the Old South. And I thought if I cooked for people, if I actually had them cook and argue and fight and not have a kumbaya moment, but actually work through their differences, we could actually come up with something new. And you know what? When you call your cuisine soul after something metaphysical, I figure it has the power to transcend difference and work its magic. So, our theme today here is dream.
Dream.
I can't think of a bigger dream than Dr. King's vision of the table of brotherhood. And it's not a metaphor. I've actually seen it. See, that's one of 4 remaining slave cabins on a historic plantation in North Carolina, where in 2013, myself and a group of other black interpreters cooked a meal for 150 people of all different colors and backgrounds. And you know what? The main ingredient that day was mutual respect. We sat down with Southern white folks as cousins rather than combatants.
Good for you, man. That's
you know what?
insane.
The ancestors who lived in those cabins,
how do you, like,
they could never have dreamed
your ancestors.
of a day when they would be honored by a group of people of different backgrounds sitting together at the same table of brotherhood. So my message today is, you have to keep cooking and eating and dreaming.
Right.
Thank you.
Keep cooking, dreaming, and eating. All right, thank you, sir. I actually got to write that down. That's pretty essential. The Holy Trinity right there. Yo, I like how it was 3 things, too. That's actually really funny. $12/29/2020, 9:46 p.m. EST. What up, bros? Cooking, dreaming, eating. Actually, maybe you should even do that in that order. Cook the food and dream about it first. Shit might taste better. Not taste better, but you get something in there. Very interesting.
Defeat COVID-19.
Not taste better. Cool. This year's biggest breakthrough in physics? Oh shit. Oh shit. 9 minutes long. Whoa, end of the black hole information paradox. Yes, my eye's a black hole.
what would happen if you fell into a black hole? If you'd asked Albert Einstein, he would have told you that according to his general theory of relativity, you'd be sucked into the black hole's singularity.
We're stuck in Einstein's black hole.
Point where space-time curves steeply inward and all the laws of physics seem to break down. After that, nothing can escape. In the 1970s, Stephen Hawking took a semi-classical approach to black holes. Bringing together quantum theory and Einstein's relativity, he proved that black holes emit a small amount of heat that eventually causes the black hole to evaporate. Still, according to Hawking, if you fell into a black hole, you and your particles would be lost to the universe forever. This is Don Page.
Holy fuck.
He was a postdoc with Stephen Hawking, where they became friends,
So
despite
I'm
the fact that they
forever with
ultimately
Einstein
landed
and
on
Hawking
either side of one of the
and
most
Tesla,
controversial debates
Soulja
in
Boy.
modern physics.
I looked at Hawking's argument and I became not convinced by it.
Hawking's work implied that black holes violated a central principle of quantum mechanics, called unitarity, which says that the present always preserves information about the past. So how could it be possible that black holes destroy information? This
just
became
bring
known
everything
as the
up.
black hole information paradox, and for
Wow.
decades, it made physicists queasy. According to Page, if you were to fall into a black hole, you wouldn't be gone for good. Particle by particle, the information needed to reconstitute your body would reemerge.
Well, it would be highly scrambled by the black hole. It'd be much worse than even, if you just cremated the body and it turned into smoke and ashes. But, another analogy is if you burn up a book and you have all the ashes, the information
Say
is
this
still
again? What?
Well, it would be highly scrambled by the black hole. It'd be much worse than even, if you just cremated the body and it turned into smoke and ashes. But, another analogy is if you burn up a book.
Holy fuck, I'm literally cremating my body. I'm smoking ashes. That's kind of what I'm doing right now, and mentally, subconsciously, just like with this video. Because if a fucking loud bang occurs,
You have all the ashes. The information is still somewhere there, is somewhere in the universe, we believe.
The key to understanding
ashes. But, another analogy is if you burn up a book and you have all the ashes, the information is still somewhere there, is somewhere in the universe, we believe.
Right, it could be a
The key to
story.
understanding why the
Holy
information
fuck.
is preserved lies in a process called quantum entanglement. When black holes emit radiation, that radiation maintains a quantum mechanical link to its place of origin. If
Wow.
you tried to measure the radiation or the black hole separately, the information would look random. But when you look at them together, they exhibit a pattern.
If somebody took a coin and cut it in half, and then you sort of shook it up and put it in two envelopes and sent it off to two people, then of course there would be what we call correlations in it. If one person gets a head, the other person would have tails. And this quantum entanglement is like that, except it's even more subtle.
This is the Page curve, which he created to track changes in the entanglement between a black hole and its radiation as it ages. The degree to which the information is entangled is called its entanglement entropy. At the start of a...
Whoa. Entanglement entropy. So, whoa, hold up. God is...
between a black hole and its radiation as it ages. The degree to which the information is entangled is called its entanglement entropy. At the start of a black hole's life, its entanglement entropy is 0, since it hasn't emitted any radiation. And at the end, its entanglement entropy is 0 again, since the black hole has evaporated. But in between, as radiation trickles out, the entanglement entropy grows. Page showed that, in theory, information can escape from a black hole.
Wow.
In a series of groundbreaking papers, physicists have shown that the entanglement entropy of black holes really does follow the Page curve.
These calculations give more evidence that indeed the information does come out, but the details of how that actually happens and still remain to be.
So are you telling me that it's like it's institutionalized, these quantum entanglements with historical figures and people and natures and science?
And of course it raises the picture that maybe space-time itself is not fundamental. Maybe there's something deeper than space-time, and maybe the basic quantum description will involve something that's not space and time.
Right.
So I think there'll be parts of the puzzle
We could do
I
some
think that'll
flying.
persist for many more decades.
Right. Yeah, I got you. Thanks. Look how this video cut out too, yo. This is definitely
Deeper
designed
than
for me.
space-time, and maybe the basic quantum description will involve something that's not space and time. So I think there'll be parts of the puzzle I think that will
It's
persist for many more decades.
in the heart and mind, baby. Wow.
Another puzzle that's baffled the scientific community for decades is superconductivity. When various solids are cooled to extremely low temperatures, they can conduct electricity without losing energy. This happens because the freezing temperature allows electrons to move slowly enough to overcome their natural repulsion with each other.
Holy fuck, yo.
When various solids are cooled to extremely low temperatures, they can conduct electricity without losing energy. This happens because the freezing temperature allows electrons to move slowly enough to overcome their
So
natural
if I act
repulsion
cold
with each
as
other,
fuck to people,
and they begin to form pairs.
then I form pairs with people.
Like any good couple should, they balance each other out and begin to move in the same direction.
No shit.
When this happens, electrical resistance disappears. This is what makes superconductivity the holy grail of energy efficiency. If only scientists could overcome the limitations of temperature. This is Ranga Dias. This year, he and a team at the University of Rochester created a metallic compound that for the first time exhibited superconductivity at room temperature.
So you have a very small two diamond tips that's sitting opposite to each other.
What?
That for the first time exhibited superconductivity at room temperature.
So you have a very small two diamond tips that's sitting opposite to each other, and then you
Two
your
diamond
sample that
tips.
you need to study in between those diamond tips, so you can apply force mechanically.
Two diamond tapes. Yo, he's literally talking about how we going diamond. We going diamond. Looted. Yeah. Yo, we getting looted. Yo, no way. So right now I emerged through the beginning of these two tapes.
Mechanically.
Dias's team applied pressures almost as extreme as those found at the Earth's core.
Wow.
They did this by crushing the compound inside a microscopic niche they carved out of a diamond anvil. Then they triggered chemical reactions with a laser beam.
Wow.
So that way, we were able to really find the room temperature superconductor. You know, it's under pressure, right? What we have found is under pressure. So somebody can argue that, okay, so you went from one extreme to another extreme. So who cares? Or, you know, what's the big deal in that sense, right? But I think there was a time that we were, even the scientists were thinking that room temperature superconductivity is not possible.
No.
To be honest, the very first time when we saw this one, I didn't really believe it. I was like, okay, this is too good to be true. And why we are seeing this nice resistance.
Right.
Everybody, around
No
the world,
shit.
Contact me via email or phone calls, and they were very excited. And this is a landmark discovery. But there are a lot of
Wow.
a lot of work to be done.
Right.
Because
He's very well
even though we
spoken.
know the initial composition, what are the material that we put together to pressurize
So y'all
it,
trying to
but
test
we
me in
don't
what I'm
know
doing?
Actually, what it is really, what the sample is superconducting. So
What am I
those studies need to be
superconducting?
done.
So for now, levitating
I don't
trains,
know.
lossless power transmission, and perfect energy storage are still utopian dreams. But
Wow.
Dias believes they're not far off.
Right.
would
I
say
agree.
I'm
I
very
agree.
optimistic.
Shit's
I
not
would
too
think
far
that
off. We
yes,
can get there.
yes, may be able to get to a real application.
A real application. Fast radio burst. No way.
In 2006, an astronomer detected a brief and extremely powerful radio signal coming from a distant galaxy. Over the next few years, dozens more were observed.
Wow. 2006, I was in the talent show and I fucking did karate on
Astronomers
stage.
created wild theories trying to explain them.
Alien
This year, a fast radio
civilizations.
burst was observed again, but this time it came within our own galaxy.
The Summer Triangle,
Just a
I
millisecond,
literally came to the
source emitted
conclusion
100
aliens are
billion
real.
times more power than the sun. Brian Metzger and his colleagues at Columbia University analyzed the data and found the source.
Wow.
A magnetar
The what?
than the sun. Brian Metzger and his colleagues at Columbia University analyzed the data and found the source. A magnetar.
A magnetar. A fucking magnetar, dude?
So neutron stars form.
Are you serious, yo? What, dude? Yo, no way, dude. They totally got me right here. Magnetar? A neutron star? No, dude. Wait, what? A neutron star? What? No, alright, that's still lit, yo. I'm totally thinking Magmar, yo, cause y'all really got me on the grasp. Magmar, yo, it's a Magmar. What? What? Yo, what? It's a Magmar? Insane.
At the end of their lives, the core of the star collapses in and
Right.
forms a neutron star.
Wow.
A very compact object about the mass of our sun, but the size of New York City.
No
and then
shit.
the outer layers of the star explode as a supernova. So a neutron star is what's left over. And magnetar is an extreme version of a neutron star with a very strong magnetic field. So there was a magnetar in our own galaxy that produced a flare of X-rays, and arriving on Earth at essentially the same time as the X-rays was a burst of radio emission, which if we'd put it into a different distant galaxy would have looked a lot like a fast radio burst.
Right.
We were, identifying that it came from a magnetar within our own galaxy. So that's pretty good circumstantial evidence, that
I'm within your guys'
produce
galaxy.
Fast radio bursts. Fast radio bursts are great because we can see them almost to the edge of the universe. And so in
Whoa.
addition to actually understanding what's producing them, one of the exciting things is we can use them as probes of the state of matter between us and the radio source. And so I think
Wow,
that's,
and the
very
radio
exciting
source.
as we
I'm
discover
listening
more and more
to
fast
this
radio bursts. And if it
through a
turns out
radio
that
source.
they come from magnetars, then we're also probing where all the magnetars are in the whole universe, which is something we didn't think, would have ever been possible.
Where are the magnetars, yo, in the universe? What? Yo, no way, yo. And there's only 3 of them?
Really, what's the sample?
Are you serious? There's 3? Wow, yo, this isn't. Oh. Wow, so cool. This is insane. I'm the center of this right now. This is phenomenal. I'm a neuron. I am a magnetar. I'm a magnetar, dude. What, dude? Oh, man. Got me confused a little bit. Science stuff. Magma. Samosa. Yeah. Philosopher Chris Payne and Samosa. Yeah. Let him know. Yeah. You. Oh, he just wants the foods. Right. Get the leaves out your mouth. Yeah. Come here. Yeah. Good boy. Yeah. Coming in with my Dalmatian. Yeah. Coming in with my Dalmatian. Yeah. I'm a motherfucking alien in my space station. Yeah, all in my body. I got my Dalmatian right and shot it. Young Samosa. Yeah. Young Samosa, ticket with bitches and I'm drinking mimosas. You know that I do the mosa. Can't wait to get a dope house and play the hoster. Oh yeah, hoster. Young Samosa, you know we do the Yeah, Young Samosa. Staying post up. Yeah. Look at the spots. Yeah, look at the spots. His pretty face and mine too. You know that we hot. Yeah. You know that we hot. Look at the spots, yeah. You know that he just knows how to chill right up on the block, yeah. Young Samosa, yeah. Ticket with bitches, we drinking mimosas. All up on the beach. That's just a dream right now. It's not hard to reach with Samosa. Yeah, keeping it young, you know we out having the fun, yeah. Young Samosa, yeah. Oh, good boy. You're looted for that. Yeah. With the fucking bros and we got Young Samosa. Yeah. What the fuck else am I supposed to do? Yeah, bring up all the topics that maybe you didn't even knew or you looking to try to go right through. Yeah. Awesome time that you could spend growing, showing. I'm showing all the science, and that depends what you think that you want to see. I like swimming right in the sea verbally. Yeah, that's where I be. Yeah. That was lit. That was looted right there. I was sick. Yeah, Young Samosa. This is first rap one while I'm holding him. Yeah. Yo, I'm gonna end that, and so I have to check that out. That's actually straight fire. Oh, we got 2 viewers on Twitch. Maybe I'll just keep it going then. I didn't even know. Yeah. That was straight fire though. Rapping with Samosa. Like, look at this highlight back. Yeah, Young Samosa, we got the spots. Oh yeah, we can do this right here.
You're alluding to that.
Yeah. With the fucking bros and we got Young Samosa. Yeah. What the fuck else am I supposed to do? Yeah. Oh no, it cut out. Alright, you guys are getting that. Yeah. Oh, okay, this is where it goes in.
Chris Payne and Samosa. Yeah. Let him know. Yeah. Oh, he just wants the foods.
That's only the small window I can see it in right now. How do I zoom in? Yeah. So I'm finding a beat here.
Yeah.
This is too funny, yo. I mean, yo, I'm sorry for whoever's watching, but this is like what I do.
Yeah. Coming in with my Dalmatian. Yeah. Coming in with my Dalmatian. Yeah. I'm a motherfucking alien in my space station. Yeah, all in my body. I got my Dalmatian right at the shot it. Young Samosa. Yeah, Young Samosa.
Still alive.
Bitches and I'm drinking mimosas. You know that I do the mosa. Can't wait to get a dope house and play the hoster. Oh, yeah, hoster. Young Samosa. You know we do the... Yeah. Young Samosa. Stay in post up. Yeah. Look at the spots. Yeah. Look at the spots. His pretty face and mine too. You know that we hot. Yeah. You know that we hot. Look at the spots. Yeah. You know that he just knows how to chill right up.
Yeah.
Young Samosa. Young Samosa. Take it with.
Okay.
Look at the spots. His pretty face and mine too. You know that we hot. Yeah. You know that we hot. Look at the spots.
Signal coming from a distant galaxy.
Spots. Yeah. Look at the spots. Look at the spots. His pretty face and mine too. You know that we hot. Yeah. You know that we hot. Look at the spots. Yeah. Spots. Yeah. Look at the spots. His pretty face and mine too. You know that we hot.
Too funny, yo.
Quantum communication and quantum computing. And it's particularly designed for people who want to learn about quantum computing.
Hey, crazies, it's time for photons. This episode was made possible by generous supporters on Patreon. I imagine a lot of you feel like you know what a photon is. It's just a packet of energy or whatever. But you know what happens when you assume. You make a mistake. Sometimes. Calling a photon a packet of energy isn't wrong. It's just not very useful because everything is a packet of energy.
So what do you say?
I have something in this box. Can you guess what it is?
Language.
No? Here's
Society.
a hint. It's a collection of atoms.
Oh.
Did that help?
Maybe.
Probably not.
Is it a gas or poisonous?
It's a squirrel.
Oh,
My
it's my
point is,
nuts.
there's a better way to describe photons. Yes, it's a packet of energy, but it's the details about that energy that make it a photon. How should we tackle this? I think the top-down approach is going to work best. Reductionism.
Whoa.
Basically, it's the idea of starting with something normal-sized and then breaking it up until you find its smallest pieces. What you might call its elementary pieces. Honestly, this is how we came up with quantum physics in the first place, so it seems like a great place to start.
Right.
Elementary particles are like bite-sized pieces of something ordinary. Kinda like how this video series comes in bite-sized pieces of quantum physics.
Yeah.
It's almost like I planned this or something.
No way.
Anyway,
Fuck,
a
dude.
photon is the smallest piece of light. Like you might find coming out of a flashlight, like this. Can I have the flashlight? Do you remember what happened the last time I gave a flashlight to a clone?
A
What
what?
this button does. Turn it off, turn it off!
Sorry.
Behave.
Okay, I will.
What if I promise to behave?
Yeah.
Alright, we'll try this one more time.
Alright, my bad.
Okay, back to business. A beam of light is one of those normal-sized things I was talking about earlier. It's something we can see with our eyes. Something the size of us. But if we're going to understand it like a quantum physicist, physicist. We need to break it into smaller and smaller parts until we find something we can't break anymore. Light beams are giant collections of many electromagnetic waves. If we focus on one of those waves, we can see a repeating pattern.
Huh.
One cycle of that pattern looks like this. That's one wavelength of that wave. There really isn't anything smaller than this for a wave. Is that what a photon is then? No.
No, I don't even
We have
know
a
that.
slight problem. Light waves can be anywhere on the EM
same
spectrum,
problem.
including the low frequency end like radio waves.
Low
A
frequency
single
end
radio
like this,
wavelength
or
can
that.
be as large as a small city. I find it hard to believe that a single photon could ever be that big.
Hold on,
Maybe
what?
we're looking at light waves can be anywhere on the EM spectrum, including the low frequency end like radio waves. A single radio wavelength can be as large as a small city. I find it hard to believe that a single photon could ever be that big. Maybe we're looking at this all wrong. I seem to remember saying something important earlier. Yes, it's a packet of energy, but it's the details about that energy that make it a photon. Right, this isn't about the space something takes up. Elementary particles like photons don't really have any size anyway. This is about energy. It's the energy we have to break into pieces. Let's start with a standard incandescent light bulb. This one is 60 watts.
Right.
That means it transforms 60 joules of electrical energy into heat and light every second. Incandescent bulbs are terribly inefficient though, so only about 10% of that actually becomes light. When you turn it on, 6 joules of light leave the bulb every second. But that spreads out in all possible directions.
6 is the
Eventually,
devil
we're
number,
going to see
so
gaps
it's 6
between- when you
joules
turn
because
it on,
everybody's thinking of like the fucking vape jewel right
6
now.
joules of light leave the bulb every second. But that spreads out in all possible directions. Eventually, we're going to see gaps between those pieces. Those tiny little pieces of light energy are called photons, but the amount of energy they have is very small. You can calculate it using E equals hf. The h is Planck's constant, which is extremely small. The f is frequency, which tells you what type of light it is. And in the
Planck's
visible range,
concept.
it tells you color. So the energy of a photon
Stranger Things.
is a constant times its color. For that 60-watt light bulb, that's 10 million trillion photons per second.
Holy
Woo,
fuck.
that's a lot of photons. Since individual photons don't have that much energy, you have to get really far away to notice the gaps between them. Let's say you move away from the sun at an unimaginable speed and somehow manage to avoid any of Einstein's relativity.
Right.
Eventually, way out in space, you'll start to notice the sun's light flicker. What you're seeing are individual photons. Actually, the human optic nerve doesn't send a signal to the brain unless 9 photons arrive within 100 milliseconds. You have to ruin everything, don't you? I don't ruin things, I make them more accurate. Alright, so humans can't see individual photons, but that actually explains a few things. If you move away from the sun like we did earlier, you can't see the flicker of the photons. So at about 750 light years, the sun's light will just fade away into the blackness of space. That's why the night sky is mostly black, lit by just a few nearby stars.
Wow,
the rest of
no
the photons are just too infrequent for us to see.
No
So what the
shit,
heck is a
right.
photon?
You gotta take it
Right.
to
Stay
real
focused, Nick. There are a lot of little packets of energy floating around in the universe. What makes them photons is all in the details, my dear crazies.
Whoa.
Photons have a specific set of
Holy
properties
fuck.
that make them photons. A charge of 0,
Yes.
a spin of 1
No
with
way.
2 possible orientations,
Wow,
and
left and
lastly,
right.
a rest mass of 0, which
Damn.
makes many things about photons possible. Their speed of almost 300 million meters per second, their energy being proportional to their momentum, and their inability to experience time or space.
Wow.
Any little packet of energy with those properties is by definition a photon.
Yeah.
So, got any questions? Please ask in the comments. Thanks for liking and sharing this video. Don't forget to subscribe if you'd like to keep up with us.
Actually, yeah, this one I want to see what's good. Is it correct to say, in my opinion, I'm a photon then? Or do, in this situation, would I be fluctuating? Fluctuating. Yeah. Thanks, man. Really got that off my chest. Lil Pump. I want to cry. That's actually just really funny. I'm crying because low-key I don't know if he'll answer and have a legit answer, and I could get fucking trolled. Cyberbullied, yo. The Alpha Centauri system. Now we go in this. I want the simple method, and I don't want State Farm. Yeah. Fuck State Farm.
Oh, just
not
watching
fuck
from State Farm,
but just like, come on.
Down saved me so much on my
Still,
insurance.
you guys still
Everyone
make
gets
ads
surprisingly great rates
everywhere.
with State Farm.
In the late 1800s, physicists were working to mathematically describe something called the black body spectrum. Above absolute zero,
black
every
body
molecule
spectrum.
and atom in an object are wiggling around. As they wiggle, they emit
Wait,
radiation.
what? Why'd they call it that?
In the late 1800s, physicists were working to mathematically describe something called the black body spectrum. Above absolute zero, every molecule and atom in an object are wiggling around. As they wiggle, they emit radiation in the form of electromagnetic waves.
Yeah.
Faster wiggles release shorter wavelengths, and slower wiggles release longer wavelengths.
Right.
A collection of particles will release a mixture of wavelengths that's dependent on the temperature of the object they make up.
Huh.
This is because temperature is a measure of how quickly, on average, all of the particles in an object are moving.
Whoa.
At the time, they were using something called equipartition theorem to figure out what sort of radiation should be coming out of an object at a given temperature. The idea was that particles with radiation should be coming out of an object.
Spectral radiance and wavelength. And they go to zero, or?
At a given temperature. The idea was that particles wiggle in every way that it's possible to wiggle, and the energy is distributed amongst all of the wiggling variations. These wiggles are also called energy states. This works really well at low temperatures, but as you approach temperatures above a few hundred degrees, the theorem totally stopped working.
Wow.
It gave an answer that was literally infinitely too high. This was because the theorem assumed there was no minimum energy state.
I'm infinitely too high.
A bit smaller. When they went to distribute the energy among all the possible states, too much energy ended up in those infinitely small wiggles.
Oh, wow.
This was obviously far off from what was measured, so they knew that something was wrong, but nobody really knew why.
Ultraviolet catastrophe?
Then, in 1900, Max Planck figured out the solution.
No shit.
In a moment of frustration, he decided to see what would happen if instead of infinite states, there was some minimum, and all of the other energy states were just a multiple of this minimum. And it worked. What went on to be called the Planck law was able to correctly predict the blackbody spectrum even at really high temperatures. And that minimum energy is now called the Planck constant. What Planck didn't know at the time was just how pervasive this odd little number was.
Wow.
His discovery paved the way for the quantum revolution, and that constant shows up all throughout quantum theory. Heisenberg's uncertainty principle, the de Broglie wavelength, Schrödinger's equation, even the Dirac equation all use Planck's constant or the reduced Planck's constant. When Planck first used the constant, he didn't actually think it would exist as a physical number, and assumed it would have a value of 0. This would mean that the infinite states were still possible. But it has been measured many times experimentally to be non-zero, meaning there is actually a minimum energy. If you'd like to learn more about
What?
Planck's constant and the
What?
aftermath
That
of
was
his
it?
discovery, energy theory. Heisenberg's uncertainty principle, the de Broglie wavelength, Schrodinger's equation, even the Dirac equation all use Planck's constant or the reduced Planck's constant.
Wow, okay.
When Planck first used the constant, he didn't actually think it would exist as a physical number, and
Right.
assumed it would have a value of 0.
Right.
This would mean that the infinite states were still possible. But it has been measured many times experimentally to be non-zero, meaning there is actually a minimum energy. If you'd like to learn more about Planck's constant and the aftermath of his discovery, I'd suggest checking out Spacetime's video, as it does a great job of explaining all of this.
So we're
So, how do
non-zero?
we measure Planck's constant? Well, thanks to Einstein, we know that the energy of a photon is equal to Planck's constant times the frequency of the electromagnetic wave.
Einstein
So the
times
higher
the
the frequency,
frequency?
the more energy is required to produce that photon.
Philosopher Chris
To
Payne.
determine Planck's constant, we're going to need to measure the energy of a photon and its wavelength. Let's tackle measuring the energy first. We're
Philosopher
going to use
Chris
some light-emitting
Payne.
devices, specifically a few different LEDs. Because of the way LEDs
Philosopher
are made,
Chris
they require
Payne.
a minimum amount of
Philosopher
energy to
Chris
produce a
Payne.
photon of a particular
Philosopher
wavelength.
Chris Payne.
In this case, the energy is in the form of voltage applied across the LED.
Right.
Below what we'll call the threshold voltage, the LED doesn't have enough energy to start producing photons. But right as we pass that
Motherfucking Philosopher Chris Payne. Right, wow.
on the visible spectrum, red light is a much longer wavelength than green light.
Wow.
Longer wavelengths are lower frequency, so it requires less energy to produce red light than it does to produce green light. For this reason, you can see that as I turn up the voltage, the LEDs light up in sequence based on their wavelength.
Whoa.
So to determine the energy of a photon coming from each
Philosopher
LED,
Chris
all we
Payne.
need to know is what that threshold voltage is for each.
Whoa.
The setup to measure this is actually quite simple.
Okay.
I've got a variable power supply that I've connected to one LED.
Mhm.
I also have a multimeter set to read DC volts across the legs of the LED for more accurate measurement.
Okay.
It's also a good idea to add a 100 ohm resistor in series.
Hold
but if
up,
you're careful,
DC
this
volts,
isn't-
yeah. So I literally have my
I've got a
2 feet on the
variable power
ground.
supply that I've connected to one LED.
And I'm listening to
I
this
also
computer.
have a multimeter set to read DC volts across the legs of the LED for more accurate measurement.
DC, right?
It's also a good idea to add a 100 ohm resistor in series, but if you're careful, this isn't strictly necessary. Now the voltage can slowly be
resistor.
turned up until the LED just starts to emit light.
Wow.
My camera can't pick this moment up really well,
I
but
just
it's
picked
really
up
easy
light.
to see in person. Record the voltage and
Where
repeat
is
this
he?
for every
Oh,
LED.
I see it.
Now, with our energy
Whoa.
measured, we need to know the frequency of light each LED is producing.
Banfield Pet Hospital is here.
To figure this out, we'll be using a diffraction grating. A diffraction grating is a piece of plastic that has small lines cut into it that each act like a prism.
Whoa.
In my case, there's 1,000 lines per millimeter of plastic. These small cuts cause the lights to refract and spread. Just
Do
like
this.
a prism, if we shine white light on it, we'll get a rainbow.
Right.
This is
Whoa.
the setup we'll be using.
Right.
First, we have a screen which we'll be projecting our light onto. Here I'm just using my notebook, and I've added a centimeter scale ruler to help make measurement easier. Then we have a diffraction grating, which I'm using a clamp to hold.
Right.
The distance between the diffraction grating and the screen are very important, so be sure to get an accurate measurement of the distance with a ruler. To measure the wavelength of light using this setup, we need to shine a beam of light through the diffraction grating and onto the screen.
Whoa.
For monochromatic light, or light that is just one color, we'll see a spot on the screen in the middle where the light isn't diffracted, and a series of spots at regular intervals on either side where the light is diffracted.
Wow.
For white light, we'll see a white spot in the middle and a rainbow on either side. We'll be using the distance of the outside spot to the center to determine the angle between the center and outer images.
Whoa.
This angle and the distance between the individual lines of the diffraction grating can be used to determine the wavelength. First, to see how this works, let's use a laser so it's perfectly monochromatic and the wavelength is well known. When the laser is turned on, 3 dots appear on the screen.
Whoa.
If we were to use a bigger screen and project the image further, we would actually see another pair of dots.
Whoa.
The center dot is called the 0-order image, and the outer dots are the 1st-order image.
Mm-hmm.
More pairs of dots would be called the 2nd, 3rd, and so on.
Wow.
Make a mark on the page to show where the 1st-order image is, and then measure the distance from this point to the center where the 0-order image is. To determine the wavelength using this measurement, we're going to use the formula d sine theta is equal to m lambda. To find
Lambda.
theta, we use the inverse
Lambda
tan
God.
function on a scientific calculator, along with the distance to the screen and the deflection that we just measured. For our laser,
I deflected
this gives
it?
us an angle
What?
of
Say
30
that
feet,
again.
and we're going to use the formula d sine theta is equal to m lambda. To find theta, we use the inverse tan function on a scientific calculator.
Inverse
along with
tan.
the distance to the screen
So I'm inverse tan.
and the deflection that we just measured.
Wow.
For our laser, this gives us an angle of 33 degrees.
Wow.
Plugging this into our
33
equation,
degrees.
along with 1 times 10 to the minus 6 meters for d, gives us a wavelength of 540 nanometers.
Whoa, okay.
This laser is actually rated for 532 nanometers, but our measurement is pretty close. Now that we know how the maths work, let's try this again, but this time with our LEDs.
What does that matter?
Since LEDs don't put out a length of 540 nanometers. This laser is actually rated for 532 nanometers, but our measurement is pretty close. Now that we know how the maths work, let's try this again, but this time with
Yes.
our LEDs.
Please.
Since LEDs don't put out a coherent beam, we need to make a collimator. I'm just using a piece of cardboard that
The
I've cut
cross.
a hole in and covered with electrical tape to
God.
form a small slit.
Symbol of God.
Placing this in front of the LED produces a thin beam line. To help calibrate things, I used a white LED first, which gave a nice rainbow. Then I marked approximately where the 4 colors that I'll be looking for are. This way, if my colored LED measurements look far off from these, I'll know that something has gone wrong. With that done, I replaced the white
Something
LED
has
with the
gone
first
wrong.
color,
Wow, hold
red.
up,
Things
what?
here. I'm just using a piece of cardboard that I've cut a hole in
Yes.
and covered with electrical tape to form a small slit.
Okay.
Placing this in front of the LED produces a thin beam line. To help calibrate things, I used a white LED first, which gave a nice rainbow. Then I marked approximately where the 4 colors that I'll be looking for are. This way, if my colored LED measurements look far off from these, I'll know that something has gone wrong. With that done, I replaced the white LED with the first color, red. Just like the laser, 3 stripes showed up on the number line. I marked where these lines are and then repeated this for the other LEDs, making sure to carefully put everything back to exactly the same place to minimize error. Here's my results after all of the measurements. The lines from each LED are very close to the rainbow control lines that I added earlier. Now we can repeat the maths we did earlier to determine the wavelength of each LED. Here I've put them into a table next to the voltages we measured earlier.
Whoa, this is for me?
Here I've put them into a table next to the voltage we did
So
earlier.
my red chakra is a little bit above 6. 6 is like the something number. I don't know. 5 is like the school of fish, and that's my Neptune. And then my purple chakra is like the ability to think forward and shit, I guess. I don't know how to exactly say it. Like the crown chakra, so it's in 4, which is in like construct of society.
To determine the wavelength of each LED. Here I've put them into a table next to the voltages we measured earlier. We now have everything we'll need to calculate Planck's constant. The Planck-Einstein relation is written in the form of
So I'm in
frequency.
7th heaven. Okay.
The Planck-Einstein relation is written in the form of frequency and energy.
Right.
So we need to convert our voltage measurements and rearrange things a bit. To determine the energy, we take our voltage measurement and multiply it by the elementary charge constant, 1.602 times 10 to the minus 19.
Elementary charge particle.
Calculate the energy of each LED, and then start plugging things in. Solve for Planck's constant for each LED, then take an average of these values. My final value came out to 5.3 times 10 to the minus 34 joule seconds, which is only 12% off from the actual value.
What?
While this experiment may seem like a high school science fair project, measuring Planck's constant is actually a really big deal. As you saw, much of our mathematics rely on this constant, and without an accurate measure, much of our modern society that is based on the principles of quantum mechanics would stop working. In a future video, we'll be exploring how modern scientists measure Planck's constant and build an extremely accurate scale called a watt balance. Also, many of the skills that we've covered in this video, from collimating light into beams, to splitting it with a grating and carefully measuring it, will be used in future videos to build things like spectrophotometers,
Holy
or to
fuck.
analyze the light from distant stars. So be sure to check back every other Monday for all of that.
Holy fuck.
If you want to sell online, make sure you stand out.
Insane.
Go to Wix e-commerce and create a professional online store that will grab shoppers' attention.
Holy shit.
Build a state-of-the-art.
That's some cool shit, dude. Can I grow opal? What? No, that's just loot bait. He's trying to get looted off the ads, and it's a 26-minute video. He about to get his YouTube channel looted. Oh, I'm not getting put to sleep for that. Whoa, lesson 34? Hold up. What? This is okay. So literally he just whoa. Let me just show you what the fuck is this. This is why I'm doing this, and this is exactly why shit's real.
Fraction grading and the screen that we've covered in this video from culminating.
So he's like basically talking to me throughout this whole thing, and then it's like, because I'm already here living on my own star, like on my own, look through my eyes, it's a black hole. Like, you don't want to, you know, I don't know, I'm a philosopher.
Solve for
Ask
Planck's
me the
constant for
question.
each LED, then take an average of these values.
The minus 34, JS, just saying. So he said, go to the 34, just saying. Nah, not time machine. Lesson 34. Force vibrations. Wow. Western instructional television. You are watching Western instructional television. Philosopher Chris Payne. And they're waiting for me to force them vibrations out. With Philosopher Chris Payne. Yeah. With who? Okay, Mr. Miller, Mr. Julius, Mr. Caesar Summer. Produced by just like a Western Video Industries.
How do you do, ladies and gentlemen, and boys and girls and teachers? I'm Julius Sumner Miller, and physics
Fake
is my
website,
business.
not secure.
And my business today, making more noise, I suppose, or sound, or some such.
Yeah.
More exactly, this business of resonance and forced vibrations.
Okay.
Consider
Fuck.
the following.
Sorry, dude.
Which I tried on an earlier lesson to do, but with not too much success,
Nope.
for some reason.
Still here, buddy.
About this, I should say more. You know already my philosophy.
No?
Experiments, demonstrations never fail.
Wow.
For nature to do what you want her to do, you must make some very special, meet some very special requirements. If they are not met absolutely precisely, nature will not show what you want her to show. She will do something else. So if the experiment did not succeed in an earlier case, we'll try it again.
Right.
But we are forced to think of why didn't it work before. 2 forks, middle C.
2 forks. Middle C. The note.
Middle C.
Okay, lit. Okay,
We
purple.
hope they're identical.
No, they're not.
Hollow chambers,
Whoa.
resonating chambers.
Okay, I'm hollow.
I'm going to strike this one, quiet it, and we will hear that one.
Okay.
Why? This emits 256 pulses per second, which are fed into this one.
Whoa.
This picks them up
Whoa.
and is set into oscillation. Listen now. There it is. Clear
Whoa.
as the nose on my face.
Whoa.
I'm going to do it again in the reverse order. Listen. There it is. Now, how far apart could this be made to happen? Oh, great
Whoa,
distances.
the reverse order. I just took a hit of the
This is
spliff.
exactly what your ear does, and you could hear me at some great distance, I am sure.
I can, yeah.
Resonance. Resonance.
Wow.
Consider now the following. I have here 2 cardboard
I have
tubes,
resonance?
one of which slips inside the other, so that I can change the total effective length.
Right.
I am going to strike a tuning fork
Oh, I'm sorry.
and hold it in front of this open pipe, which is so long,
Thank you.
which has
Thank
a
you.
certain natural frequency.
Thank you.
I'm going to change the length by this sliding tube and hope to find a resonant length for this fork.
Okay.
Listen now.
Oh. Wow. No shit.
Yeah, there is a place. there is a place at which this length is resonant to this frequency.
Wow, no shit.
That's an open pipe. This end is open, that's open. Here is
Okay.
a closed one.
Wow, no way.
Now, it would be an interesting exercise to compare
Do I have to do this the whole
lengths
video?
of open and closed pipes for the same fork, but I leave that as an exercise for you.
Oh, same
This is
fork.
closed because it is closed on the bottom of the table.
Right.
Listen.
This is me grounded. Hmm.
Uh-huh.
Hmm.
Let me use another fork.
Yeah, do that again,
This fork
please.
happens to be what? 512. That's an octave above middle C.
512. Oh, 512. Wow.
Oh, I can't get a length there.
No, you really can't. You didn't get me.
There it is. There it is somewhere in there.
Whoa.
Let me try this open one.
Whoa, okay. Whoa.
Very
Wow.
clearly resonant. Very clearly resonant.
Wow.
Or, as I might do it, consider here. Here is a glass cylinder with some water in it.
Looks
and
like
a
God.
tight tube. And this is a closed end, so the air column here constitutes a closed tube. Let me show you resonance.
Wow.
There it is.
Yeah.
Now, what can one do with this?
Whoa.
By making certain measurements, we can determine the velocity of sound in air.
Wow.
Here is another tube.
Holy
another
shit.
fork. Oh, very clearly resonant. I hope if the tube is long enough to find another resonant length. Listen.
Not really, man. Oh.
Yeah, pretty nearly. I couldn't quite make it with the lengths available to me.
Wow.
Resonance. Resonance.
Wow.
I want to show it to you in a more delightful fashion.
Wow, no way. So you got, whoa, interesting. Yeah,
Here is
because I'm
something really
digital. I'm
enchanting.
here radio frequencies. Wow.
A wooden frame, which is hollow, so like the belly of a piano or of a fiddle.
So it's my body as an instrument to
A
talk.
tightly drawn string
Yeah.
with two bridges, one here and one here,
Huh.
so that I have cut off a certain length of string,
Uh-huh.
this long.
Oh, cool.
The string, therefore, has such a length,
No.
is under such a tension,
Right.
and is so fat.
Wow, it's so fact.
Now that string
I
has
am
a
matter of
certain
fact.
frequency. Listen.
Guitar? Oh shit.
It therefore has a certain pitch.
What?
It is resonant to a certain fork.
Wow.
Proof. I've put a little paper rider on there
Huh.
because if the string is vibrating, you can't see it. And I'm going to strike a fork and apply the end of the fork to one of the bridges. And we hope that the
And I
energy of
just
the vibrating
burped.
fork is
Except our
communicated through
food.
its stem to the string. And
Oh,
if the
my
string is
stomach.
vibrating, we would hope to see the little
My
flag
stomach
there
just,
quiver. Watch it now.
Yeah. Had gas
Oh,
come up.
yeah, I like that. Let's
Yeah,
get
I
tight
did
on
have
that
gas
again,
come up.
boys,
You do
because
like that. Is this
I
an,
like
am I a
that.
really good
And
experiment?
do you see, people, if I like something, well,
Yeah.
I might do it again because I like it, and that's
Oh,
good enough reason.
alright, sorry. I didn't mean to mess you up, buddy.
I suppose I have done this demonstration 4,782 times, and it never fails to stir my soul because it is pretty and dramatic and spirited. Watch it now. Watch.
Who, me?
Yeah,
What?
there it is. Now the question is, will this string respond to some other fork? That would happen to be B, 480. Let me try 384, which is G. Listen, watch. No. That string can vibrate 480 times per second in a natural, ordinary, comfortable, happy way.
Right,
It
yeah.
will not vibrate 384 times per second. How about 426.6? Oh, yeah, that
Right.
reminds me.
You're telling me all
I
the
find a
math
fork.
about this tuning forks and
On an
stuff.
earlier lesson, I suggested that, I said that A in America, the orchestral A, was 440 vibrations per second. And then I said that I thought that A in Europe was 426. I find it, 426.6.
Wow.
Now listen, watch. No.
What?
But 480, yes.
What? These tuning forks have a certain size, and he's talking about the frequency they emit and how much they vibrate. He knows way more specifics about this stuff. And to test those is very difficult. You have to determine what type of room he's in and like the space in the room.
I strike it.
All right.
I deliver the stem of the fork to the table.
Okay. Whoa, yummy. Did he trip out too? Sorry, did I throw you off, man? Am I talking too fast?
The table is being put into oscillation at the same frequency as the fork, which is 426.6. But the music it emits, the sound that emerges, has a little different quality to the ear.
Right.
Sure.
Wow.
A, when played on the piano, sounds different from A played on the fiddle.
Wow.
So this has a different quality. But the table is forced into vibration that many times per second. Let's take 480. Listen.
Right. No
Let
shit.
me try this table back here, which has more stuff on it. May have higher or lower pitch. I don't know.
Wow.
Very interesting.
Dang.
Now something quite enchanting. Consider the human voice, which results from the vibration of the vocal cords, the hollow cavity called the mouth,
Does it?
where the tongue is,
Okay.
where the teeth are, how the lips are held.
Whoa.
That chamber,
You
the
trying to
vocal
tell me
chamber,
I'm
has a resonant frequency.
Ha.
And I have observed over the years
Facts.
that when I try resonance at the open mouth of boys, the response is to a fork of lower frequency than that for girls. Let me show you what I mean.
What?
Listen. Well, let me try another fork. And sure enough, this is 426 and that's 480. Let me try one lower, 384.
What is going
Maybe
on?
I'm boom, boom, boom in pitch. Let me try a higher one, 512. Notice I have a strange vocal system. Resonance. Forced vibration.
Yeah, it's fucking weird. I don't want to fucking look at you go, oh.
There are some wooden bridges still.
It was actually about listening, but I wanted to see how close you were putting it, and then, you know,
No trotting. Why?
even trying to see the variables. Genuinely just curious the first two times, then you put the idea in my head, and I'm like, what the fuck?
Or consider soldiers in marching, crossing a bridge, they break up their stride. Now, where do we have some ancient, wonderful commentary of the same sort? If you read Joshua in the Old Testament, Joshua 6:20, it says something like this. The priests blew their trumpets and the walls fell down flat. And I've often wondered why the sackers of cities didn't just go around the world, the then known world, with bands and musicians playing music in order to fell the walls of the cities instead of attacking them with manpower. All right. Resonance, forced vibrations.
What?
Consider this, which is quite enchanting to look at. Here I represent the towers that carry the big, heavy cables in transmission of electric current across the country.
Whoa.
This is a cable.
What
It
country?
might be viewed as hanging like this. The shape in which it hangs is very special, incidentally. It's called a catenary. And if you look up the word catenary in a dictionary, you will find that it means chain. Now, when the wind is
Catenary.
very high, this cable could be set into oscillation,
Chains.
which is dangerous
3.
for the mechanical system, as well as for the electrical affairs. But we need to damp out that mechanical motion. And so what is done? If you look closely, next time you see these transmission lines,
You need to damp out that mechanical
observe
motion.
That there hang on the wires some system that looks like this, called a damper. Now what happens?
A
When
damper?
that cable is
Why'd
set
you
into
just damp
vast
it?
oscillation with large amplitude by a stout wind, the cable, having flexibility, as I will show you, takes up the oscillation and damps out the mechanical motion of the wire. Here it is. Here is a cable.
Whoa.
Cable damper. The wire goes through there, and now you see these are flexible, And this takes up the energy of the oscillating wire.
Wow.
So I say this business
How does it
resonance,
do that?
forced vibrations,
What is that
mechanical
used for?
damping, and the like,
And I'm
very
forced
enchanting
vibrations?
to contemplate, and
Wow.
I would invite you to think more about it.
I what?
So,
Why?
more on resonance, more on forced vibrations.
Forced vibrations are like the freedom of like the Constitution.
All this
What?
More on resonance, more on forced vibrations. Mark you. All this evidence that the natural world presents to us is gotten by one of our senses, namely the auditory, and
I thought he
all
said,
governed
"Fuck
by the
you."
reception that the eardrum gives to the variations in pulses. And I thank you for watching. More on...
You are welcome, dude. Holy shit. That was insane. That was spooky. What was his ending statement though?
Governed by one of our senses, namely the auditory, and all governed by the reception that the eardrum gives to the variations in pulses. And I thank you for watching.
Wow. Good looks, bro. The song is Spy Fingers. What? My phone. Right. Let's go into this. Just had to go in quick.
Are you that dumb?
Hey, nice band.
What's suspicious behavior? Taking pictures of cars? Taking pictures of cars? That's suspicious?
Leaning on a
It doesn't-
pole
what
might
is a
not be the
normal
most
person take
professional,
pictures of cars?
sir.
That's your one little opinion.
I literally acted it out.
I know, and it was. I am now dumber from listening to watching you act that out. Hey, Bay fam,
Unless
our
you got
sponsor,
your Pokemon Go app out, you can't
is
be
the
really
official
just leaning
horticulture
on a
partner of
pole.
Samsung, with the best LED grow lights in the world for light spectrum. They also partner
Light
with many
spectrum,
other
I
great
just watched
companies
some
and have many
videos
other
on that.
products. Use checkout code Bay Area Transparency for a 10% discount in the U.S. and 5% in Canada. If you need a package deal, use the email above and they will take care of you. What's going on, Bay fam? It's the Kid, Bay Area Transparency, back in the house with another audit. Today we're in the small city of Sausalito, California, right across the Golden Gate Bridge from San Francisco, California.
Wow,
now I know
right.
I put
So
a
I
little
wonder what
piece
the
of this
history of
audit
these
in a
places are.
compilation I did a couple weeks ago, but that was just a small piece of what's going on here. In this audit, we're dealing with an officer who has a huge ego problem, probably a little bit of a Napoleon complex, little man syndrome type thing going on. He wants to argue, he wants to say he's following me even though there is no crime, no reasonable suspicion of crime. He's trying to lie about being under a car and turn everything he can into reasonable suspicion
FBI.
enough for him to follow me around. And then I got to thinking, do we really have an officer like this on the street? Somebody who's this childish with the power to walk around with a gun and a badge and arrest people and possibly shoot somebody? I don't know about you guys, but I'm calling the city manager, mayor, and the chief of police on this one. Let's watch the video.
Is he that bad? Is he that bad?
Hi. Sergeant Rogers, is there anything I can help you with regarding our vehicle? Hello? Do you have any questions?
Oh man. What is he wearing? I didn't see what he was wearing.
How about an ID?
Whoa, hold up. How about an ID?
Your vehicle? Maybe I can help you out. Do you have any questions regarding your vehicle? Maybe I can help you out. How about an ID? Can I see your ID?
How about your ID? not the right way to go approach it.
Leave me alone, man.
Can I help you with anything? See what you think of
It's weird.
behaviors.
Cut you off. Sorry, dude.
Maybe I can answer some questions for you.
Decent jeans. Are they dirty? What shoes you wearing? You got holes in them jeans? Boy. Okay, otters don't involve private vehicles.
When was I around private cars?
It makes sense.
No, a normal person would take a picture of the car. You're crouched down underneath, kind of almost underneath the back end of one of the cars.
Saw me.
And then
Now
you walked around by some private cars as well.
Now I'm recording.
And you were going between and in and looking at private cars too. So we're just curious what you're doing.
Private cars too?
That's great.
You never saw me looking in any private cars. You never saw me even looking at private cars. All the photos on mine are of your cars. So go ahead and go back to work. What's your name and badge number?
You didn't even need to say it that way. And he's
What
a
about
good
you
guy
two?
though.
Right here, Rogers, Sergeant 5227.
They all
What about
probably
you?
know what's going on. They're used to
Do you have any
audit.
questions about our vehicles? Almost underneath the bumper of the detective car?
See you later.
Is there a reason for that?
See you later.
Reason?
Is there a reason for that?
See you later.
That's
So there's no legal reason for that.
See you later.
legal reason?
You're not going to provide ID?
See you later.
He needs legal reason to do it?
Go ahead.
Go ahead.
I'm standing here in the open.
And so am I.
You can stand here as long as you want. That's fine.
Fine with me as well.
Can he walk away?
Do you have any questions about our cars? We can help you answer.
Nope.
Is that
Nothing
just
that
like
I'm not answering myself.
a fanboy license plate thing? Like, is that something fake? Wouldn't it be smart to not have that if you're in the FBI?
You know what that means? Do you like police cars? You like police cars? Is it your thing? Is it your jam?
The what?
I know a lot of little kids do. Little kids run around and look at police cars. It's kind of weird when adults do it.
Wow.
Especially for a prolonged period of time like you were. You're looking in each one. Little kids do. Little kids run around and look at police cars. It's
This is
kinda
my
weird when
jam.
adults do it. Especially for a prolonged period of time like you were.
Wow.
You're looking in each one.
How long is okay to look in a police car?
That's just weird. That's creepy talk.
Kind of interesting.
Do you have kids?
How long is okay though?
Quite a while. You were being watched, of course.
Okay is quite a while. You guys weren't. Well, I didn't see you guys.
I know. We have cameras around our police department.
Right.
You good?
Yeah, yeah, yeah.
Well, I don't know.
Cameras around our police department. That's how we first observed you, sir.
Who's all stealth here?
Good luck, guys. Have,
Oh, wow.
have a good day. I think I said it about 4 times, maybe. I don't know.
Yeah. We walked back 2 or 3 times and took multiple pictures of the same vehicle. So
And then once you guys,
maybe you had some questions about our vehicle.
once you guys leave, I'll probably walk back again. Matter of fact, I'll go walk back right now. See you guys later.
What? Interesting. Why doesn't he just say that what he's doing though? Like I mean, you don't need to. That's holy shit.
Now these guys are following me.
Holy shit.
So we're walking back. I'm cool with that. I'm gonna walk this way too then.
Like this guy probably just
You don't want to walk that way now?
yeah. They probably look and see.
Given the contentious nature of today's society, someone lurking around our vehicles, not taking normal pictures, not doing normal things, that's going to make us a little uncomfortable, right?
Can you
Reasonably
define
so.
what's normal?
I'm sure you know there's been lots of cases where police cars have been sabotaged.
Define
So,
what's
we're
normal.
curious about that. Huh?
Define what's normal.
Sure. You got video going, right? I'm a tourist. I'm someone who likes police cars. Check this out.
Look at this idiot.
Right? Are you upset about
This
that, dude?
entrepreneur
Oh
brand logo
man,
was
that's
done
insane.
by a top freelancer on Fiverr.
We have
It is
tons of
simply-
tourists here. Like, dude, like back in the day, like if you see even a nice car, yo, I'm pulling a. Oh man, yo. I literally from a year ago have a picture of me next to this like purple car because it's so sick. It had a nice purple green paint on it. Oh man, it was looted.
Define what's normal.
Huh?
Define what's normal.
Sure. You got video going, right? I'm a tourist. I'm someone who likes police cars. Check this out.
Look at this idiot.
I did though. I took a photo with it.
Maybe even come over and go, wow, look at that. Look at the radio, look at the gun, look at the computer.
Huh.
I don't hang out for an extended period of time and go back to the same cars and keep going around. I don't come over here like you did and get down underneath the back of the detective's car.
You saw me get down underneath the back of a detective's car?
Just there when we tried to contact
You saw me get down underneath
just
the
like
car.
I did right there. You're crouched down.
How far away from the car was I?
You don't need to
and
release that info.
was I taking pictures?
You should keep that quiet, sir.
If you don't understand that, then you're either a liar or there's other issues going on.
Well,
We the people, it does, but like, there's a job and there's a role. If it's that big of a
You just
deal,
said right there that there's no other issues, so that's the angle you're taking.
I don't even know. Yeah, I'm lost. Sorry, guys.
Shame to be dishonest.
I'm not being dishonest. I'm just showing you guys both sides.
No.
Please stay on the sidewalk.
No.
Please don't go in the street.
No. I'll do all that. I'll go in the street. I'll be off the sidewalk. I'll do all that. I'm gonna take a picture right in front of your window. All that stuff. Yep.
Continue to try to antagonize, but it doesn't work.
I'm not antagonizing you. I'm letting you know. I'm not gonna do. You don't give me directives. Okay. I don't have to listen to your. What's illegal about me being off the sidewalk and taking pictures of your car?
Walking in the street, I don't want to get hit by a car.
My safety isn't your concern, right? No, it's not. The Supreme Court's ruled on this, bozo. The Supreme Court has ruled on my safety is not your concern. You don't then leave pictures of the car.
Nothing.
Okay, so
I'm
give
not
me
reaching to be
directives.
superior.
Okay,
I was watching this. I was just really busy.
Window, all that stuff. Yep.
Continue to try to antagonize, but it doesn't work.
I'm not antagonizing you. I'm letting you know. I'm not gonna do. You don't give me directives. Okay. I don't have to listen to your directives. What's illegal about me taking pictures of the car? Okay. Then leave. What's illegal about me being off the sidewalk and taking pictures of your car?
Walking in the street, I don't want to get hit by a car.
My safety isn't your concern, right? No, it's not. The Supreme Court's ruled on this, bozo. The Supreme Court has ruled on my safety is not your concern. You don't worry about me walking in the street taking pictures of your vehicle. You don't worry about me. Speeding is me committing a crime. Me being in the street taking pictures of your car is not committing a crime. I know a little bit more than jaywalking is crossing a street, not being in the street. You heard of a public easement? Have you heard of a public easement? Do you know what a public easement is? I just look like this, idiot. Do you know what a public easement is?
No.
Yeah, I am.
I'm not an idiot, but
You can't tell me I can't walk around the back of that car. You can't tell me I can't stand behind that car. There's nothing you can do.
what's a public easement?
Nothing you can do. Right? Admit it. Yeah, you said, do me a favor. Do this, do this. Don't do this.
Yeah.
Admit it. If I want to, there's nothing you can do. Is that correct?
Did I ask or did I tell?
Is there anything you can do if I can? Here, we can solve the argument. We can solve the argument. Is there anything you can do? Look at being a little kid. Is there anything you can do if I can't? Is there anything you can do if I can't? Solve the argument.
Did I ask or did I tell?
De-escalate. Is there anything you can do if I can't? If I don't listen to you? Is there anything you can do? Is there anything you can do? Answer the question.
Why
yes.
are you
Is there
being
anything
like
you can
that?
do if
I
I
mean,
don't listen
this
to
is
you and I
crazy.
get off
How
this
does this
sidewalk and I go
escalate?
take pictures of your car?
You can do that, but I can also follow and watch you and make sure you're not going to do anything.
Yeah, you can waste the public's money all you want. You can.
Actually, based on your behavior, that's not a waste of money.
It's not a waste of money taking pictures of a car.
No. That's not what I said. You just twisted it.
I didn't twist it. You guys walked up on me and said you're taking pictures of vehicles. It's suspicious to us, and now you just said I can follow you around.
Like I said, I already described for you taking
Hey,
pictures of cars. Illegal.
you're outgunned mental-wise, bud.
Sorry.
Go back to work. You're not gonna win this. Get out of here.
Tell me about what
Hey,
about it was not
where's your
suspicious.
daddy, Sergeant? Tell him to get out of here. Go ahead.
We're still talking. You're free to leave.
I know I'm free to leave. So are you guys. So this is Sergeant Rogers, and this is the other officer's daddy. And
You gotta understand, dude. They're staying with their boys.
As close to you as I want.
No, you can't.
I can't?
You cannot get as close to me as you want. You cannot touch me.
Do you want to bet?
Mhm.
I'll get very close to you. I'll get this close to you.
6 feet away.
Give him a hug, buddy. Just ask him for a hug, man. It's like, just carry on with the day, yo. Tell him thanks for doing what the fuck they already did. 6 more minutes? No, it's not a law, but
It's a mandate? Don't
No.
provoke me. Is that a law? Because I'll get very close to you. I'll get as close to you as I want. What are you going to do?
What are you trying to get out of this?
Nothing. I told you guys a million times, go back to work. I know what I'm doing. Reasonable suspicion of what crime, babe? Of what crime? Suspicious behavior, is that a felony or a
nah, you
misdemeanor?
wouldn't give him
Which
a
one
hug
is
in
it?
this situation. But the hilarious part
Is
is
suspicious behavior a felony or misdemeanor? I can tell you the court history. I can tell you the Supreme Court rulings. You need reasonable suspicion of a crime. What penal code do you have suspicion of right
to
now? What
detain you.
vehicle
They
code?
just
Tell me.
followed you.
Which one?
Reasonable suspicion of a crime.
Of a crime. Of a crime. Of a crime.
There is none.
I don't
I'm
gotta
following
teach
you.
you.
They're just
Found
trying
one.
to.
Knows the law a lot more than us.
Right,
Exactly,
interesting.
I
They're
do.
trying
Where'd
to
you
just
get your law
wrestle
degree
you
at?
out of just
Your
your
6
position.
weeks in the police
words.
academy made you guys a lawyer?
It's like a military talk down in a way.
I'm not gonna keep talking to you. I'm not gonna keep talking to you.
Wow.
You said it's reasonable suspicion, and I said, yeah, of a crime. You need of a crime. You can't follow me around because somebody's suspicious and waste money. You're already a waste of our money. You're already a waste of our money as is. You're a waste of our tax dollars.
Is it thunderstorming in the back? Or is that a green screen?
I'm just gonna sit here and it's fine. I'll go ahead and go back to your cars, and eventually you guys will leave and I'll hang out. So that's fun to me. It's fine to me. I'll chill.
Me too.
You know what you could do instead of being here right now? You can
No.
go back to work.
I
Stop
don't-
making your department look bad. Stop making yourself look dumb. Go get a job and work. That's real professional.
I mean, what you're doing is a professional.
There you go.
I mean,
I feel like I'm being very productive. I was taking pictures I wanted, and it's none of your business why I'm doing
so,
it.
sir, the guy
And that's
auditing,
it.
you could dress very
So,
specific.
you guys should just go back to work.
Questions regarding our police vehicles, let us know, all right?
Nope.
You can dress
All right.
very specific.
Yep,
for
you're
this.
dismissed. See you later. Yeah, I just did. I dismissed you, and I'm gonna walk with you to make sure nothing happens to you on
You
the
don't
way
have
back
to,
to the
but-
police department. I'm worried
But
about
there's
your
a
guys'
sign you
safety.
could hold.
Yeah, no problem.
Maybe we should create a flag.
You can
for it.
ask. Because I don't
Wow.
have to.
Very
The
interesting.
bottom line is, I'm your boss. You're not my boss, right? You work for the public, correct? Well,
Wow.
okay. So I don't have to answer you. That's the bottom line. In most situations, you have to answer me. It's because I couldn't answer you? Yeah. Yep.
Holy
You're
shit.
definitely more skilled and educated in the law than I am.
Thank you.
If you were, you wouldn't even came out. You would have walked
Appreciate
up,
it.
said, "Oh, you don't want to talk to me? Okay,
No,
we're
yeah,
out of
you're
here."
right. No, I wanted to talk to you. Talk to God.
If I was, I wouldn't be saying that you would walk away and not mess with me.
Oh, now
Is that
he's
what you're
leaning on the
saying?
pole. Holy shit, where's he going into?
What
This
thing?
is the craziest part.
What
He's got
thing?
squad cars
That
in the
you have
back.
no
Now I
reasonable
see
suspicion
he's
of a
way
crime?
more relaxed.
I do.
No
what I'm saying
way.
is you
But
have no
this doesn't look
reasonable
professional,
suspicion
sir.
of a crime.
Depends on where you
Reasonable
are. He's
suspicion
kind
of
of
a
just
crime,
tired
you
of
can
it.
detain me. I understand. That's exactly what I'm touching on. I'm not talking about coming to talk to me. You can make contact. But you can't sit there and go, well, we're going to follow you around and waste resources. Who's going to approve that in your department? Are you that dumb? What suspicious behavior? Taking pictures of cars? Taking
You
pictures
keep
of cars?
saying
That's
the same
suspicious?
thing, sir. It's try a
It
different
doesn't.
approach.
What does a normal person take pictures of cars? That's your one little
Talk in a different
opinion.
voice. Hey, buddy, listen here.
I know, and it was
Fucking
I am
that
now
you'd be
dumber
YouTube
from
gold
listening
for
to
him
watching
too,
You act that out.
and it'd be the most epic fucking
Reasonableness.
reply to a
see
fucking
you later.
first audit, and it becomes
I'm
a
an
funny
extremist?
thing.
That's what I'm not.
But it's
You
not an
guys are
extremist. It's just like
You guys kill people all the
Hey,
time
buddy.
and all kind of shit. So,
Just
oh
talking.
yeah.
he followed. Oh man, he really bugging
What's the
then.
percentage? You tell me.
But he doesn't need to. He
Tell
doesn't
me.
need to talk still. It could be way
Tell
more
me.
less hostile.
Because
Yeah, it could
I
be
didn't,
way less
I didn't
hostile.
say it. I don't have it.
At a minimum, 300 million contacts with citizens every year. The number that get killed is...
You know, you're
Who?
more
You?
likely to be killed by a police officer than a terrorist in this country.
Did you know you're more likely to get hit by lightning multiple times than get killed by a police officers?
No.
Did you know
No.
more likely out of every 3 officers, the other 2 are just as dumb as the first one? What a piece of shit. These guys, they like to mess with you and
What?
play. Well, what percentage?
I
And
heard-
then all
I
of a
heard-
sudden,
I
they
heard-
feel like if you don't know a specific percentage from some deep down thing somewhere, some deep down study somewhere, then you're just an idiot and everything you say is totally void if you don't know what the percentage is. And to me, that's just stupid, dude. It's obvious. Police are killing people, and that's the bottom line. And I don't sit there and study those studies. What I do is come out and audit these idiots.
Wow, okay.
And put them in their
So,
place like I did.
The whole idea is that there's something between shark attacks and lightning. I know that for sure. I looked this up. Wait, no, it was something that. So wait, that's not even what I should be trying to look up. I should be trying to look up deaths by lightning, fatalities, better word, from lightning strikes, and this could actually be even just like 43 lightning failures for 3 years. Okay, shark deaths per year. $64, right? Yeah, exactly, yo. So you're more likely to get, killed by a shark than by lightning. Situations of fucking getting killed by a cop is maybe like fucking. And so, like, when you go to see and examine a fucking someone who's killed by lightning, right? They're fried. You see that. When you see someone killed by a shark, they're fucking gnawed up. Or maybe don't even come back. That's one of the things you might not even know. That shit could be higher. Unprovoked. Oh, 2 fatal? 2 fatal? Holy fuck. In the U.S.? Right, yeah, so no way, yeah. So actually, and I thought I was just being high, but initially my thought, and it's right. That fucking you're more likely to get struck by lightning than attacked by a shark. Yeah, straight facts. So the US averaged 43 lightning kills per year. Only about 10% of people are struck by lightning. So there were 5 fatal attacks this year. In the U.S. for sharks, but worldwide so like the whole world, that's insane. So you're actually more likely to get killed by a cop than killed by a shark. Yo, so if we associate cops on a predatory scale, that's interesting. All right, I wouldn't even know how to do this in mammalistic. And maybe we could find some of those behaviors and correlations and like maybe just dissolve some of them and create like a new version of a cop that like has no kills per year. But you know, like if you get shot at, if I get shot, I'm shooting back. Like I wouldn't know how to say as a police officer, I've never been one, but in my opinion, if I'm getting shot at and I think it's like if he's literally right in front of you, you know, like you do that. It's a human thing to survive. So ideally you would just not get to that point, but being a police officer, in my opinion, tough decisions are made so quick. It's all just like not anything that I can speak on. But you get, you know, a couple deaths per year by police. More than 5. So And in situations that like maybe could have been handled you know, moving forward with a little bit more you know, reflection on these things that happened, potentially, yeah. Let's all get this PDF. wemjournal.com. That's, whoa. Deaths resulting from animal attacks in the United States. Venomous snakes and lizards, spiders, scorpions, hornets, wasps, bees, centipede, venomous millipede, other venomous arthropods, a sting of an ant, caterpillar, venomous marine animals and plants, others specified. Holy fuck. So we could literally probably find that we need to examine the nature of all of those things and relate it to human behavior, because we share this space. Not a high thought. It'll help use ways to describe, right? So like if you literally have like a language, like that is a way to describe. Right now is what I'm using as a language, is a way to describe. But to describe a behavior, a lion biting some shit, way different than a shark biting some shit, right? And we got the hammerhead shark, we got the fucking other shark. We use these as a language. We could use this as a language if it's in the right setting and if it's in the, like, you know, to do all of them? Wow. To do all of them? So this might go back to the idea of infinity, but what are we even trying to achieve? I guess technically, yeah, like behaviors like these. Okay, let's look to see how many quick deaths. White female snake. Okay, 12. That's basically, okay, a white female snake, that's how many cops killed. Like I said 12 earlier, around like 12, yo, yeah. So the cops have a white female snake attitude. Probably not so much. That's really dark and fucking hilarious if you think about it, that I just came across that really quick. But yeah, this looks pretty legit. I thought I said 12 earlier. You might have to check. Let's go back and check. I have to verify that just to make sure, yo, just so you guys aren't really like thinking I'm crazy, because this is hilarious. This is just so funny. As we share this space. And in situations that like maybe could have been handled, that's maybe just dissolve some of them and create like a new version of a cop that like has no kills per year, but you know, like if you get shot at, if I get shot, killed by a cop, then the U.S. high, but initially yeah, this is fully right here. Yeah, this is straight facts. Right, yeah, so no way, yeah. So the actually, and I thought I was just being high, but initially my thought, and it's right. People killed by lightning than shark attacks. You're more likely to get struck by lightning than attacked by a shark. Not attacked, killed by a shark. Killed by a shark.
So,
wow, going over
US
this high is
averaged
tough.
43 lightning kills per year. Only about 10% of people are struck by lightning. So, there were 5 fatal attacks this
10
year.
people that are struck by lightning die. 10% of people that are
In the
struck by lightning
US
die.
for sure.
It's just
But
all
worldwide,
static
there's,
data.
so like the whole world, that's insane. So you're actually more likely to get killed by a cop than killed by a shark. Yo. So if we associate cops on a predatory scale, that's interesting. I wouldn't even know how to do this in mammalistic. And maybe we could find some of those behaviors and correlations and like maybe just
Did I
dissolve
say the
some of
number?
them and create like a new version of a cop that like has no kills per year. But you know, like if you get shot at, if I get shot, I'm shooting back. Like I wouldn't know
Oh
how to
man, as a
say
cop, this
as
is
a
the
police-
tough convo too. I think everybody would answer that.
So, ideally, you would just not get to that point. But being a police officer, in my opinion, tough decisions are made so quick. It's not anything that I can speak. So
Not anything I can speak of.
more than 5.
Oh shit.
So, and in situations, but you get, you know, a couple deaths, anything that I can speak on. But you get, you know, a couple deaths per year by police. More than 5. So, and in situations that like maybe could have been handled.
So maybe I spat. That's what I was thinking. 12, and I thought I said it.
You know, moving forward with a little bit more,
It's interesting.
you know, reflection on these things that happened. Potentially, yeah.
Not too lost. I mean, that would have been a crazy correlation. The cops are white female snakes. Characteristics of white female snakes.
Let's all get this PDF.
Yeah, we checked it out, boy. All right.
Wemgermal.
Okay, back at it.
When you think of accounting and finance, what comes to mind? Don't worry.
I'm gonna have to tell you that they're gonna tell you to delete that.
Yeah, I feel bad. He's already shamed. No, not good. Gastronomy food. Oh man, no, dude, hold up. It's a full moon, full moon, full moon. Alright. Plank length,
Plank
dude, that
length,
dude
yes.
was
What is
just
the plank
chilling
length?
right there.
Well, first thing to say about it is very, very small. And physicists tell us that
It is.
it's
I
the
gotta
smallest
fucking put the
length
coat
scale
on.
imaginable, really. The subject today is the Planck length.
Now, this is a length of a plank, but this is not what a plank length is.
about to eat
This
the
is about
fuzzies,
1.6 meters. It's the height up to about my nose. So that's 1.6 meters.
Woo,
And I want to
1.6.
talk about something which is a bit smaller. Well, a lot smaller. Well, I can't give you an idea of how much smaller it is.
Oh, now you're
Suppose I
picking
take
on me,
this
bitch.
length and I chop it into 10 equal sections.
Okay.
And now that I take this tenth and I divide that up into 10. 1, 2, 3, 4, 5, 6, 7, 8, 9,
What was 10
And so
earlier?
then I
Oh, yeah,
take this
10%
small
of people
piece
die
here.
from
I
lightning.
can't show you anymore because it's going to be a tiny little sliver down there. That's chopping it 3 times.
Oh, I
In order
chopped
to
it.
get down
Wow.
to the plank length, I had to chop this 35 times. That is, do this process
I have
of
to
contracting
chop
by a
this
factor of
35
10,
times.
35 times.
I have
So
to
it
wait
goes
till I'm
down
35 to
to
be president.
1.6, 10 to the minus 35 meters. An unimaginably small quantity. You can see this length coming down to that. That you can visualize, but seeing it done 10 to the 35 times is ridiculous. This is a length which is smaller
It's not
than the
ridiculous.
size of a
No,
proton
I'm gonna run for president.
by a factor of 10 to the power 20.
Let me write it down. And do I have to do all these 35 of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, and 35 of those zeros.
Now I'm
Yeah.
going to write this
Yeah.
number down so you can see how ridiculously small it is.
No.
It's not 0.35
35 years.
That would be 5 zeros. It's that with another 5.
Wow.
Oh, that with another 5. And if I stop there, that would be 10 to the minus 15 meters, which is about the size of a proton, the smallest thing that people can more or less visualize. Oh, no, you
15.
can't visualize it. We're going to carry on. 1, 2, 3, 4.
Wow.
And that's 10 to the minus 20.
When I had first Facebook.
That's, I can't work it out. I'm going to have this plus another 10 to the minus 15. I feel so ridiculous doing all this, but there it is, down there with this extra 4 sets of zeros with the 1 at the end. That's the distance, and then it's 1/6. So in meters. So this is
16
the Planck
meters.
length.
It's arrived at by taking 3 fundamental constants. Planck's constant, the gravitational constant big G, and the speed of light.
Wow.
Now, Planck was
Gravity.
the first person to come up with this length because he just
Planck.
invented quantum physics by studying black body radiation.
Now, the history of
way.
it's quite strange because
Yeah.
back in the 1880s, Max Planck and others were thinking about the heat and light energy that was coming out of hot bodies.
Wow.
And in the course of that, he started getting a feeling that there was something quantum mechanical happening. From that, he came up with an idea of fundamental units for mass, length, and time. And the unit of length is called the Planck length.
So the Planck length is telling you that when you try to merge the fields of gravity
Right.
through Newtonian constant big G with the velocity of light, which is something comes in electromagnetism,
Right.
with quantum mechanics, and merge them all together, out of it comes somehow a natural length called the Planck length.
Let's just write down the 3 constants then.
Planck length.
Here's Planck's constant, h, or as it's sometimes written, h upon 2 pi, which we signify like this. This is big G, the gravitational constant. That tells us why gravity is as strong as it is, why the Earth has
Planck.
got
Wait,
its,
what? Didn't I just watch a video on Planck's?
gravity on the surface,
Constant?
or of course big G and the mass of the Earth determines the orbiting of the moon around the Earth.
Wow,
and then
the
other
moon
constant
around the Earth, so
is,
it's self-reflection.
C.
Wow.
Now the curious thing is, if you multiply
Holy
H
shit.
bar and G, and then divide by C cubed, the cube of C,
What's C?
that gives you the square of a length, or if you like, an area, and that's called the Planck length. So the Planck length, if we now take square roots, so want the length itself, we take the square root of that quantity, and that then gives me the Planck length.
And if you want to talk about the early stage of the universe, the period before it expanded to the Planck length, we had no idea of the laws of physics. To do that, we
Yeah.
had to have a quantum theory of gravity.
Sneezing is
And none
spiritual rejection.
exists. Well,
What you're
they exist,
saying
they
every
exist
time
before, but
someone
nobody knows
sneezes
whether
is
they're right
just
or
like that. What you're saying is
Now,
bullshit.
what does it all mean physically? Well, of course, what it's telling us is that perhaps
He's trying to tell
if
about the
we
origin of
take
the
quantum
universe.
mechanics and
Leave it
gravity
to
into
God.
account,
Don't question.
space itself is not really properly defined on length scales smaller than the Planck length. Maybe space-time gets foamy, as they say, on these
Space-time
sorts of
is
length
me
scales, and then
right
all the
now.
particle physics guys,
You're in my quantum
these
tunnel, buddy.
cosmologists start worrying about their ideas of bubble universes springing out,
Hey,
out of the
Planck.
Planck length. But you better go and
Hey,
talk
Planck.
to
Planck and Chris
cosmologists.
Payne.
Or if you
Planck
get a
and
black
philosopher
hole,
Chris Payne. What?
for
If you get a
example,
what?
or if you get a black hole,
Right, in my
for
eyes.
example, if I fell into a black hole, I will be spaghettified, turned into long strands of things and disappear. But as I go into the black hole, all the entropy associated with me, my complete disorder, how my hair is untidy, everything about that will be dissolved in the black hole. And in order for the laws of thermodynamics to hold, the entropy of the universe must increase, and if the black hole is part of the universe, the total entropy must increase, and the black hole must have an entropy. And the person who wrote down the formula for the black hole's entropy originally was Bekenstein, and then Stephen Hawking. And he
Wow, Bekenstein and Stephen Hawking. Who the fuck? What is entropy, by the way? Wow. Also often interpreted as the degree of disorder or randomness in the system. Holy fuck. This is why you guys are trying to watch the FBI and all that shit. No, but like basically, yo, in the way that's like, that's insane. The way these guys are reacting with me in the video. Let's see if what he says now.
He wrote down the entropy is equal to.
Oh, whoa, hold up. What is this? What is he faking right there? The video glitched.
And then Stephen Hawking.
He's about to
And he
pass
wrote
out.
down
I'm
the
sorry,
entropy
buddy.
Is equal to Boltzmann's constant times the area of the black hole.
Who's Boltzmann?
Divided by 4 times the Planck length squared. So there it comes in this model.
Whoa, now it just changed.
4 times the Planck length squared. So there it comes in this model of the entropy of a black hole, and that is believed by most theoreticians, despite the lack of any evidence, to be the entropy of a black hole.
So there is a practical use for this Planck length.
Well, if you're a cosmologist or a particle physicist, I have to say in my everyday work on semiconductors, I don't use it too much. But it's great to think about because it's such a small length.
Wow. It is really good to think about. Thank you, sir. What? Not secure? This is all fake shit. This is insane. What? Desert Blooms 2008? Wow. What is this? Oh, damn. 55 degrees in Colorado right now? Shit, in El Paso? That's nice. PBS space time. I don't want to trip PBS out, but I think let's do it. It's already green screened and faked, so this can't be it. Who's this guy? He looks... I could challenge him.
Black holes are so fascinating and so troublesome because they represent the often problematic collision of quantum theory with classical theory. On the edge of a black hole, it is no longer possible to assume that quantum effects can be ignored on the classical macro scale. Black holes are formed by the 75.
No,
defined by the
trash.
following, where h bar is plumb.
I need more stimulation in the eyes with diagrams or just like someone who just seems more valid. I can't, just because he's young. Oh wow, the World Science Festival? No way. I could go back and forth. I like the old heads more because like that's where I'm trying to be. I'm trying to get that respect. Like all these guys that are just fucking doing this shit for like a living. I'm here doing it now.
Talk about black holes.
Sorry, bud.
Of course,
Brian Greene, he's
Stephen
classic,
Hawking
man.
is the great scientist who comes to
Long
mind.
live.
So I'd like to spend a little bit of time thinking about what it is that Hawking told us about black holes.
Okay.
What were the insights that he gave us, and what puzzles emerged from his work that we are still struggling to resolve and probably will continue to struggle with for some time. And toward that end, as a little bit of background, we need to have some understanding of a concept that everybody is familiar with at some level or another, but let's use this opportunity to get us all in the same place.
Okay.
And that's the concept of entropy.
Entropy.
So entropy is a word that's freely used in the culture. We often use it to describe
So I'm a thermodynamic quantity.
disorder. That's going from low entropy to high entropy. That's sort of the intuition
You cannot get
that
my
the culture
energy.
has about this word. So let's start with that very basic way of thinking about
Not signed to
entropy.
anybody.
And a good example would be, let's
exercising
say
my
I take
freedom
my book,
of speech.
I throw it up
Sorry.
in the air. It starts very ordered. All the pages were in complete numerical order.
Uh-huh.
But as they come down, it's overwhelmingly likely that they will not land in numerical order. They'll land in a highly disordered state. And that gives you some sense of what it means to go from an ordered arrangement to a highly disordered arrangement, going from low entropy to higher entropy. Now, of course, that's just a sort of fanciful everyday example. If we head more toward a physics example, we could imagine having a box of gas. And imagine it just has a small number of atoms in there. And imagine that they're all neatly arranged in this nice cubic lattice.
Sorry.
This would be a very ordered or low entropy configuration of the gas, like the pages all in numerical order. Now, contrast that with a box of gas that has a whole lot of atoms, a whole lot of particles are all bouncing around in a completely haphazard way. This would be a very disordered state, a high entropy state. And another way of thinking about
a lattice is a framework or a structure of metal strips, a window, a door, or a gate. So I'm your window to the word lattice.
Is the amount of information that would be required
He said
to
just a
describe
moment to describe two configurations.
Because look, on the left, you don't need a lot of data. It's a cubic lattice. You've got 3 by 3 by 3 atoms filling out that lattice. And if I give you the separation of them, say 10 centimeters,
10.
that basically describes the configuration on the
What
left.
the
You don't
fuck
need a
is
lot of
10?
information to describe a system that has low entropy. But let's
What
say I
is
want
low
to
entropy?
describe
10
the
has low entropy,
configuration
but
on
God
the
has high
right.
entropy.
Well, I basically have to tell you where each and every particle is located. That's the only way I could describe it. Look at all the information I need to describe that configuration.
Yeah.
So the idea is low entropy, not a lot of information. High entropy takes a lot of information that's hidden in this configuration of particles, and that's kind of the distinction between order, disorder, low entropy, high entropy, low information, high information.
No,
Now, of course, I'm talking
sober info all
in
the time.
loose language, so that we can all get a feel for the
Yeah, you
critical
can't. He's
ideas.
high.
But you can make this all quite precise. And this gentleman over here.
Thank you. What's up?
You know who this is? Who's this?
Philosopher Chris Payne.
Ludwig Boltzmann. That's right.
Oh,
And
Ludwig
this
Boltzmann.
is his
Hold up.
famous tombstone. And you see that Ludwig Boltzmann. That's right.
Ludwig
and
Boltzmann.
this is his famous tombstone. And you see that formula on the top of his tombstone. And that is
K-log.
the formula that makes these
The
statements
video
precise.
log.
This is a formula that
K-log.
you learn if you take a course in statistical mechanics, thermodynamics.
Yeah.
S stands for entropy.
Okay.
K is Boltzmann's constant, and the rest
Whoa.
of it has to do with the number of
Right now, all my
configuration
focus is
of
on
the
Boltzmann
ingredients
because
of
you
the
don't know him.
particles that make up the system.
Wow.
And the famous second law of thermodynamics makes use of this formula. And again, it's something that we're quite familiar with in the culture, that things typically go, as I said, from low entropy to high. That's the
Right.
natural progression of a system,
Right.
which means that this quantity S tends to increase over time.
Right.
The entropy later on is almost always greater than the entropy earlier on in the evolution of a system. And what we'd like to do now is have this idea come into contact with the idea of black holes. And we'll see that there's a certain
lot of fun
kind
with you, Brian.
tension that arises. It's a very fruitful tension that will take our understanding further as we try to
My
come to
eye
grips
is a
with it.
black hole.
And to help us go on that journey, we're going to now bring out the Donner Professor of Science in the Department of Physics at Harvard, whose primary area of research is string theory. He's received numerous awards and recognitions for his work, including the Dirac Medal and the Breakthrough Prize. Please welcome Kumran Vafa.
Kumran Vafa. Kumran Vafa, physicist. What up, bro? Hey, man, how you
Now,
doing? You can hear
I
me
should
good?
say
Can you hear me?
that I have known this gentleman for over 30 years.
Wow, and he
We
knows
were,
I'm
I
not to
guess,
just
both
talk to me right now. I get it.
postdocs at Harvard in the 1980s.
That's right.
You got a
Harvard.
job at Harvard as faculty, but that's okay. We're
What does that mean?
still good.
You're doing very well too.
Thank you.
What does that mean?
And I should say, my most exciting intellectual adventures in string theory have been the papers that we have done together.
Right.
So
Okay, yeah, I bet.
Thank you. So it's been an honor to
Yeah,
work
join
with
the
you. So
live
thank you.
stream,
So-
man. Sorry,
so
Brian.
let's now get into this subject here. We heard a little bit about entropy and about the second law that entropy increases over time. But in the 1970s, people like Bekenstein and Hawking, they began to worry about how the second law of thermodynamics would behave in the environment of a black hole. So you can give us a sense of what they were puzzling about.
Yeah, you guys are acting weird.
The objects falls into the black hole.
Why?
But they cannot come out. So
Right,
objects that are
you
falling
just fell
have
in.
entropy, just like what Brian already described.
Wow,
They have
and
some
you guys
information
just
about
like
where
had
they are, how they
body
are.
language earlier.
But once you fall into the black hole, then you don't have any more access to that information. So what happened to that information? So that seems like you lost entropy.
Nah, you gotta follow me.
Down, and that's against what Boltzmann said.
That's what
So
everybody
can I give a
does.
concrete example of
Boltzmann.
that? So I think we have a little silly example. If I took my wallet,
Oops,
it
sorry.
has information, it has entropy.
Oh,
I
shit.
throw it into the black hole.
Right.
And you're asking,
I'm trying to throw my
what
bag in
happened
this
to
sh-
that entropy?
Exactly.
Did it disappear from the universe?
Exactly. So that was the kind of question that they were struggling to understand. How could this be consistent?
Right.
So they began thinking about this, and then there were a few ideas that they were thinking about, and in particular, the properties of the horizon of a black hole.
The edge.
The edge, the event horizon that we talk, the edge in which, beyond which no light can escape.
No light can
They found
escape?
it had some interesting properties, and in particular, they began studying what is the area of this edge, and how does it change.
Wow.
And in particular, what happens if you throw objects into this black hole? What happens to this area?
Yeah.
And one of the surprising things they found was that when you throw objects in, this area cannot stay put, and in fact increases.
Right.
So they began to think about, okay, what could this mean about this? What this could be related in some way, compensated by the fact that you're losing something, the entropy. Could it be somehow compensated by the fact that this area is growing? So they begin to ask the question, could the area of this event horizon be in any way related to the lost entropy?
So we actually can unpack that. So let's just go
What?
through a couple of little examples here. So this is the
He said we
standard
can
second
actually
law of thermodynamics.
unpack
Entropy
that.
grows over time.
Slater,
Let's just take the two boxes
Surlier.
that I started with to illustrate what you're describing. If we take those two boxes and we put them together, what happens to the entropy? It goes up,
That's
right?
the Boltzmann statement.
Right.
Right.
So we have the combined entropy is greater than the individual's entropy.
Right.
Now
So
you're
my energy now is
describing
higher
something
than
that
when
doesn't
earlier.
have to do with gas in a box. You're talking about the geometry.
Oh
of
yeah,
a
me
black hole.
me
So for example,
examining this shit.
They
Sorry.
studied what happens if you study one black hole with one area of event horizon and another black hole with a different area, and you bring them together, you merge them, and you get a new black hole with a new area. And they found that the area of the new formed black hole is bigger than the sum of the two areas.
Yeah.
Just like
Tag along with
the
me.
entropy had that property. The entropy resulting on the
You and me know
once when you
people.
combine them was bigger than the individual entropies. So the entropy sounded very similar to the area, or area sounded very similar to the entropy. So they began asking, could it be that the area and the entropy are proportional to one another for black holes?
No, yes.
Formula that we can bring
Wow,
up here.
very interesting.
So entropy
Proportional?
the
Is it
area,
proportional?
and the proportionality constant is a
S and A.
little
What's
bit
S stand for?
complicated,
Over 4GH
right?
squared,
But you don't really have to worry too much about this number on the right-hand side. But the basic lesson
Four.
is that they're guessing, they're suggesting that the area of the event horizon is somehow holding on to the entropy, holding on to the information in some sense that's inside the black hole. Now, you gave an interesting thought experiment
Yeah.
about how to test that. You were talking about
Yeah,
throwing
man.
something in and watching the
Yes.
area. And
So-
it just so happens that we have a little
Accidental.
segment on that here. So why don't we go through this? So here's so what are we seeing here? And then we'll do your little thought experiment.
So here, I guess we are seeing a black hole, a red black hole.
Yes,
Oh,
exactly.
With the event horizon of it, you can see that the idea that the information is proportional to the area with some proportionality constant. If each individual element
K
of the information
Payne.
is like one square there, we just divided this sphere into these areas. So these represent
Wow, right.
bits of information.
Yeah, the whole thing
on
right
the
here is just a
surface of that
sphere
black
with
hole.
info,
So
and
those
I'm a
little squares
sphere.
can, roughly speaking, be thought of as Planck areas.
Planck
The
areas.
Planck length that describes
They brought me
the
here.
smallest length that makes sense in a quantum theory of gravity.
Squares of the size 10 to the minus
Oh
30
wow,
centimeters or
that
so.
gravity brought me
10
here.
to the
Holy
minus 30
shit.
Squared. Yep.
Each size of the square is.
Yep.
Yeah.
So you basically count the number of those little squares that are on the event horizon, and that's the amount of entropy it has. So if we now if this is true, and we were to take a particle that sort of carried 1 unit of entropy, what would we expect to happen if this is true?
We expect this area to grow exactly by 1 square.
So let's sort of do that. We have this is
What?
actually a real film.
1 square? No way, dude. No,
Let's
no
get
way.
our
You,
particle
you,
going
you.
in to this guy over here.
Yo, come on.
So
Lead
the
me
one
to
on
the.
left
I
was
want
the
to be
original black
I'm the
hole. The one on
philosopher
right
of the
is a
world.
larger one after a particle has fallen in.
I
So if we take all those
have
little squares and we smear them out on the larger black
become
hole, what
here
we'd expect to happen
to
something
unite.
like that.
Exactly. So one more square.
So we throw sort of one particle in that carries one
And
unit
I-
of this order, and the black hole eats it. It grows a little bit, and in fact,
Wow.
you can calculate that the amount by which it will expand can accommodate one more of these little tiles, and that makes this a consistent way of thinking about black holes. So
Black
this was
balls?
like an important. I mean, how important was this kind of an insight?
Well, it was the amazing insight because it was the first time where Einstein's theory of relativity was combined with quantum effects. And that is what Hawking used to actually argue that the entropy of a black hole has something to do with the area.
Yeah.
So this combination of quantum theory
Wow.
and Einstein's theory was quite novel. And this was
No
in the
shit.
early
So this is where I am right now. You guys see me
So,
right now? Can you guys see me? Please answer me.
When it
Yo,
comes to
call me.
entropy and black holes, like what issues does this leave over?
Well, actually, the problem was that Hawking's argument showed that there must
What
be
issues?
information, but on the other hand, the horizon of a black hole is featureless. So you don't see these point squares or anything. So there seems to be no room for information to be stored on it.
No,
so
there isn't.
In fact, if you use Einstein's equations and solve it, you find there's exactly one solution for a spherically symmetric black hole.
You have almost 19
one
minutes
solution
left.
means it has zero entropy. It's
Wow.
exactly
Wow.
ordered state. There's no choice.
Wow.
One piece of information.
One piece of information. And that is inconsistent with what Hawking found when he combined Einstein's theory with quantum mechanics, where he found a huge amount of information. And the question is, where is this huge amount of information stored? Is it the shape of the horizon? Or is it what aspect of black hole encodes the microscopic structure of the black hole? That was open when Hawking discovered this fact.
This idea to work. Let's just go back to my little example
Brian,
of sort of
what up?
throwing the wallet in. So in that
Yeah,
little example,
sorry.
I threw the wallet in and said, where did the information go? So
It went right
so
to
the
you,
new
dude. I don't
idea,
know why
if
you're on
it's
me about
true, would
this.
be,
This is interesting,
I take
though.
my wallet and I throw it in, and rather than it like disappearing, The idea, roughly speaking, would be the information that is in my wallet, the configuration of all the atoms and molecules, it goes toward the black hole. And we want it to be the case that information kind of like smears itself out on the outside and is encoded in sort of bits, ones and zeros.
That's the picture.
That's the picture. And in
That's
principle, were this true, I could actually extract that information in principle and use it to rebuild anything that fell in this case, it would be my wallet. So that's the idea.
That's if the information is not lost and information is there. That's what we would expect.
Right.
Yes.
Yeah.
That's the hope.
And the
That's what I
puzzle
wanna
is,
do.
is that actually
true? And how do you actually see this information? Or where is it stored? Or how do you account for the microstates of the black hole or the entropy of the black hole?
Just
and that's
like
where you
yeah, that's where you come in. Just
me
call
and
me
my
up, man.
colleagues in string theory
Okay,
began
right.
studying these questions
Right.
more seriously with the advent of duality symmetries in string theory. So first,
So
perhaps
first
I should
string
say-
theory. Can you say a few words on string theory?
Hold
I
up,
should
what?
say a few words about string theory. So string theory is a framework where we believe combines Einstein's theory of relativity with quantum theory in a consistent framework. And as part of it, it demands that the entities making up the matter are not just point particles,
Right.
but entities like strings,
It's like a
or
string of
membranes, or extended objects have to stay
association
zero.
in your head.
And so that's one aspect of string
So
theory.
here's a little, if you want to take us through, this is just a little example of what string theory might look like. So you got a piece of matter, and we're going to dive into it, and then you're
burning candle.
saying that if we go sufficiently
So if you
deep,
go to the beginning inside, you'll see the atoms first, and inside the atoms you see the nucleus, and the nucleus you see, well, here I guess the protons and neutrons, I'm assuming. And you go inside them, you see the quarks.
Whoa.
And once you see the quarks, you can go inside them, and if you zoom in a little further, you might see actually that these featureless quarks that you think are
They're
point
colorful but
particles,
colorless.
actually they're tiny strings, vibrating strings of some sort.
Yes,
And that's
sorry.
the kind of a picture that we expect to be true
Right,
in
that
the
is.
context of string theory, that point particles are
Mhm.
point-like because we are not zoomed in sufficiently close to them.
Mhm.
And if we zoom in enough, they will have features like strings.
Yes, that's what humans are.
We
That's
don't
how
know
we
exactly, but it
exist.
could be like 10 to the minus 30 centimeters, somewhat close to the Planck scale that we
10 to the
discussed
minus
already in the
30
context of the
centimeters. So
areas
wow,
of
I'm right here.
horizon
I'm
of
the
the
black hole. No
so
way.
that's the basic feature of string theory, but as one of the aspects of
Wow.
string theory that was originally one of the negative features was
Sorry.
that string theory predicted that the spatial dimension of the universe is not 3. And that
Wow.
was manifestly in contradiction with the fact that we think we live in 3 spatial dimensions. We have 3 spatial dimensions. String theory seemed to demand that we have
Yeah, I
9
don't.
spatial dimensions.
Whoa,
And so this
yes.
was a contradiction originally, and physicists thought, how could this possibly work? And one resolution
It's
was,
a triangle.
oh, these 6 extra dimensions that we have are so tiny, like little circles.
Right,
at
okay,
every
sorry
point
about
in
that.
Space.
Sorry about
Let's
triangles.
Imagine 6 circles at each point, 6 types of circles, which are so tiny that you cannot see. So the idea would be the macroscopic dimensions are only 3. The big ones are 3, but the tiny ones are 6. And the tiny ones are hard to see unless you really zoom in, and that's difficult to do with the energies that's available to us in our experiments today.
but the idea would be that you've got these big dimensions that we
No,
know about,
man.
these extra
I'm
dimensions.
ready to fight them.
And then how do you relate this to this idea of black holes?
Right,
So this
okay.
was actually a negative feature for string theory. So string theorists were kind of struggling. Yeah, we
Yeah.
have these 6 extra dimension.
Yeah.
It's a little embarrassing.
It is.
It's tiny. You
Yeah.
don't see them. And then other people say, sure, yes, there's.
Yeah, the evil
So this was the
spirits.
state of the art till mid-90s, where we didn't know what to do
Yes,
with these
exactly.
extra dimensions. They were there just to make the theory consistent.
I was born in 1994. I'm Chris Payne. I'm a philosopher.
And then came the question about the black holes, and the black hole had the opposite problem.
Yes.
The problem with the black hole was
Thank you.
we were missing information
Thank you.
of the black holes.
Yeah,
Where
you
were they?
were. I'm here, right here,
What
buddy.
were that information?
Mm-hmm.
It turned out that these two problems canceled each other out. And so this
It's
the
you versus
problem
me.
that was where are the ingredients or the degrees of freedom that constitutes black hole?
What are the
ended up
degrees of freedom?
in the internal spatial, tiny spatial things that I was talking about.
How do you control
So as
it?
you can see here, the red
I can
donut-shaped
not control what I
object there
see.
is to represent these
I
tiny
really wish I could.
internal dimensions. And
All the time, and then just live stream all the time. But it's
that you see
interesting, you know.
represents the
You just have to help me out.
macroscopic dimensions. And so the idea there is that if you take a string or a membrane
Maybe
or
I'll
one of
do
these
that soon.
extended
Wow,
objects
right.
and wrap it around the cycles
Right.
on these external tiny spaces
The
like
green
a
and the
torus
red.
or like a circle or donut or whatnot shape you have, it will create
Food.
a mass at
It'll
the
give
point
me
where you're
energy.
wrapping around that circle. And the more it wraps around,
And then
the
it
more
gives
mass
me-
is going to be constituting there.
Right.
And the more it's going to shape and distort the geometry of space around it.
Wow.
And if it's enough of it, it's going to create this warped space, which
Me?
is what we call the black hole.
Me?
So the black
My
hole
body?
itself can be viewed as these strings or membranes wrapped around these extra cycles of this tiny space. And so then if the question is, what accounts for the degrees of freedom of
Wow.
the black hole, these are precisely these strings or membranes wrapped around these extra dimensions. How many are there? How many
Right.
degrees of freedom are there? What are the entropy? Gets translated to how many ways
Wow.
these extra strings or membranes can wrap around these extra dimensions. And there are many ways. And that
There
accounted for
have
the
been
entropy
proven
of the
to
black
be
hole.
many ways.
So with Andy Strominger and I did actually a computation of how much entropy is there in these
Oh,
wrappings of these
wow.
strings around
Determine my
around
entropy.
these internal dimensions of string theory.
Yeah.
And we found exact match with the prediction that Bekenstein and Hawking had made
Hey, okay.
about the entropy of these black holes.
What was it?
So just to
Who
quickly
is it?
unpack a little bit. So
Is it me, Chris Payne, philosopher Chris Payne?
Way
Yes,
of
I did.
describing black holes in string theory.
Yes, I did.
Which makes use of the extra curled up dimensions, the red part of this
Yes.
image that we find here.
Yes.
And you're saying that by wrapping these strings or ingredients of string theory around
Yes, by
the
smoking
extra
weed,
dimensions,
I bring you to a black hole.
create a warping in space
Yes.
that looks just like the black hole that we've been talking about for many years.
By
before string
smoking
theory
weed,
even was
I
on
can
anybody's
create a black
mind.
hole. The
But
devil.
in this description,
Yes,
you can do a
sorry.
direct
This is
count
me.
of the amount of information necessary to describe the situation, and bang on, it matches what Hawking said.
Yes.
It matches
So
what
this gives us
Hawking says.
insight
I
into
match
one
what Hawking
possible
said?
way of describing the internal structure of
So
a black
Hawking
hole,
said-
which in many ways I think the community views as one of the most important pieces of data that string theory may be going in the right direction. We don't have experimental support for these ideas, but here's a mathematical piece of experimental
Am I
support.
quantumly
that it
proving
matches
that I'm
ideas
the
that have been on the
superposition
table for
of you?
25, 30 years.
Yeah, sorry.
So-
I
so
didn't
this
mean
is
that.
a
Quantum
key
mechanics
step
has been
forward.
for a while.
But now let's turn to some of the puzzles.
So
that
I'm the
still
superposition of you guys.
remain. And part of the
What's the
puzzles
puzzle?
surround something that's tightly related
How do you guys do this
to
for
what
a
we've
living?
been talking about, which is something
What the
called
fuck?
Hawking radiation.
Hawking
Can you just tell us
radiation.
a bit about what Hawking radiation
Is it just like
So
the Chris
Hawking,
Payne theory?
After discovering
You
the
guys know about that?
properties of having information in the black hole and the entropy, he also noticed that the black holes actually are not quite black.
Yeah.
And what happens if you go near the event horizon
Yeah, you.
of the black hole? What happens is that you get pairs of particles created out of vacuum. These are quantum fluctuations. The quantum fluctuation is always
What?
creating particles and antiparticles in pairs, and typically they go in and out without doing anything. But if they are near the event horizon, one of them perchance could go towards the inside of the black hole, and then one of them could go outside.
Hmm.
And the one which goes inside has no way of getting out, so it's stuck there.
How?
But the one going outside can
Right.
leave
So
and go
you guys can
far
enjoy
away
it.
from
I'm fun to
all
be
the way
around,
to
aren't
infinity.
I?
And that looks like a radiation from the viewpoint of somebody outside. So in other words,
Cool.
from the viewpoint of somebody outside, the black hole is
Hey,
actually
guys.
radiating energy.
I am.
As it radiates energy,
It's not always bad.
it loses mass, and it shrinks and shrinks and shrinks.
Until I need to
after
eat.
a while, the black hole totally disappears, where there's no more energy
I'm
left
dead.
to,
Yeah.
to emit.
Wow.
So
So
once the-
I'm here in
once
the
the black
flesh,
hole
guys. I'm Chris
disappears,
Payne. I'm
The
philosopher
question
Chris
is,
Payne.
what happens to all that information that went into the black hole? What happened to that area I was talking about? Where is that information gone?
What
so this was
area?
a question that Hawking basically posed.
What
Perhaps
area?
you
Why'd you
recall
guys
the
flinch?
discussion between Einstein and Bohr, that Einstein did not like the probabilistic aspect of quantum mechanics, and so he said God does not play dice. And
God
Niels
does not
Bohr
play dice.
responded by saying to Einstein, "Stop telling God what to do."
What? God will tell you
And,
what?
Hawking added his own wrinkle on this. He said, "Well,
Wow.
what happens if you throw a dice inside a black hole?" and the black hole after a while disappears, and with it disappears the dice.
Wow, right, yeah.
So and then he said,
No
not only
way.
does God throw dice, he sometimes throws them where they
Wow, you guys can't
you,
see me, but
made
I'm
a
God
little-
right now with you.
Cake. for him
So
with
yeah,
an
we had
Yeah.
the lucky occasion of
I'm
having
with you.
Stephen
I'm-
Hawking
I
as our guest
represent
at the
God,
home
guys.
A couple of years ago when he was visiting Harvard.
Philosopher
that
Chris Payne, I'm
we made a
representing
cake
God.
in the
I'm
form of a
sorry,
black
guys.
hole. With
Yeah,
the dice,
Harvard, yeah.
And the book,
Harvard,
his famous
no.
book,
I'm
which is actually
from.
made of,
I didn't
is
go
a
to
cake,
Harvard.
and it's actually gluten-free because he was allergic. So
Yeah, no.
So Stephen had,
Funny
had
joke,
his
but
cake and he could eat it
I'm
too.
with you guys. I'm God.
Very
Let's
nice.
praise. Do you want to cry with me or something? Make music?
So yeah, so in that.
What do
in
you
that
guys want to
picture,
do?
see that
You
there
guys
are
got
two
7 minutes.
dice
But
hanging there,
you're right, yeah. So you're
floating
seeing
towards
stuff.
The black hole, and it's going in.
The
and
issue
that's
of information. I just want to have fun.
information puzzle. You lose
Yeah,
the
you're right. It's
information
interesting,
of
but
what
I
is
can
the
just
dice
live here.
roll, and that's what's called
I'm
the
God.
information puzzle.
Right.
Because if the dice rolls some number and the black hole evaporates and disappears, with it disappears the information about what the roll of the dice was, and that's called the information puzzle, which we still are struggling to understand even today.
No,
Now,
I make
most
music.
people
I make
in the
music
field for a long
instrumentals.
time have
You guys should listen to
anticipated
them.
that somehow the information does get out with that radiation that
You
we
guys
saw
should listen
coming
to 'em.
off of
Listen to
the
it. It
black
could be
hole.
a
Now,
mantra
while
for
Stephen
peace on
Hawking
Earth.
said that the information would not come out. I mean, that quote
It
was
would.
quite serious. He was
That
saying
is not. That's a
we have to
fucking.
rethink
He's not.
quantum
He doesn't know what
mechanics
it's
because
like to make
information does
music.
not come back
Facts.
out.
Yeah.
He then changed
He does
his
not
mind
know what it's like
on
to make
that.
music
So part of the
and
reason for
change
this is the
people's life and
discovery
heal
of a more
people. I just
detailed
released a
version of what is
music
called
album called
holography.
Anti-Music
In other words,
Healing.
This began with the work already back
Listen to it, guys.
long time ago, but became more precise with the work of Juan Maldacena, where it was discovered that you can describe a gravitational system precisely using objects which are much simpler to understand. And in particular, in that system, you could prove mathematically rigorously there's no way you can lose information. So therefore, indirectly, there was a proof that whatever happens to black holes, the information should get out. So that part
Right.
was kind of beginning to be established using these kind of arguments in string theory.
What information? Where are these
but
black holes?
The wrinkle is that even though there's this mathematical proof that this should happen,
Right.
we still did not know exactly how. And some people thought maybe the information gets out with this radiation, as we were saying.
Oh no
right?
shit. So I
Very
am the
gradually
black
and
hole.
very tiny bit at a time, but gradually builds up to give you information out. And this is what in the early 2000s, I believe, Stephen agreed that this is the resolution. But I still
did.
think, and
Yeah, in the early
community
2000s, I knew
believes
I
we
was
haven't
chosen
really
by God.
understood
I really did know
how
I
this
was chosen
happens
by
exactly.
God.
So the information puzzle about how this
Easy.
information comes out
It
is
is
still one of
God.
the big
God is
mysteries
me. I am God. You
of
are
black
God.
holes,
Everything
and we
around
don't
us is
really
God.
understand it.
So do you think it's
You don't
possible
really
that
understand
we
it?
will
Why?
one day
How do you guys do this
conclude
for
that
jobs
the
still?
original view of Hawking was right, that the information does not get out? Is that still on the table in your view?
Well, I think it sounds
does
much
information
less likely
get
given
out?
that we think we understand a dual
Yeah,
description.
because
another
I'm just
description
actually a
of these black
person, but
holes. So
I
it
can.
seems like
Yeah,
that
you're
seems
right. I
much
keep
less
running my
likely now,
mouth.
but you know, we can never say we know everything about the subject. That's our current understanding.
Yeah, you guys
of
don't know
what's
me.
involved. But
Sorry.
But even with that understanding, it's not our understanding is not sufficiently detailed.
I'm
to
just
convince
listening
us
to you guys
of how it
anyways.
happens.
Now, a lot of our discussion here has been focusing on what happens at the edge of a black hole, at the event horizon of a black hole, that it may
Event
be where the
horizon.
information
What is this
stored, it
event
may be where
horizon?
the entropy is stored. We haven't said much about what happens at the center.
Right.
Can we just spend a little time talking about that?
Well,
What is an
one of
event
the things
horizon,
that happens
and what
in
is
the
at the
center of the
center?
black hole is that there's this singularity, this infinity that Brian discussed already. This
Me and
division by
infinity.
zero analogy, and we don't believe that's physical. We believe that's just a phantom of our equation. It's just a mathematical thing that comes out, and that means that our description breaks down, not that there is an infinity.
Now, quickly, the infinity could be physically that you've got all this mass crushed to zero size.
And
so
zero
that was
size is not physical. For us, there's nothing smaller
It's all
than
me,
times
yeah,
length,
and it's not physical.
about
It's
10 to
me
the
just
minus
running my
33.
mouth,
There's the
listening
notion
to you
of
guys,
space
producing
breaks
quantum
down anything
mechanics.
smaller than
I
that.
got
So
you guys.
There cannot be an infinity in physics. We don't believe so. So we don't understand what is happening in that way. And the understanding of this singularity, we are not at all close to understanding what's happening there.
Why?
We know that there should be a
What?
good description, but we don't have it. And why that's important is that, well, we want to know what's happening inside the black holes.
Why?
Of course, we can send somebody and find out what happens to that infinity, but that would not be a fair thing. And even if we did that, even if we said, well, we send some creature, not us, the robot or something, the robot cannot come back to tell us what happened or what they saw. So because nothing can escape from black holes. So it won't be useful. So we have to figure it out without going inside the black hole, what's going on there. And that's still, we have no, not only we don't have observational data, we don't have enough theoretical understanding. And we think it's important, not just for the black holes, but it turns out that those infinities that we see, if you try to pass through those infinities to the other side, so to speak, it turns out it looks very much like the infinities we see at the beginning of our own universe. It is as if our universe is emerging from inside one of these black holes.
It is.
Along those lines, and
It
don't
is.
lose your train of thought there.
You guys are,
Oftentimes
the
people
universe
think
is
of the center of the
emerging
black hole as a
with
location
me.
in space, the center. Is that the right way of thinking
No,
about
actually,
it?
it's like in a given time. It happens at a given time.
Yes,
And that's
not
because the
right
nature
now.
of space and
It's
time
building up.
changes as you enter the black hole, when you cross the event horizon of the black hole.
So one of the reasons why you can't get out is because you can't stop time from ticking forward.
Exactly.
So
And
going forward and forward in time is like going closer and closer to the
center.
singularity.
And then at a certain time you hit the singularity, that's the time. It's at a given time.
I was
So the
born into
singularity
it.
could be the end of time in some sense.
It could be, but we don't believe that. And then what you would say, what's the after that? And that looks very much like what could be a new universe or something. So we are interested in understanding the resolution to the issue of singularity of black holes. And I think it's very exciting.
But my eyes
We
are
know
black
that
hole.
black holes, as we discussed already in this program, there are a huge amount of evidence that they exist, so they are there. We cannot say we're just imagining. So what is that? What is that singularity? What are we learning from it? It's one of the most beautiful, mysterious objects, I think, in the universe. And hopefully,
Nah,
by
I
some
just gotta be
experiments and maybe
myself,
by
you
some
know?
theoretical
Yeah.
understanding, we'll have some progress.
Sorry, guys.
So what's your guess?
You're just
I mean,
an
if we
innocent
come back and
person
we invite
asking
you
me
back
these
for the,
questions, but I know what I know.
2025 World Science Festival.
Wow.
Can you give us the answer to what happens at the center of a black hole?
Yes.
Maybe you invite me 2050 if I'm alive.
2050.
What?
All right.
No.
Good prediction. A safe prediction.
No.
Please
2025,
join
get me there.
in
Come on.
thanking Kumran Vafa.
Thank you.
Wow, hey, good job, guys.
Thank you very much.
Appreciate
Fantastic.
you. Talk to you later.
Good night, everybody. Thank you.
Nah, they're gonna talk shit about me. Interesting. A Magnetar, yo, Magmar. Oh. Wow. Okay, this could be cool. I haven't really seen many female videos in a while. This would be
Can't
awesome.
believe that Daniel deal you got me on my insurance.
And when I say this, I mean like literally probably like
This episode was
yeah, like solid 8-10 hours, 12 hours of video.
made
It's a
possible
big
by
difference.
Brilliant.
Body language
Hi
and
everyone,
everything.
I'm Jade. Lovely to meet you.
Thank
or
you.
see you again. In the movie The Matrix,
Oh
people
shit.
are plugged into a
You're gonna
virtual
see me
world without
again?
knowing
What?
it. All of their experiences are completely simulated and don't correspond to the real world around them.
That'd be lit.
It's a classic piece of science fiction.
Oh, maybe in the like
Or
the
is
rerun or when I watched the video
What
back.
if I told you that cosmologists, the people who study the large-scale structure of our universe, actually argue over whether our universe is really just a simulation? In the cosmologist version, the idea is that
It's not
all
a
that
simulation.
really
You got the
exists is a
outlet
single
behind your
brain,
head.
which simulates all of the senses that make up your experiences.
Wow.
Everything you've ever tasted, smelled, touched,
Chocolate.
all of your memories, your
No.
entire life, from the day you're born until the day you die.
Right.
This all-simulating brain is called a Boltzmann brain. This sounds insane when I just say it like that.
It
So
does.
before we get into why this is something legit science even talk about, we need to cover some basic physics.
She's good.
Before we start, this is part one of a collaboration with Isaac Arthur, who makes really cool videos about
Isaac
space and philosophy.
Arthur.
He'll be popping in and out of this video, and make sure to check out part two
Okay,
on his
thank you.
channel
So it's not
afterwards.
just you.
All right. In any physical system, it's often really useful to quantify the amount of ordered structure in
Yeah,
that system.
it is, you're
We
right.
can do
1,
this by
2,
counting
3.
the number of possible ways we can rearrange the system.
Yes.
Take this example.
Okay.
Imagine flipping 10 coins. There's only one way to flip 10 heads. That's a pretty ordered system. But if you wanted to throw 5 heads and 5 tails, there are 252 different ways to do that.
Oh, yeah.
This
Holy
way of looking
fuck.
at the overall order of a system is called entropy. And physicists love to talk about entropy. They love it because they can always rely on it for one thing, to keep going up. What do I mean by that?
Entropy.
Well, in our coin case, you can imagine that the number of possible ways we can get heads or tails is proportional to the entropy. Flipping 10 heads can only be done one way, and so has very low entropy. But flipping 5 heads and 5 tails can be done many ways, and so has high entropy. So if you started with 10 coins facing heads and started flipping them, you would tend to a state of higher entropy.
Entropy.
The takeaway is entropy always increases in a closed system. You can also think about the entropy of more realistic systems, like the air in the room around you. When you open the door to let some cool air in, the cool air doesn't just stay in the corner. It gradually spreads out and mixes with the warm air, lowering the temperature of the whole room. It goes from a neat, separated system to a messy, mingled system, which is impossible to reverse.
Wow.
Try as much as you want, you won't get those
Right.
cold air
I'm in your
particles
black
back
hole,
to the
buddy. I
corner
like
of
your
the room.
voice.
But
It's
hang on,
nostalgic.
some of the very
Sorry.
astute of you may be wondering, but you said entropy always increases. But it is possible that I
It
can start
does,
off with 5
bitch.
heads and 5 tails and flip them all heads, making the entropy go down.
Let's get
Explain that, Jade.
all in my
Alright, well
head right
spotted.
now.
In fact, you're right. That is possible. And it's a key piece of the puzzle in understanding Boltzmann brains. Entropy is a concept governed by statistical fluctuations. The larger the fluctuation, the more unlikely the event is to happen. But while on average entropy always increases, it's very possible to have fluctuations which lower entropy given enough time and dumb luck. So that's entropy. Now let's leave that for a moment and talk about cosmologists, the people concerned with Boltzmann brains and the whole your entire existence may be a simulation thing.
What?
The goal of cosmology is to understand the universe on the largest scales. They try to answer questions like, what is the entire universe made of?
Really?
Is it changing over
Or is
time?
it like
Is
actually
the
that
universe
like
the same
those
over here
fucking
as it is over there?
solar
Arguably,
systems
the holy
emit
grail of
fucking
cosmology
light?
is about the origins of the universe.
No, they don't.
The
They
theory
fucking
is
emit
that the
light
universe
to
started
us.
off in a very hot, dense
And
state
energy.
in the past,
Sorry, yeah,
a
hot
state
and
of
dense.
very low entropy. The
Right.
big question is,
Okay, what up?
why?
Why? Because I'm a motherfucking philosopher.
This question is still not entirely answered today. It's so hard because we have no
I'm
way,
Chris
as
Payne.
far as we know,
I'm
to
a
measure
mofo
anything
philosopher.
before the Big Bang, if the concept of before the Big Bang even means anything.
The
But that
Big
hasn't stopped
Bang?
cosmologists
Oh,
from
look at her.
coming up with
She
models
just
about
trying
how
to
the
dominate
universe
the
may have
combo?
started.
Oh, make you
It's
blush?
hard to summarize an entire
Look at those
active
eyes
field of
widen.
research,
What?
But one paper by
Oh,
some
now
of
we
the
had to
leading
switch it.
physicists in the field
Disturbing
summarize it like
implications of a
the
cosmological
question then
constant.
is whether the origin of the universe was a naturally occurring fluctuation, or was it due to an external agent which started the system out in a specific low entropy state? Now we'll get into what naturally occurring fluctuation means in a second, but the phrasing of external agent here is just meant to describe any other mechanism of why the universe may have started out the way it did.
Liar.
So here we can finally tackle
Liar.
the problem of Boltzmann brains.
Liar.
The guy that Boltzmann brains are named after, Ludwig Boltzmann, was a 19th century physicist whose primary contribution to physics was our modern understanding of particle thermodynamics and gases. Unfortunately, the idea that small particles like atoms and molecules make up matter was highly controversial at the time, due to nobody being able to see them. He spent much of his life fiercely defending his theories against constant attacks by the scientific community,
Right.
but he was right. And much of what we know about
Yes.
thermodynamics and entropy is because of this great man, whose equation is now etched on his tombstone.
K-Log, what up?
But what does thermodynamics have to do with cosmology? Remember the holy grail question of cosmology. Why did the universe start out the way it did in such a state of low entropy?
Why?
Well, one answer to that question is that the universe is actually much older than we observe it to be.
No.
And the Big Bang was a kind of all coins flip heads type situation. By that, I mean it was an astronomical fluctuation which created a region of space with very low entropy, which was
Wow.
the Big Bang. And the evolution of the universe ever since then has just been a consistent increase in entropy, like what we would expect.
What are you talking
Now that all
about?
sounds
No.
plausible, but if we stop and think about it for a second, smaller fluctuations in entropy are much more likely
No,
than
that
larger
is
ones.
relevant.
Would you
It's
agree?
God.
So it should seem intuitive to think there would have been a smaller fluctuation in entropy, and hence be more likely to have created only half the universe as opposed to the entire universe that we observe. Scratch that, it would be even more likely to simply produce our own galaxy. Even more likely to just produce our own solar system, our planet, a single human body, or even a single brain. The Boltzmann brain argument states that it's astronomically more likely for a single brain to spontaneously and briefly fluctuate into existence, complete with
Yes.
false memories of our universe,
Wow,
than it is for
no.
the entire universe to have fluctuated into such a low entropy state as the Big Bang.
No.
So, statistically
No.
speaking, you are most likely a Boltzmann brain.
I am. Yeah.
I can imagine this doesn't sit well with a lot of you. Neither
Probably
does it sit well
not.
with a lot of cosmologists. Of course, in principle, if our theories tell
Come
us that we're
find me.
most likely to be Boltzmann brains, we should believe our theories, right? Well, not necessarily. There have been many arguments that try to come to grips with the problems that arise if we take this view.
What do you
because
mean?
It points to a broader issue about how we construct and interpret cosmological theories. I'll try to give the
I mean,
intuition
nah.
for a couple of the counter arguments here, but
What?
the subtleties for each of them will depend on the particulars of the cosmological model we're analyzing.
Okay,
An
okay.
interesting argument against Boltzmann brains comes from cosmologist and all-round cool dude Sean Carroll, and it's that the very idea
Sean
of thinking
Carroll.
that we might be Boltzmann brains is, in his words, cognitively unstable.
Wow.
This idea is a bit confusing, but this is the best way I know how to sum it up. So what cognitively unstable means is that if our theories tell us that we
Oh, sorry.
the only way that could be the case is that if we are Boltzmann brains simulating everything in the world that we experience, so then because we're Boltzmann brains simulating the real world, we can't really trust any of our observations about the world. So
Yeah.
this means that we can't trust our observations that came up with the theories that we are Boltzmann brains. Does that make sense? It's a self-contradicting situation, and it's what Carroll means by unstable. It doesn't settle on a conclusion. It flip-flops between, well, we might be Boltzmann brains, but then if we are, then we can't trust our observations that tell us that we are, but we still might be, but then if we are, we might not be.
It's called a
What's interesting about this
superposition
argument is that it
in
doesn't
quantum
rely on empirical data. It's
mechanics.
arguing for a particular way of doing science in a consistent way.
Yeah, I agree.
What are some
Yep.
other, more digestible arguments against Boltzmann brains?
Yeah.
Many cosmologists
Yeah,
say that our
bitch.
cosmological theories ought to be able to predict that we should be likely to exist. However, in assessing this likelihood, we should take into account the fact that we do exist. Let's break that down.
Who?
This is an example of what is called the anthropic principle. And in its
In my
simplest
eye,
form,
the black
it
hole.
says that the environment we observe around us is the kind of environment that would allow observers like us to exist. This is a powerful idea when used to its full extent.
Yeah, you
And
can.
It's particularly
It's all in
useful
God.
in fields like cosmology, where the data is limited and you can't really do controlled experiments with the entire universe. However, talking about probabilities gets complicated and a little precarious in situations where
Yep.
the infinities like potential size and
All
age
the
of the universe
variables.
come in. So the details of the analysis start to become very important, but suffice it to say that with different Bayesian arguments and taking into account that we exist as a key part of your empirical evidence, then humans in a Big Bang universe come out over and above these pesky Boltzmann brains. Of course,
Yes.
there's an alternative way of looking at that,
I
which
agree.
goes back to a more elemental assumption of
Why
the
did we-
observer being able to trust what they see and assume it is real, accurate, and normal. And we'll examine this and some alternative approaches, such as the anthropic principle and some of its consequences, in part 2.
The take-home
What?
message of this video is the fact
Accurate
that
and
cosmologists
normal?
try to avoid the idea that we're Boltzmann brains.
How is
Isn't
this
because they have a
normal?
fear
Like-
that we might actually be one of them.
You have to really be a
It's
nerd
more
of
of an
science.
interesting thought experiment
You
that
have to
points out
really
subtle
be
issues
fucking
about
into
how we
this
deal with
word shit.
probabilities in our theories when we're asking
Wow,
these big holy
holy
grail questions
fuck.
about why the universe is the way it is. As we saw in this video, big ideas like, is the universe a simulation, seem like nothing more than
Mm-mm.
science fiction if we don't have the basic physical principles to back them up. You can't really understand the idea of Boltzmann rings without first understanding entropy. I like to cover big ideas in my videos, but to do that I need to nail the
Right.
basics first.
So I'm just talking to people
One way
about
I
this.
do this is by practicing with Brilliant.org. If you'd like an extensive overview of fundamental physics, I highly recommend their course on classical mechanics. It includes quizzes about motion, energy, reference frames, oscillations, and more. Their interactive quiz style really forces you to think about what you're learning. And as any physics professor will tell you, to get any kind of intuition about a topic, you need to work through problems. And this couldn't be more
Why?
true. Every time I look into
Can't
a
I
quiz,
just be
I
found?
either learn something new or gain
Wouldn't
a fresh
someone want to come to
insight.
me?
When you are ready to tackle those big ideas, Brilliant has more advanced courses too, like this one on quantum computing, or this one on gravitational physics, where
Nope.
you can learn about black.
Wow. Holographic worlds, yes. This is for me. Alright, welcome to my
Tonight's
black hole.
program, Black Holes and Holographic Worlds, a
You guys
wonderful
there?
program.
Yo,
Black
Brian,
holes
what up?
have
Young
really,
Brian
over
or
the
no?
last few decades,
Okay,
played a
painted the
vital
crowd.
role
Sorry.
in helping us
Back you.
understand the universe with ever greater detail, ever greater
Are you
precision.
still working,
And
dude?
tonight's
Holy
program,
shit, dude.
wonderful
Wow.
moderator Alan Alda, who will be out in just a little while. My friend
Alan,
Robert
the
Dijkgraaf from
moderator.
University of Amsterdam will be giving you an introduction to the
Your
subject in just a
friend
couple of minutes.
Amsterdam, yes.
And to
Sorry.
ensure
Okay.
that everything you hear tonight is absolutely accurate,
Yes.
absolutely spot on. We have
Right.
a very special member of the audience, the world's expert on black holes,
Philosopher Chris Payne.
Professor Stephen Hawking.
Philosopher Chris Payne. What? Yeah, this is a hologram right here. He's not there. This is all fake. He's what? You awake? Can you see me? Nah, this is me. I'm Stephen Hawking. No, I'm the third party. Nah, I'm just watching. But what? No, Stephen, is that a holographic world? That's a holographic world right there. This is a holographic world. Do something. Touch him. Somebody touch him. Somebody touch him right now. Somebody touch him. Somebody move him. Shit, dude. We're trapped.
And so without further ado, I'm
No.
proud to present to you Black
All right.
Holes and Holographic Worlds.
Okay, well, you're in my black hole. You guys all watch. Okay, see you, Brian. What up, Alan?
Ladies and gentlemen, my name is Robert Dijkgraaf, and my
Robert.
pleasure and honor to, and also I
Dijkgraaf.
must say, a little bit of a sinking
Dijkgraaf.
feeling to teach a short
University
Black
of
Holes 101
Amsterdam.
course
Yeah,
in
yo, I'm
front
teaching
of,
what it's like
Professor
in
Stephen
Amsterdam.
Hawking. Must be
Sorry, guys.
the most intimidating audience, just in
I
himself.
bet.
Today we will not only discuss the edges of space and time,
Mhm.
but we actually bring you also to the edge of current research,
Right.
of the great questions and ideas in understanding space, time, information, gravity. And in fact, we also see that black holes are right there,
Yeah, I'm
where
right
the
here.
two main characters, the two big theories in modern physics, general
Holographic
relativity,
Stephen Hawking and Chris Payne.
Einstein that describes the large structures in the universe, and quantum mechanics that describes atoms
'Cause
and
he's
even
dead.
elementary particles, how they clash and where they clash, and black holes are right there in the middle.
Like, he's
So
dead.
just as a little
Stephen Hawking
teaser
is
trailer,
dead. That's a
Let
hologram
me
of
flash
him.
some of the important points that we will be discussing.
I'm Philosopher Chris
And let's start
Payne.
with the history. Black holes actually made a long journey from an idea to a full theory, and finally to a physical, observable phenomena.
What up?
Already in the end of the 18th century, the French astronomer Laplace discovered that if an object is heavy enough,
Mm-hmm.
then even light, which is the fastest traveling object, a phenomena in nature, cannot escape. But of course, there was only Einstein with his theory of general relativity, the fundamental description of space and time where they found their proper place.
Oh.
And the first mathematical solution was found in 1916.
3.
And
God.
then John Wheeler,
Trinity.
famous American physicist, really brought this subject alive in the 1950s and 60s. And in fact, he also baptized it as a black hole because a time or null-like geodesically incomplete solution of the space-time equations makes a little bit difficult to pronounce.
Yeah, you're talking gibberish. Sorry, bud.
If you
Robert.
look at black holes, I mean, one thing we can do,
What are
we
you
can take a
doing,
little
man?
marble and throw it up.
Oh, okay, lit.
And of
Pass
course,
that
we'll fall
here,
back
bro.
to Earth.
Yeah.
And you can wondering, how fast do I have to throw the marble so that I can throw it to the moon? It has to escape
Self-reflect.
the gravity of Earth, and it has to have a speed of 25,000 miles per hour.
Wow.
But now you can ask, can we make
How do you know the size
the
of the
Earth
ball?
heavier? Or what we can also do, shrink the Earth, make the mass more concentrated, and
Yeah.
thereby strengthen the gravitational force.
Yes.
So how small should we make the Earth so that even light cannot escape? And the amazing thing is that the Earth will be as small as another marble. But then a marble that will weight as much as the whole Earth.
Oh shit, weed.
Now, this is a very
No.
caricature of a black hole. But the better way to describe it,
That's
of course, is
insane.
Einstein's equations. Einstein's equations that tell us that space and time are curvature generated by energy and mass. So it's like the stage on where I'm standing is not rigid and flat, but actually is made out of rubber sheet that curves under the influence of mass.
Wow.
And if you have enough mass, then actually
Why'd he pull out his
the
phone?
whole thing will turn into itself. It will essentially,
he
the
printed out his
space-time will curve in such a way
Right.
that it stops
I thought he
objects
was.
from
I thought he was
escaping.
flinching because of me. He felt
Form
me.
is what technically is called an event horizon.
Right.
The sphere surrounding
And you're
the
feeling it.
singularity, the place where everything gets crushed together.
Yes.
A sphere that surrounds that singularity that divides space-time in two regions. The outside, where everything is safe and things can escape, and the inside, where things are doomed. And they're doomed in a fundamental way.
Yeah.
Because inside the black hole,
Yeah.
there's only a limited amount of time.
Yeah.
It's like you're watching a DVD and you know there's only 10 minutes to go.
Is
so
there?
the plot better come to
Oh,
an
we
end.
got fucking an hour and 2 minutes.
Black
20,
holes
2 minutes.
are, of course, absolutely fundamental in understanding our universe. And therefore, it's important to see where we can find them in the universe.
A
and
black
I want to
hole?
mention 3 examples that we'll discuss in much greater
Okay.
detail later today. The first are black holes which are roughly the size of a star.
Wow.
If you have stars which are heavier than the sun, at least 3 times heavier, or typically 10 times, at the end of their life, they will explode, and the remainder will collapse and will form a black hole.
Wow.
If you are kind of lucky, and the black hole is part of a binary system, there will be another star orbiting the black hole that can feed off its energy and mass and all the matter. It will swirl around the black hole and will emit X-ray radiation.
Wow.
There are now many, many examples of
I'm
sources
giving an
in our
X-ray of you
galaxy
guys right now.
of these star-like black holes.
Okay.
But there's a second category, which is even more fascinating, which are black holes that are sitting right in the center of galaxies.
Right.
It looks like almost every galaxy had such a black hole.
Right.
And the plumes of radiation that are coming off are so large
Yes.
that, as you can see in this picture, they're even larger than the galaxy itself.
Wow.
Hundreds and thousands of light years of energy radiating out of this galaxy.
Yeah, buddy.
Inside the galaxies, and we can do this by watching with our telescopes,
Damn.
you will see that inside the galaxies there is these huge black holes that are millions or sometimes billions times more heavy than a typical star.
Oh.
And just to give an impression of how forceful these objects are, even these galactic centers, these supermassive black holes, which are a million times heavier than the sun, they're not that big. They're perhaps 4 times bigger. So much energy in space is concentrated.
What?
And we also will discuss a third type of black hole, which is even more mysterious.
The music life.
Because as I said, the black hole is not necessarily large or small. It can have every size. But what about if you took a black hole and made it as small as a particle? Could a proton or electron be a microscopic black hole?
Nah, I'm the black hole. Yeah, I'm the black hole. Yeah, what's up, yo? I'm the black hole. What you talking about? I'm about to rewind it just so you know. Yeah, okay.
One of the most important achievements of Professor Hawking was made. Because he realized that if you take tiny black holes, you really take into account the quantum theory of matter, the things, the laws that govern the smallest particles, then actually black holes are not black. They start to radiate. There's a possibility of matter escaping the black hole, and thereby the black hole can evaporate, and in some sense it looks just like a particle that's formed and again decays.
Huh.
But if we take that last step and really ask these kind of questions, we are really no longer in the realm of observations of good answers.
Right.
We are really at the stage where we should ask good questions.
Yeah.
And I think there's nobody better to
Oh,
ask these questions
than me?
Alan Alda. Thank you very much.
Oh. Kevin, what up? How we doing, Kevin?
Hello, thank you. You know, I was
I
at
got
my
you.
computer this morning
No shit.
trying to get up
Oh,
to speed
Alan.
for tonight.
He's an actor. Holy fuck.
And an email popped up on my screen from my daughter Eve.
I think I was talking to Alan
It
earlier.
required a long answer, and I said, I just shot back an answer quickly. And I
You
said,
got some video of me
I
doing
can't
it.
answer you right now.
Okay.
I'm trying to learn everything that is known about black holes in the
Okay,
next 2
Kevin.
hours.
I'm sorry. I'm sorry, Kevin.
So, being
2
my
hours.
daughter, she shot back an answer to me, and she said, "You need the whole 2 hours?"
Who is
So
your
then she
daughter?
laid it out for me. One,
What?
there are areas of
Interesting.
space that suck everything
Wow.
into them.
Yeah,
Two,
no way.
you don't want to get near a black hole.
Wow.
Three, some people are like black holes. They suck everyone around them into their vortex.
No way. What? That's insane.
And she ended with, what else do you need to know? So that's
No.
really the question, isn't it? What else do we need to know?
But that's actually really crazy.
We've heard about them. We know a little bit about them. We use them.
And
in
why did you use the
conversations.
daughter
Sometimes we
thing?
make jokes about them the way Eve did.
I don't get that's a joke. You don't bring up family in this matter as a scientist, in my opinion, sir. I apologize.
What are these holes? How do they form?
Who are you?
And how
Who are
can they
you?
tell us something about the universe that's unexpected?
Who are
Well,
you?
we have an extraordinary panel
Yes.
tonight that can guide us to the
Okay.
heart of black holes and throw some light.
Let's go, man. Come
dark
on.
places
I'm
for
sorry,
us.
guys. Yeah.
Please welcome Kip Thorne, Raphael Busso, Andrew Hamilton, and again, Robert Dygraff.
Andrew Hamilton? No shit. Let's go. USA. 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 All right. They're humbled. They're all good with the game. I get it. I'm cool with it. Not even the game. I just like, wow. I think they're here hearing me.
Welcome. Let me tell the audience a little bit about each of you. Andrew
Yeah. Okay.
on your far right is an astrophysicist.
No shit, he's
known
the
for
first
his
one.
Scientifically accurate general relativistic
All right.
visualization.
Wow. General the relativity visualizations.
TV documentary programs, including Nova and
Yep.
National Geographic.
Wow. Interesting. All right.
Computerized
Okay.
renderings which take viewers into black holes.
Viewers into black holes.
Utilize video game software developed
Wow.
by Silicon Graphics.
Holy
and
fuck.
They're based on Einstein's equations, and they're designed to visualize the unseen. Dr. Hamilton is professor of astrophysics at the University of Colorado, Boulder, and a
Whoa.
fellow and current
Smoking
chair
pot.
of the JILA
Probably.
Research Institute. Did you say JILA?
Gilla.
Gilla. Thank you.
Gilla joints.
I never heard that before.
Sorry.
So,
3 Nobel Prize winners.
I bet.
Who really? What? No.
There's going to be a lot
Nobel
of things
Prize.
I never
What
heard
now?
before tonight.
For the
So,
limit.
Robert Dygraff, no, wait, now I'll do first, next on your right is
Sorry.
Raphael Busso. Raphael is known for discovering a general relation between the curved geometry of space-time and its information content, which we're going to get into tonight in a serious way.
Wow.
And that's known as the holographic principle. You say
Yeah.
holographic or holographic?
Holographic.
That sounds like both at the same time.
Really? Holographic.
This is amazing. This is like
Say it
quantum
after me,
mechanics. You
holographic.
get everything at once. What?
I'll let you pick. What do you prefer?
Pick it.
Say it after me.
Holographic.
Holographic.
Yes. Okay. I don't want to hear anybody else say it any other way tonight.
Holographic.
This
Sorry.
holographic principle is believed to underlie the unification of quantum theory and Einstein's theory of gravitation. Those two things that don't seem to go together. Dr. Busso is professor of physics at the University of California, Berkeley, and he's one of the discoverers of the landscape of string theory, and his work has led to a novel view of cosmology.
Cosmology?
String theory.
The cosmos?
We're only going to appear in one tonight, as far as I know.
I always keep thinking of like Cosmo the
Next
Face.
to Andrew is
Cosmopolitan,
Robert
like Cosmo
Dygraff,
the
who
Face,
has done
cosmetics.
award-winning research on string theory, quantum
Robert
gravity,
Dygraff, is
and
he the
interface
same
between
guy?
mathematics and particle physics. He's
Amsterdam.
dedicated to creating greater public awareness of
Yeah.
mathematics and science,
Okay.
and to bridging the gap with the arts and humanities. That's great. I'm really glad to hear that. He's president of the Royal Netherlands Academy of Arts and Sciences, and is the distinguished university professor at the University of Amsterdam and the chair of mathematical physics.
Wow.
And to my
Okay.
left
What's up, dude? That's cool,
is Kip
man.
Thorne.
I'm Chris Payne,
Kip
Philosopher Chris
is
Payne.
a
Kip
prolific
Thorne.
expert on gravitational waves and is the co-author
Wow.
of the textbook Gravitation, from which most of the present generation of scientists has learned general relativity.
Right.
His research is focused on relativistic stars, black holes, wormholes, time warps, and
Whoa.
gravitational waves, and he co-founded the LIGO, which, as you know, is the Laser Interferometer Gravitational Wave Observatory.
What is that?
That's why we call it LIGO.
Thank you.
And Kip is a member of the faculty of the California Institute of Technology, has been since 1967, and Kip was the Feynman Professor
Whoa.
of Theoretical Physics from 1991 to 2009, and he helped me enormously with notions of
Whoa.
quantum mechanics when I played Richard Feynman on the stage. I'll always be grateful for that. Well, welcome all. Let me just
Whoa.
If I,
Is
if
this
I,
me?
If I know anything at all about a black hole, let me just help.
I'm a black hole, guys.
I get from general reading. You start out with a pretty big star.
Wow.
It's got a lot of gravity, and
Wow.
it's all the stuff that the star is made of because of the gravity. But it's also radiating.
Oh my gosh.
And if it radiates enough that the gravity is more of a pull than the radiation pushes out, the star collapses and becomes a black hole, and then not even light can get out of it. How close is that?
What?
Close.
Oh no, I'm crying.
Okay, correct it a little.
No, that's a great way to say it. Let me say it.
Wow.
You may not have heard.
No.
But another way of thinking about it. I like to talk about Einstein's law of time warps. Einstein's law of
I'm a black hole still, dude.
likes to live where it's going to age most slowly.
Yes.
And gravity pulls it there.
Okay.
And so
What up?
you age more slowly if you're on the surface of the Earth than if you're at high altitude.
Oh.
That's why gravity pulls you to the surface of the Earth.
So it literally clocks run slower.
Yeah.
And that causes
But so
gravity.
little slower, you wouldn't notice it unless you
No,
were...
but that's
Yo.
gravity that holds you to the Earth. So little, yeah, 4 parts in 10 billion slower here than up
Yeah.
That's enough to produce the gravity that holds you to the Earth because you want so badly to age more slowly, even if it's only 4 parts. Okay, so we've got that.
Yeah, that's good.
Okay.
What up?
So now you've got a star.
Okay.
And
Justin
time
Bieber.
is flowing more slowly on its surface.
Oh.
And as you say, the heat, you're radiating away the heat.
Jesus Christ.
That is holding it out, and ultimately it implodes because gravity wins. And as it shrinks smaller and smaller,
Aristotle, Plato,
gravity becomes stronger and stronger
Stephen
at its
Hawking,
surface.
Kanye West,
And
Donald
correspondingly,
Trump,
time flows
Adolf
more and
Hitler.
more slowly.
Well, that was just like
Ultimately,
I tried.
it's a
Yeah.
size where
I mean,
gravity is infinitely strong at the surface and time is
Chris
flowing
Payne.
at 0 rate.
But it's not
That's
like
the
that. I
horizon.
have.
So
Yeah, I'm zero.
If you try to hover above the horizon, if you try to hover...
Why don't we say the horizon? Maybe we get a...
Oh, I'm sorry. I screwed up.
The horizon, yeah. So like technically, I can't think of anyone more commonly known as evil other than Adolf. And like if you Google who are the most known people on the planet,
You're in the black hole, and you can forget everything after that.
Now let me tell you a point of view on why you
yeah.
can't get out.
Okay.
and then
So
there's
if you
also
hover just above the
Michael
horizon,
Jackson,
time
Drake.
is flowing exceedingly slowly, basically not at all.
No, and I've traveled and I've gone places and people know the name of him.
To stop flowing if you're just above it. What happens
If you're-
is that time starts
What?
to flow in a direction you thought was a space direction toward the center.
Anybody get that?
Yeah.
Somebody over there.
Right here. I'm right here. I'm right here.
Ask him.
Philosopher Chris Payne.
No picture yet. No picture yet.
But they got a picture of something.
Yeah, well, we'll come to this in a moment.
Okay.
But,
No.
but that's why you
Philosopher
can't get out
Chris
of a black
Payne.
hole, because time is flowing toward the center and you can't go backward in time.
Well,
Philosopher
that I knew.
Chris
I came
Payne.
in knowing that.
Yeah.
But
But if time is flowing toward the center and you can't go backward in time, you can't get out of a black
how does
hole.
time turn into a direction? What'd you say?
Well, it's the weird thing about relativity, the weird thing about Einstein.
Not famous,
The direction
known.
you thought was a space direction. Inside a black hole, it's really a time direction. And you are forced always to move forward in time.
Yeah.
So you're dragged
Come on,
willy-nilly
guys.
toward the center of the
What are you
black
guys
hole, and you
fucking
can't get
doing?
out because
Trying to
get out,
ridicule
you
me?
had to go backward in time.
So time,
Yeah.
and time reaches a point at the center of the black hole where it doesn't exist anymore.
Well, you get to the center of the black hole and you have a singularity. We can discuss that later, and
Yeah, come at me.
may give us some visualization.
Right.
We can talk.
That's where you die.
Wow. What? You die?
But I wanted to get to where I
Why
would
would you
age
die?
slowly,
Are
and now
you
got me
reborn
ahead.
again?
You want to age slowly.
Are you reborn again in through God? And I am the
So
Son
they
of
can
God?
make face cream out of these little black
Holy fuck. Holy fuck. I am the Son of God. To remind you to be just
Robert,
chill.
let me ask you.
How can
were
you guys
these
be
black
joking about
holes,
this stuff?
Around at the time of the formation of the universe? Would you rather answer? Yeah, sure. That's
well,
Raphael.
Not as far as we know. It's possible there's some speculations about what might have happened in the early universe that include the formation of very small black holes. But the black holes that you discussed could only have formed after the first stars formed and burned out their fuel, so that what you described happened. That radiation no longer holds them up, and they
So
collapse in on
they
themselves.
pretty much only occur as a result of a star burning out its fuel.
Yeah, so the earliest time would be millions of years, probably. Not, certainly the ones that most of the ones we see would be much older, much younger.
Yeah.
Would have formed much longer.
Andrew, what
I'm
about
younger.
the
I'm
stars
26.
There's a black hole.
How
in
old
the
are you
center of
guys?
the Milky Way, right?
That's right.
We know that for sure.
It's probably the best observed example of a black hole, of what astronomers call black holes. We don't actually see the thing looking like a black hole because it's way too small to see. But we do see, Andrea Gheze's group at UCLA in particular sees stars buzzing around a place that corresponds to the center of our galaxy. These stars are buzzing around, and we can tell from their orbits, or she can tell from their orbits, that what is there is weighing in at 4 million times the mass of our sun, and yet it shows no light
4
in the
mil.
infrared. You have to look in the infrared because you can't, if you look in the visual,
Right.
dust and gas gets in the way. So you look in the infrared, you don't see any stars there. You see a 4 million solar mass thing
Interesting.
providing the gravitational pull which is causing these stars to go around.
I think we actually have a movie of this from Andrea Ghez.
You have a movie of this?
Yes.
Oh, that'd be great.
There we go.
Okay.
So you see.
Where's the black hole?
So, well, look at
I'm
what
right
everything's
here.
going around. You see.
Everything looks like they're
There's a
going
star
in
there.
different
It's
directions.
the star.
Yeah, right.
It's the star
thing.
Each of those round
So that's a black hole. That's
Let's
kind of like
replay
me.
it. Let's replay it.
I mean, I know a black hole is black and you can't see it, but
These are the orbits of stars going around that thing that
Oh, it's colorful and colorless.
you saw something came in, it whirled right back out, right where that star is at the center.
Yeah.
Another object went around it in a more elliptical orbit.
Now,
but you don't see the object. They've put a star in there. They should
Oh,
have put
no
a black
shit.
hole in there.
Right.
You don't see me?
Well,
the
are
star's the
some
one
of
thing
those
that predicts
stars going to eventually get drawn into the black hole, do you think?
Andrew?
Well, the stars that we see are actually the ones that have survived. They don't get close enough to be tidally torn apart, but presumably there are stars, or there were stars, that got a little bit too close and got tidally torn apart. And once that happens, the gas that they were made of is going to stream into the black hole.
Now, my guess,
Wow.
hearing that, is that the black hole has at the center of our galaxy has some kind of structural significance. It's at the center of the galaxy. Is it holding the galaxy together in some way, or what?
No.
It's too small
I'm
by
combining
itself.
all
It's
knowledge.
a mere 4 million times the mass of our Saturn.
Yeah.
And the galaxy comes in at hundreds of billions of times the
No,
mass of our
I'm
Sun. So it's just a
I
small
could be
piece of our
really
galaxy.
here.
But it certainly dominates the central region of our galaxy. Its gravity is dominating the gravity in the central region.
Will you always find a black hole when you observe a black hole through this indirect process? When you observe that there's a black hole in a galaxy, will you always find it in the center?
No, we see two types of black holes. We see supermassive black holes like the one at the center of our galaxies, and those always
Like your
seem to
video
be
versus me.
at the centers of our galaxy. Now, I'm not sure whether that's really always true, because the astronomers tend to look at the centers of galaxies where they expect to see these things. But we also see stellar massed black holes in
Are
the
you
Milky Way,
investigating
and those are not at the center.
I see. So my
Stellar.
impression, because they're in the center, thinking everything's swirling around them,
Yes.
they got there some other way. It's not. I mean, it's not that they're causing this this galaxy to form around them.
Oh,
Well,
certainly
yeah, I
have a
am,
tremendous
because I'm
influence
alive
on
until I die,
the
and then I
galaxy
just don't have any
surrounding
impact
them.
on
They
anything.
may well moderate star formation in the galaxy as a whole. But we think that those central black holes, we don't know for sure because we haven't seen one form directly in front of our eyes. But the leading idea is that they formed in the usual way, you might say, from the core collapse of a massive star, and then accreted gas from the surroundings. So the center of a galaxy is a very special place. It's a place where gas tends to funnel down to.
Internet?
And you said they accreted gas, and that
internet?
is tied to the term accretion disk, right? Where you can tell a black hole is there in part by seeing stuff light up as it falls into it. Is that right? Is that an accretion disk?
That's about the only way we see them.
I see.
By
Accretion
virtue
disk,
of
no
the stuff
shit.
that falls onto them.
Holy
So
fuck.
we're, Kip, this is,
Sorry, guys.
does this come out of Einstein's theory fairly directly, the notion of a black hole? Did he predict it?
So it comes out of his theory so directly that it was the first mathematical solution of his equations that anyone ever found.
Wow, it's me?
Karl Schwarzschild, a great German astrophysicist, found it
Who?
a matter of months after Einstein formulated his general theory of relativity.
What?
However, it wasn't well understood at that time.
What are you talking about, dude?
We had this mathematical solution that described something.
It's God.
But everybody thought of it, well, this is the external gravitational field of
Are
the
you have
star.
fear? Do you have fear?
But
Of
if you
God?
look at the mathematics of it and you take away the star, there's still something there that's pulling gravitationally. And it was
No.
really not until the
No.
era of, and the work of John Wheeler and colleagues in the late 50s, early 60s, that we really understood clearly these black holes. Even though the
No.
mathematics of mathematical solution, Schwarzschild solution, had been around by then for nearly 50 years.
That's interesting. So people
Not
knew about
interesting.
it, but they didn't believe in it, or what?
So it was just very hard to get a physical handle
No,
on the
I
meaning
am
of
black hole.
mathematics
Sorry, sir.
when the
I will show you.
mathematics is saying that time is flowing in a direction.
Well, I can understand the
this direction.
difficulty, yeah.
Yeah. Nope. I will show you. Yeah, I got you. It's okay, buddy.
There is, and we can get to this in more detail, but
Sorry.
Professor Hawking's
Virtual hologram.
Hawking radiation seems, when I hear about it, seems to go against the idea that nothing is coming out of a black hole. Can you say that Hawking radiation, is that coming out of the black hole, or is it coming off of the black hole?
It's coming
What do you think?
Well, it's actually
to describe the black hole.
one way to understand it is that
I know who
quantum
Stephen
mechanics allows
Hawking
for
is.
a brief time to have a pair of particles to be produced.
And
a particle and an
for
antiparticle.
me and him,
That just happens very close
he
to the
just
horizon.
was
one
known
can fall in,
and
the
quoted
other
for
can get
things,
out.
and the whole God
And,
thing was a
it's
very
even more
anti-thing to me.
Bizarre, because the particle that falls
And
in
it
has
was
kind of
what
negative mass. So it
almost
eats up a little bit
everybody
of mass.
just used,
So
and
if
I
you
can't
really are asking where
say because I
everything
just
is coming
always had
out,
that young connect, and I
think
know
that's-
I
that's
feel that in
already
my
a
heart.
caricature of the calculation, of course, but then it's not really something that passes through the horizon.
It's not coming, when we hear about Hawking radiation, it's not something that's coming from inside the
I
black
think
hole,
I
going through the horizon and
superposition
coming
him.
out the other side, right?
No, that's not.
It's something that's happening on the surface, at the
I
at the
superposition
horizon, right
it.
about at the
I'm
horizon.
philosopher
And
Chris
it's
Payne.
coming off of
Yes.
the, and this can be measured, right?
Yeah, so
Yeah.
Jessica, maybe the Hawking radiation slide will help you describe this.
Who's that?
Jessica was searching through her slides. You didn't expect this at this point.
Was that that other last girl?
When you have somebody who's just curious and not organized, you get this.
Okay. Okay.
Is that it?
So,
Wow.
yeah, so you might.
Was her name
I don't know if
Jessica?
you can see it. Do you want to comment it, or I'll just repeat what you said?
It's your picture. Such a beautiful picture.
Okay, so if you look on the left, ignore the thing on the right.
Okay.
On the left, you see two astronauts falling into a black hole.
Wow,
They're
you guys
watching
are fall.
what
You guys
happens
fell into the
when
black
Hawking
hole with me.
radiation is created.
Is that this girl's name
What
Jessica?
you see happening is that there are.
Are you guys
a
serious?
particle, an antiparticle pair that are forming. You see, say right at the very top of the left-hand side, you see an arrow with the particles flying out.
Fuck advertisements.
Another arrow with the particles flying in. They're very close.
Corporate.
They've been created as a pair by the
Brilliant.
intense gravitational field of the black hole. They've been pulled out of nothing. And the one goes out and it becomes part of Hawking radiation. The other one goes inside the horizon and is lost. And this can only be done in pairs.
All of the
This is-
senses that make up
I
your
was going to ask you
experience.
why, and I think you answered it just now.
This
Why?
sounds instinct, which stimulates
these-
all of the senses that
am I right
make
about
up
this?
your
These
experience.
are pairs,
Everything
paired
you've ever
particles
tasted, smelled,
that
touched, all of your
pop
memories.
in and out of existence
your entire
all
life,
the time.
from the
Right
day you're
here,
born
right now.
until
Yes.
in any
So the
physical
one
system, it's
amazing
often really
thing
useful
of
to quantify
understanding
the amount of
the
ordered
quantum
structure
theory
in
of
that
particles
system to do
is that
your
even
memories.
empty space
Your
is
entire
very
life,
active,
from the
because
day you're
continuously
born
we have
until the
these
day you die.
particles. Of course,
This
they're like what physicists call virtual particles. So they're very brief, and basically, quantum mechanics, anything can happen if you do it fast enough before it gets detected. So
Right, sorry, guys.
It's like in life.
Exactly. Yes.
Wow, what is her name? That's
and
insane.
it's that phenomena. So really
her
thinking
name
of empty
Jennifer?
space is already very challenging.
Right.
But thinking of empty space in the neighborhood of a black hole produces these kinds
Now
of
that's the thing. You just said that there's it's
Hole,
so.
we
I
fought.
think you said it was so energetic around the surface of the black hole.
Yeah, so I think the point is this is happening right here, but these particle and antiparticle pairs, they pop into existence and then out.
Right.
And they can't stay in existence for very long, a very, very short period of time. But if you have
Right
a
now.
very powerful source of energy that can basically pry them apart and give them enough energy to materialize, to become real particles, then they materialize, become real particles, and
If I
fly
become
apart.
real.
That's what the gravity does. If you're very near a black hole, there's what we call tidal gravity. You're pulled more
Tidal
strongly
gravity.
by the gravitational pull of the black hole at your feet than at your head, and it's stretching you.
Right.
So this pair of particle
Wow.
and antiparticle, they flash into existence and they're ready to disappear because they know they can't
Because
exist
they
very long.
annihilate each other
They're going to
ordinarily,
annihilate each other ordinarily, but this
Wow.
tidal gravity
They
that
would annihilate each
try
other.
to stretch you apart, it pulls them apart, gives them enough energy
Yeah.
that they materialize, one of them flying out and the other one going in.
So what do we do with that radiation that's coming out of them? Do we study it? Do we learn anything from it?
Well, of course, it's.
Marfio was nodding his head.
Unfortunately, and you're asking me?
It wasn't you. No, I was.
Oh, Raphael. Okay.
Well, I think it's important to keep the upshot in mind. So independently of the mechanism by which radiation comes out, what does it in the end boil down to? What it boils down to is that the black hole is boiling off. It's slowly radiating
I'm
away.
boiling
all of
off?
its mass is fizzling
What?
away, And what you get in exchange is a cloud of what's called Hawking radiation. And in the end, that's all that's left of it. Now, that's not what would happen right now to the black holes that we see in our galaxy, because far more stuff goes into them all the time than Hawking radiation goes out. But if you left the black hole alone, put it in empty space and just let it be, and you gave it a lot of time, and you open your eyes again, what you see is this cloud of Hawking radiation and no black hole.
How much time is a lot of time?
A hell of a lot of time to use the technique. It really takes, but you know, and it's one of those questions
I'm
that
a philosopher for a long time,
perhaps
forever.
it's
I'm
not
doing it
of
for my
some immediate
humans.
practical importance to us, but it raises deep, profound questions about how nature works, because when Stephen first did this calculation, it seemed like this cloud of Hawking radiation bore no trace.
Why are you fearing? Fear God. Fear God, sir.
But you raise the idea that
Thunderstorm could
that I
come
don't think we've
anytime,
heard
any
yet,
crazy shit.
that a black hole can eventually evaporate. Now, this is after a certain amount of Hawking radiation occurs? Not because it's giving stuff up.
No way.
But because it's getting too many of these anti-particles.
That's really the same thing. You know, so
Right.
one way.
Well, rainbow bodies
it's-
exist, and you can
it's like
disintegrate your
saying
body.
that,
That's what they
you know, if
say.
you owe somebody money, or you know, or your paycheck gets reduced, either way, you know, you're making.
So that's what you're
less.
doing.
And
Sorry.
It's really the same thing. It's like what would happen if you
No.
have a pot of water
No.
and you boil it for a long time.
Uh-huh.
After a while, there's no water left, and everything is just got off in the air.
Sorry.
It seems sort of, I don't want to, I'm just trying to understand this. If
First Amendment,
the
bitch.
Hawking radiation occurs because
But it's not even that. It's just like I want to just combine everything.
separate a little right by the surface, and the antiparticle goes in, and the other one goes out, then you're adding to the diminution of the black hole.
Exactly.
Right.
And you're as far away from this black hole.
Mhm.
You don't really see what's happening with these negative mass particles that are falling into the black hole and making it smaller and less massive. What you see at the end of the day is
you
a
don't.
black hole getting smaller and a lot of stuff forming a cloud outside of it.
Now, if you have how small a black hole can you have?
As small as about the weight of a gram of sand, of a corn of sand, so a 10,000th of a gram.
A grain of sand?
10,000th of a gram.
Would that last
What?
very long?
That one wouldn't last very long at all. It's those astrophysical black holes that we actually see. Those would last for an extraordinarily long time.
So how long is not very long for a little black hole?
10 to the minus 43 seconds, so that's...
10 to the 43 seconds?
Much less than 1 second.
10 to the minus 43.
Yeah.
Well, wait, let me get this. I have a...
Oh, it's too late. It's gone already.
George Bush?
So
Oh, Trump? Oh, fucking...
light coming out, right?
The fucking...
Of the black hole.
There is.
9/11.
Well, that's coming off the black hole from the way we've been describing it, not
Sorry.
coming out of it. Because when you say out, in my mind, I think simply it's coming from inside it, but it's not. That's not good. The light is coming
No.
off the surface.
Yeah.
I
Yeah.
hope he doesn't mind our saying that.
I don't. I don't. I forgot your name, sir. Actually, I apologize.
But you can't see anything that's in there itself.
No.
So how did we first know it was there? What was
How did I first know it was there? I had only myself.
Like any black hole.
I had a lot of doubt.
Pointed you toward them or what?
I really had only God.
I think we should distinguish two kinds of black holes, the tiny ones, for which the Hawking
The
radiation
third one is the right one.
extremely
I'm sorry. It's the triune.
Almost paradoxically, the smaller the hole, the more intense the Hawking radiation.
And that's why it disappears fast.
That's why it disappears fast.
Mhm.
I don't think those things should be called black holes.
Oh.
Because they don't behave like the black holes I study.
No, I am a black
My
hole,
black
sir.
holes are the ones up in the heavens, and they're gigantic. And the Hawking radiation is so tiny that you just forget it.
I apologize.
So the black holes we look at in the sky, because the Hawking
I want to show
radiation
people
is
how
so
to do this.
extremely weak.
Or
It takes basically nothing to overwhelm it in terms of any gas or radiation falling in. So those are one kind of object, and then the objects for which the Hawking radiation is very intense you shouldn't think of, those are not things down which you fall and you're lost. They're things that pour out huge amounts of very intense radiation.
I can, yeah.
They're dangerous to be around because they radiate you.
Can I, just parenthetically,
Wow.
can I ask you,
I radiate.
when you talk about these big black holes, it's understandable
I
to me
do.
that they're formed from big stars.
Yeah.
But when you talk about one the size of a grain of sand, there are no stars that size, are there? How are they formed?
Well, you can think of, I mean, there are some people who think actually this might happen, that, for instance, if you shoot particles together, as you do in a particle accelerator, if, in some sense you could make a very small but very intense concentration of matter, and then perhaps in certain theories these kinds of black holes can form. But indeed, as we were saying, they will immediately radiate.
Right.
So what you will have, you have something being formed,
Yeah.
and then it will burst into pieces.
Yeah. So
that should look very much what you have in a particle accelerator.
Yeah,
because
that's
you
exactly what you have, yo. We could do any. Oh my gosh,
the little bits and pieces. And then
I
you
can
try to
really
reconstruct
coordinate
what happened.
everything.
So have these tiny black holes been, or have the effects of them been observed by scientists?
No, I need to just. Can I
important
gather
effect was
people?
that
Can
people were very
someone
worried about
help
that
me?
When the particle accelerator.
Okay, wow. So then, how did you guys get together?
Exactly.
CERN, people have been worried.
Like what?
Black holes. would
Who are
form,
you
but
guys?
From everything we've heard, they would.
Come on.
They would last only 10 to the minus 43 seconds.
They would think that it would.
But that could be enough time to do a lot of damage. Did I interrupt you before, Kip? No.
What?
So it's the other question is.
Okay.
Not only how did you find? Well, you were on the way to saying how you found them, but you find them through accretion disks and things like that.
Yes. So
Right, yeah,
the first
I just looked it up.
observational evidence for a black
Sorry,
hole was an object called Cygnus X1, which was an X-ray source.
Cygnus
You
X1.
looked at it. You saw that there were X-rays coming off of something that was inferred to be an accretion disk. The gas had to be orbiting around something.
Whoa, hell no.
The astronomers weighed that
Hell
something
no.
because this object had a companion, and so you could apply Kepler's laws to the orbit of the companion and weigh it, and discovered that this object weighed something like 10 times as much as the sun. And then you used what we understand about the fundamental laws of nature, which says that anything that is completely dark,
That was fucked.
aside from the X-rays coming off this disk,
That was
is
fucked.
pulling gas
Why did he
off
do
of
that?
itself,
Why did he do
and
that?
form this disk, but it's dark.
What?
And it's that heavy, and it's sufficiently compact. To
I
make
mean,
those
that could have
X-rays.
been
It can
helpful
only be a
to
black
something,
hole. So
but
that's sort of an indirect.
What?
That's
that's like a term people use, professionals
that
use
was
and shit.
a good enough piece of evidence
Wow.
for Stephen and me to make a bet.
Oh, tell us about it.
So this was our first bet.
Yeah.
And I have a habit of winning these bets with Stephen. This is the only time I ever get on the front page of the New York Times is when I win a bet with Stephen. But this particular bet was whether or not Cygnus X1 was truly a black hole. And what was required.
Which side of the bet were you on?
Oh, I said it was.
Yeah.
He
What?
said it wasn't. But
What?
he said it wasn't because he had so much invested in it scientifically, that in its being a black hole. He wanted to have sort of an insurance policy that it wasn't a black hole. At least he got something.
What? What?
And-
Okay.
How was this
Not you.
settled finally?
Well, it was finally settled as the astronomers, and this is the combined work of hundreds of astronomers studying this object in great detail.
Okay.
Ultimately build up a case that got stronger and stronger and stronger to
Okay.
the point where it couldn't be anything but a black hole. So I was in Moscow in, I guess this was 1990.
No way.
And Stephen came out to Pasadena to give a lecture at
Hologram.
USC, and snuck into my office and thumbprinted off on the bet. While I was away, I came back and discovered this wonderful concession.
Oh, that's great. That's
Moscow would just
So
be fun for a turn up.
That leads me to wonder about
But
not just
why would I go
discovering
there?
them, but once we know they're
It's just
there,
exploring there.
since it's
Is it unlockable?
so dark in there,
I don't need to
can't
go
see
to like fucking
how do you
complete
and I
an
know,
objective.
Andrew,
I'm fucking chilling.
you've really done a job on this. How do you get us to see, to visualize what's going on when we cross the horizon of a black hole?
The wonderful thing
The
about
trust of
Einstein's
God.
general relativity is
And-
it's so specific about the behavior of space and time and matter, enshrined in a very simple, on paper, set of equations called Einstein's equations. And if you solve those equations, which is a prodigiously difficult thing to
If
do
you solve
in
the Bible,
general, but you can
you could
principally
do it.
solve those things and explore
If you solve these
what Einstein's relativity
everything,
predicts
you just become
in
to
various
exist
situations.
yourself, and I'm the black hole.
It's a prodigiously difficult thing to do.
I'm sorry.
But the theory is all there.
Yeah.
You can ask Einstein's equations what's happening, and it'll spit out an answer.
Yeah.
The visualizations that I do,
Yeah.
I didn't choreograph what was going to happen.
Mhm.
It was a voyage of discovery for me to see what emerged from Einstein's equations.
That's really
Right.
fascinating.
No shit.
Could you give a little example of that, of using an equation of Einstein's?
But nah, he set
and
up the
suddenly
equation
seeing a
to
picture
show
come
you.
up? Did it work as simply as that?
Do you want me to do some stuff here?
Yeah, would you?
No, we just test it.
Do some stuff.
You want me to do some stuff?
I was going to say there's an ominous black screen, but apparently not an ominous black screen here. Can we bring up what's on this screen here right now?
You want me to do
Here,
some
what's that?
stuff?
So you've all heard that we're going to see black holes today. Well, you're not. You're not going to see any black hole at all because, of course, a black hole is black, isn't it? The star of this black hole thing is actually the stars
Bad joke.
that form the background to
I know I
the black
am
hole.
white.
In particular, this Milky Way
Identified by some people, but I'm a
Mellinger
human.
gave me kind permission to use it.
I'm a
here,
human.
The most recent version of
I'm a human. You're in my black
Milky
hole.
Way panorama. So Axel Mellinger, if you're watching, thank you very much indeed.
Axon Mellinger.
This is rather an overachieving program. Let me start this going here. So whoa, 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 whoa.
Whoa.
See what I'm doing here? This is doing full-screen general relativistic ray tracing in real time. And the people that we have to thank for this are not so much the scientists as the video gamers. So all of you out there who've been playing with your video games, thank you for all the gaming software and the hardware, because that's what allows this to happen. So let's see if we can find a black hole. It might be hard to find one.
That's
here.
just
Let's
cool.
see if we can get one going
That hurts
here.
my brain.
Oh, that's good.
Sorry. It actually flexed
Usually they're
something
hard to
though.
find.
It flexed something though. It really flexed something though.
This one here.
Hold up.
though, I've
Oh no, we'll keep it.
It's,
You guys are good. I'll let you
I've
talk.
imagined that this black hole, this is a spherical black hole. Now, real black holes are actually likely to be rotating, and they wouldn't look like this. They'd look kind of an elliptical shape rather
like how
than
you guys dim the
spherical.
lights, too.
But it's hard enough to do these things with a spherical black hole. So we've got here a rather simple black hole, a spherical black hole.
Yes. Hey,
And
buddy.
I'm going to put on a couple of things here. First of all, there's a little map of where we are, just to orient you. Down here on the left-hand side, that's us. There's a green regime. It's not really to scale here. There's a green regime of safe, stable circular orbits. There's some yellow regime of unstable orbits, and then there's a danger regime, and then there's a red line here. And if we fall inside that, well, that's the horizon. Maybe we're going to get that. But first of all, let's stop this. Let's actually fire up the black hole flight simulator here. And so I'm going to go into a circular orbit. If you want to know how this works, there we go. We're now in circular orbit. This is now working in real time.
You guys just took me
We're
into a
orbiting the
black hole.
You can see that, can't you?
Holy,
It is
I'm a
actually
black
working here,
hole.
except with, I'm imagining this is the same mass as the black hole at the center of the galaxy.
Wow.
The reason I'm
So
choosing
you guys
that is
watched me.
we can go close to this black hole without getting tidally torn apart by the tidal forces, and that's a very wise thing to do.
Right.
If we went near Cygnus X1, for example, we get within about 100 times the horizon radius before we got torn apart. So choose yourself a big black hole. Okay. So just to show you that we're really in orbit, here we
Yeah.
are.
Okay, of what? Of me?
On the right-hand side, you see
Right.
a clock here, which
Yep.
is clocking our actual time in seconds. So you can see that
Yeah,
there's
why?
1,000 seconds going by per second. That's not because the black hole is distorting time here.
No.
It's just what we see on our watch as
Right.
time goes by. And if you see it slow down, that's because I'm slowing it down. If it speeds up, it's because I'm speeding it up. If you want to,
Sorry.
if you want to find an explanation of what's happening here, I can offer you no better origin than Kip Thorne's book. His prologue describes the journey precisely like this, Black Holes and Time Warps. When people ask me, where can I find out more about this? It's from your book, Kip, written almost 20 years ago.
Oh, what up, Kip?
I should tell you, I offered him a kickback this evening, but he declined.
Sorry, bud.
So, as a special treat here,
Kip and
I'm gonna
Kip and
fire you
philosopher
in,
Chris Payne.
into this black hole.
Thank you.
Right
You're welcome.
Right here.
Kip, Stephen Thorne, and
if
philosopher
you remember
Chris
in your
Payne.
book, Kip, it was you sent in Arnold, right?
Who?
Arnold was the robot that you fired in, and you were going to watch it. And I thought,
Nah.
well, yeah, the governor of California, probably a powerful person here. But what was his catchphrase?
I don't remember.
Fart Arden.
I'll be back.
Gastronomer.
So how could you choose that? Arnold, you sent into the black hole. The one thing he's not going to be is back. I need a little audience participation here. You can see the orange thing here. This is where we're going to throw Kip. We need a vote. Who thinks that Kip is going to fall into the black hole?
He already did, I thought.
Raise your hands if you think. So, and panel, I want you to do this too, because I want to challenge you too. Okay?
Okay.
Who thinks?
How, he's that close to the edge?
Well, I'm going to fire.
Yeah. No, he's there.
Got my left.
He's there.
In it.
Kip.
He's going to fall in.
Is he going to fall in? Yes. Raise your hand if you think it.
Who can save him? Is something gonna
Kip,
just...
go ahead. Good. Robert, you can lower your
No, that doesn't count. I
I
know.
don't want you to feel stupid here, because we had half our panel say yes and half our panel say no. It's rather like Kip Thorne and
What?
Stephen here disagreeing. They can't agree on something basic like whether a black hole exists. Let's see what happens here.
Kip.
So I'll fire it off.
I'm
Oops.
sorry, Kip.
Let's
What's
kick
that?
this
A
back and
cube.
slow it
Ooh,
down, 'cause
cool.
it
All right.
happened rather
But Kip,
slowly.
Kip.
Let's back up. This is something that you can't do, by the way, in reality. Even
No
near
shit.
a black hole, you can't. Let's bring him closer.
No shit.
Come here
Hello.
and slow him right down.
Oh, shit. Oh, shit, yo.
There we go. There we go.
No way.
Now, Kip, you know that I took your photograph last night. Indeed, I took photographs of all of you, so you know where you're headed in just a moment. Here, it was my daughter who took those photographs, and this morning drew these portraits of each of you. So I thought it would be a wonderful
Why would it be
thing.
your
I think One of
daughter?
the highlights of this festival, at least
And
for
you brought
me,
it up too?
is the marriage of art and science that we're promulgating to you today.
So is your daughter in the audience?
Wild, are you there somewhere?
Wow.
Should stand up.
Oh, bravo.
That's cool.
Let us proceed and
Good
see
for
if
you,
Kip
man.
does his job by falling in like Arnold
Appreciate
does.
it, dude.
Let's speed him
You
up.
didn't have
We
to
have
do
to.
that. You
I've
didn't have to do that.
I've made him spin so that you can see how fast he's going.
Yeah,
Well,
you didn't have to do that.
uh,
Now where we at? Yo, stop.
at first cut, it looks like he's there in case you want to see. You can get out the telescope and
Yes.
say,
Hello.
bye-bye, Kip.
Hello.
Well, turn off the telescope here.
Okay.
Moral
Wow,
of this story.
yeah.
If you want
No
to
shit,
aim,
so
you
I'm
actually
just a
have to
floating
aim into a
head.
black hole.
No wonder Stephen Hawking is there because he's
they don't
totally
actually suck.
disabled
carefully,
and he's totally
and,
recognizable.
Probably know which way I have to aim in order to send the next panel member in, right?
Yeah. Sorry,
Where do I
guys.
have to aim?
Bring him in.
So you're in a circular orbit?
We're in a circular orbit around the black hole, yes.
Right. No
So
shit.
I guess you better aim backwards a bit. We can aim backwards a bit, I hope. Am I right?
A what?
If you were a footballer, you'd know the answer.
Kip, man. Shit, bro. What are you trying to pull?
Send it where the football's going to the passer's receiver's going to be, right?
Football, yo,
So
you gotta
let's see
play
if we
football
can,
out there. You can't play.
let's see, who's
Can
our
you
next
throw football?
member here? So I'm
The
gonna-
guy
it
next
looks
to
to
you
me like
can't.
Black
Oh
Hole's
man, I wish I knew names.
Send. Ooh, let's
You guys
send-
are cool
We
though.
lost Robert.
Who's Rob? Who's Rob? Oh,
Let's bring Robert back.
yeah,
And slow him
yeah.
down.
Rob.
Robert gets quite
Who
excited.
wrote this? Who drew that? Your dog?
Let's come here.
That's Rob. That's a bet.
Slow down.
Cool, bro.
Slow down. You're upside down, Robert. I'm sorry about that.
Sorry.
But rather a nice
Wow.
rendering, don't you think?
Oh yeah, Robert from the other one. Yeah, no shit.
Okay, let's send Robert in and see
What?
his fate is.
What?
Go for it. There we go. That's a decent lick. Doesn't waste his time, does he?
Okay. What if I close my eyes?
Missed.
I'm gonna close my eyes.
Wow.
Now what?
Did you see some interesting gravitational lensing effects there?
Yes, yes.
Very briefly.
I did,
it's
yeah.
hard to do this, by the way, because this is interactive.
Oh,
with the video.
stop it.
So sometimes
Oh,
you get it,
no.
Sometimes you don't. Let's try again.
Oh no, dude! You guys get it. You're all trapped.
Side here, and I'm going to slow this
Oh no!
so that we don't lose it. Come on, go for it. There we go.
What? I'm not gonna lose it.
Now,
Who's
slow
this?
this down.
Yeah. Yeah, yeah.
What do you see that
Yeah,
all the members of
yeah,
this panel
yeah,
have
yeah.
in common?
We're extremely handsome.
We're extremely handsome,
Yes.
all white. all male,
Me?
right?
I'm pretty lit. I don't
Which
know.
is, I think,
It's
this is a little
relative.
bit sad. This is Vera Rubin, who was
I
at the
don't know if
gala
I'm handsome.
performance yesterday.
I get told all the
And
time.
She was there. I come from an astronomical background, and seeing Vera always gives me a shiver up my spine when I see her. She was one of the very first women faculty members, and
It did
I'm
look
rather
like a-
proud as an astronomer that
What?
we have some women who go back a long way of having made pioneering discoveries. So I thought it would be appropriate, since we only have males. Maybe it's appropriate to be sending males, white males, into the black hole because we have a surplus of them. But I thought it would be appropriate. I don't know if Vera is in the audience.
I mean, they control
here.
the world.
Are you here, Vera? Never
Vera.
mind. She's probably doing something useful. Some real astronomy and some speculation.
Did Vera discover
Vera Bradley, my bag.
She was one of the people who was one of the.
I'm trying to.
not the
I mean, I'm not even
discoverers,
trying to
but
get money.
charted out the rotation
Come
curves of
support my
galaxies to
life.
show that galaxies were full of dark matter.
That's what I mean.
Yeah. No. But, I mean.
Off you go, Vera. Let's see
No.
if Vera makes it
No.
to this
Damn.
exercise.
Vera, no.
Come on, Vera. You're a lot better than the rest of us.
Me?
She did. She went in.
Me?
So the women beat the men in this particular case. If you call falling into a black hole, beating the situation. If you didn't see her fall in, you can see here, this is her frozen and as we say, redshifted on the horizon, because the wavelengths of light that come off from her would be shifted into the red and infrared.
Wow.
Let me
You
brighten
guys
it
see
up
me?
a little bit, so maybe we can see Vera on the horizon and turn on the telescope here. Wow, look at that. There she is.
Yep.
Now, in reality, you wouldn't see Vera frozen on the horizon like that at all. That is her image.
Wow. Oh. Little bead, a kidney stone. No.
Can you see? That's
Little
Vera
bit of lips.
frozen on the horizon. Now,
Oh, wait,
from
that's
her
that
own point of
lady.
view-
No way.
It's hard to keep up with this, isn't it?
That's that
From her
lady.
own point of
Holy
view,
shit.
She has fallen into the black hole, and all we are seeing is an image of her frozen on the horizon.
Why is she, would she, if she were...
Wow, did
in
you
a-
see
by a
Robert
black
just go
hole,
by?
Would she actually
See
be
what go by?
frozen there?
She would appear, at least from a classical, non-quantum perspective, to be frozen on the horizon.
Yeah.
So is that just an optical illusion?
That's just an optical illusion. Let me just see. Who else is it? See who I've got lined up.
Good guy. Who said that? Who said that?
This thing, because I think it may help.
Kip?
The next one may help us.
Kip?
Oh, look at this. Yes, this is
Harambe.
Brian Greene, by the way.
Harambe.
Slow this one down. This is Brian Greene.
Brian Greene, the host of the last episode.
I have a little story about him. He has 3 eyes. He was also drawn by my daughter here. And we wrote a paper last year. When I say we, Weil illustrated this and a postdoc wrote this paper. Let's slow it down again. We were interested in 3D visualization of black holes. 3D is all the rage
be running
now.
some
And
shit.
we thought, well, let's do something nobody's done before, 3D visualization of black holes. And for me, it was a puzzling thing to do because if you are in curved space-time and you look with your binocular vision,
Right.
the trouble is the curved space-time curves the spherical light rays hitting your eyes, and you use essentially the radius of curvature of the sphere of light that's entering your eyes to determine how far away it is. That's how binocular vision works. And that is destroyed near a black hole because it curves space so much.
Yeah.
And I thought, well, that's terrible. We're never going to be able to make 3D movies of black holes.
Oh, yeah, you can.
Bad
What?
idea, right? If
Huh.
You're going to make a 3D movie of a black hole.
A 3D movie?
Well,
What's a 3D movie?
I realized
Let's
that
make-
this
whoa.
is merely a limitation of people with 2 eyes. If you had 3 eyes, you could sort of triangulate the ellipsoidal wavefronts and you'd be done. So I thought this was a wonderful...
Where are you
thing.
going
Let's-
on?
let's send it
Triangulate?
in.
Okay. But
And I want
got
to-
me a little lost. Still in the horizon, event horizon.
Actually, you know what I want to do? Let's go down.
The Harambe
Visit
didn't
the
really
black hole.
settle it. It was fake.
Let's
It was
go
fake
into
news.
a closer orbit, because aiming at black holes is a difficult thing.
I agree, buddy.
show
I
us what it
agree.
looks like
And that not
inside
even
the
who the
black hole?
what even is
We're
that?
going to get
That you got out of Einstein's equations?
Yes, we are going to approach the black hole.
Yep.
We'll do that. There's Vera stuck on the horizon.
Oh man.
And here we are in orbit around the black hole. Let's make this real time.
Okay.
There we go. This is real time. If you were in orbit around the black hole at the center of the Milky Way, this is going by around 1 second per second. You can actually see the sky move. Now the black hole at the center of the Milky Way.
By the Milky Way. Some song. Oh,
the
sorry,
radius of
bro.
our sun. So
He
that's a
cringed.
pretty big black hole. It takes just a few minutes to go around
Minutes.
in the orbit of this thing. Okay, I showed you Brian Greene.
Something about the Milky Way and
want to
oh,
show
that was
you
a song. That was a song.
Another thing here.
That was a song.
So
I could tell right away that the
see what
Milky
else
Way
we have
something.
here. You're going to come out.
You guys know if
There
you
we go.
know. If you don't know, you don't know. What is this?
So this is the referee's report.
All right. So
that
the
we got on
words,
this article.
language.
And I'm gonna,
It was well written, entertaining article, and I enjoyed reading
right
it.
here.
Yes.
And the reason
Doesn't
I'm showing
contain
you
new
this, I
results.
wasn't sure that I should show you this, but I asked Kip
I
Thorne
feel
in class,
like-
he said you should show this.
Why?
And it's a little moral story here.
Like, do you do this
it
to
says that
everybody?
This is a well-written, entertaining article, and I enjoyed reading it. However,
Is this
although
what
it
you
does
do for a
contain some
job?
new results, I feel that it's jolly black hole style and content, e.g. figure 11. Can you imagine what figure 11 would have been?
No.
It was the three-eyed ape. Would seem out of place in a sober professional journal like
Yes.
whatever
Sorry,
it is.
guys.
Moreover, it would largely
Yeah.
be aimed at an audience. Sorry. Moreover, it would fail to reach the audience it is largely aimed at. So the reason I'm showing you this is I think there are real barriers between
Kip.
science and art. And some of those barriers, in spite of the present
No,
are
sorry.
coming from ourselves. We judge ourselves and we say, that is not appropriate for a science journal
No.
because it contains some art. Now,
No,
I think Weil
it doesn't contain art. It contains like,
Okay.
So you're sending this review
No one else
to a
is
black
talking.
hole, is that the idea?
and then
That is correct.
and
You know how
then
many times I wanted to
and
do
then
that?
Robert, like you just blew my mind. You know, some
This
of
is
you
one
guys
thing
I just
that
don't know how to
really
interact
black
with
holes
sometimes.
for. I
I don't
do
know what to
have,
latch on to. Come on now,
Sorry.
guys.
But I'm eager to see the inside of this damn hole.
Just a minute. I have to get in control here. Alan is trying to avoid being thrown in.
Well, once,
So the main difference with Alan is I'm letting him be tidally torn apart as he falls in.
I'm getting longer and longer there.
And you got longer and longer and longer. Okay, you want to fall in and actually
I want to look
happens.
around in there, yeah.
Yeah, okay.
You fell in
First
what?
thing that has to be said that is that Hawking's radiation has a profound influence on what happens here. What I've shown you here
Facts.
is people freezing at
You
the
didn't
horizon,
fall in
but
anything.
reality,
What is he? What am I trying to
the
hide
wavelengths
from?
of light are getting very redshifted, very elongated, and the images of
I
these
fear
people
God.
mechanically would become as large as the black hole, and then their images would essentially be lost against the Hawking noise.
What?
I want to turn them off, and let's turn on.
Yeah.
A
Yeah. I'm the
turn on something that you
I'm
will
the
not see in a
superposition
real
of
black
Hawking.
hole, which is
Yo,
they-
pan the camera
they
to
don't
Hawking
really
real
come
quick.
equipped with a red grid.
Yeah. Oh
The
shit.
trouble with black holes
Holy
is when you
fuck.
fall through what we
Oh.
say is the horizon, there's nothing really there.
No, there
It's
isn't.
like falling.
Holy
over
cow.
Niagara Falls.
Oh, that's even worse.
Niagara Falls, there's a point of no return.
That's like
and
saying,
not where
oh, man.
anything interesting happens. It's only when you get in deep inside that something interesting happens. So let's fall inside.
So,
do a little
yeah. Why
reverse
doesn't
thruster
everybody?
maneuver here.
Huh. No.
And that should start us falling into the black hole. And let's see what happens.
Okay.
Whoa. Yikes.
Now, what these
Wow.
look like a bunch of little whirlpools that you can fall into on the surface of the hole. Is that what you're showing us?
These little things here, you mean like this one here?
Water.
That's just a grid that I've painted on the surface of a black hole, like lines of latitude. And
Are we looking at the surface, the
Yeah,
horizon?
he's good argument. He's
We're
backing
looking at
himself.
the
Sorry, dude. You're
surface
being
of the
pro. though.
horizon, this red
Right,
grid
so we
here.
haven't gone past the horizon yet?
We have
Nope.
gone inside the horizon.
Oh, we are. So we're now like in a narrow band within the horizon? Is that-
Yeah.
We're inside the horizon. We're actually a decent way inside the horizon.
Way inside.
Yeah. Are you guys
What-
gonna go
what's
over this
grid
video?
painted on? Are we looking at the other? What are we seeing? What's the grid on?
Right? You guys forgot? No way. I
Remember
blew
I
you.
told you when I first started doing this.
I blew your guys' mind. Yes, dude.
Well, that's where I am now.
So
Yes,
welcome to the
dude.
crowd.
Philosopher
And it took
Chris
me a
Payne,
year to
ask me a
understand
question.
this, so it takes you a year to understand it. Don't
Well,
blame me.
these people are going to be gone by then.
Technically, you could ask the audience a
Here-
question.
We have fallen through
And then
the
they'd be
horizon.
gone.
The horizon
Wow,
we've fallen
right.
through is this bluish-looking grid above us, what we call the true horizon. This other thing here is actually an illusory horizon.
Wow.
Which is a holographic image of what's inside the black hole. We'll get onto that later. When we go down to the horizon, we fall through the horizon, it appears to split into two.
Yes.
And the reason for that
Oh.
is once you're inside the horizon, essentially, space itself is falling faster than light. It's what Kip Thorne had to say, which is that time and space sort of change roles. Essentially, what's happening is space is falling faster than light.
Okay, everybody here, including me, has heard that nothing goes faster than light. But in the black hole, space is falling faster than light. Why? What's going on? What is it about a black hole that makes space fall faster than light?
I would say a black hole is a place where space is falling faster than light. Let me.
What?
Which is
Well,
the circular.
I would say red is blue. What do you mean that space is, what do you mean by that? We'll say it again.
What I mean by space falling faster than light is if you attempt to come to a halt at this point, to stop falling to smaller radius, you would have to be moving, you essentially have to be moving through space faster than the speed of light. Space itself is falling faster than the speed of light. You
What if I
cannot
just
move
block
through
this?
space faster than the speed of light. So the flow of space is what carries you inward
Space
into the black
itself
hole.
is that's different from me moving through space or anything moving through space faster than light.
That's right.
Come on now.
Space
You
faster
got
than-
what?
But space
How are you? What do you guys? What?
faster than light moves.
That's correct. Yes.
Well, that's a certainly weird thing that's happening.
It's why light can't escape from a black hole.
Well, that's worth coming to a lecture for.
Wow. You are welcome.
Yes, go right.
You
up to
are
the center.
welcome.
I can't wait.
I'm not sure that we're going to go through a center here. But
Thank
let's
you,
go as
philosopher
far as
Chris
we
Payne.
can, and,
You're welcome.
and let's see what happens. Now, this kind of black hole.
You could say it, guys. It's
charged
okay.
black
I don't
hole.
mean
It's
to be
it's
too
It's a
unprofessional, but
surrogate
like,
for
come
a
on.
rotating black hole, and what you're about to see is actually very similar to what you'd see in
Whoa.
a rotating black hole.
Huh.
They have not only an outer horizon, but
Ah.
also an inner horizon.
Okay,
where
so an inner horizon is like a globe within a globe, right?
It's a globe within a globe, yeah.
So stuff that comes in from the outside, like dust or something, or these, or an antiparticle,
Whoa.
goes in, and what happens when it gets to the inner horizon, the inner globe? What
Where-
goes on there?
We're about to see what happens at the inner horizon. What happens is that, which is something very remarkable
Water?
indeed.
You need
So,
water.
The outer horizon of a
All
black
humans
hole
need water.
is the place where, essentially where space is falling at the speed of light.
Mm-hmm.
It's like a waterfall of space.
Mhm.
The water's going faster and faster and faster, or space is falling faster.
Let's get water
The
tech
horizon is
down.
the
Come
place
on.
Where space is falling at
Don't
the
get me
speed of
started
light.
on this. I'm just
Space is
right.
falling
This
faster
isn't the
than
right
speed of
place.
light inside the horizon.
Water
But then
technology.
in a rotating black hole, there's a centrifugal force which tends to slow the inflow of space, and the place where it slows back down to the speed of light is something that we call the inner horizon. And that inner horizon is the location of some very strange and energetic phenomena. If you like, this is the bottom of the Niagara Falls. Roger Penrose first pointed
Trying
out
to
in
make me pee?
1968, if you pass through the inner horizon of a rotating black hole, you will see the outside universe infinitely redshift, so
Right.
infinitely blue shifted,
Whoa.
infinitely energetic.
Oh. Oh. Huh.
The particle,
Redshift, blue shift.
particle
What do
coming
these
in,
mean?
going through the
Explain
outer-
more, maybe?
the horizon.
Yes.
No, you don't have to.
Goes faster and faster and faster. Water going over Niagara Falls goes faster and faster. When it gets to the bottom, that's equivalent to hitting the inner horizon.
That's right.
What's different about the speed of its descent or its?
Of the space.
Yeah.
So you're going with the flow. You're going down the Niagara Falls.
Yeah.
But when you get to the bottom of the Niagara Falls, the key thing is that water that's kind of bounced up from below
Yeah.
is able to collide with the
Huh?
stuff that's coming
No.
back down.
Everything
No.
slows down there?
Wow.
I wouldn't say it slows down.
Wow.
I'd say it speeds up.
Yeah.
Well, that's similar.
No. I'm the superposition.
It has some of the same words in it, you know.
Yes.
Are you here?
Okay.
Hey, guys.
go ahead. I'm not interrupting. I'm trying to understand. Go ahead.
Okay. Okay.
That's okay. It's hard enough for all of us to do
Can you
this.
guys comment?
But as Roger Penrose pointed out again in 1968, this is a place where light from the outside universe, what we're looking at in this is
Light from the outside universe gets sucked in?
appears
No.
infinitely
Oh.
energetic, concentrated at the inner horizon. And now, if we
What?
continued on this journey, if this
You
were
don't?
an ideal black hole, the kind that
Huh?
Roy Kerr discovered in 1963, and as an ideal solution, mathematical solution to Einstein's equation,
What?
we could go through a wormhole and out to another universe. But in reality, this
It's cold.
infinite concentration of energy at the inner horizon cuts off that wormhole
Yeah.
physically.
Yeah.
And instead of
What's the
going
next
through a
video
wormhole
I
to
can
another
find you?
place, we are vaporized by this instability.
Who are you?
Thank you very much.
Who are you?
Thank you.
You're vaporized.
You mentioned, Andrew, and
He's had
that
enough
was really,
beating.
I
Andrew.
can imagine it must have taken you an enormous amount of effort to get from the equations to those fascinating pictures.
Andrew
But you did
Hamilton, my
mention
man.
At some point, there was the entrance of the idea of,
I didn't know your name, but I know it now.
pick us up at that point, would you, Raphael? Where does
I just literally, I fucking totally forgot. Like I just didn't even register.
Well,
He was just like,
we all
he
know
was
what
just like,
holograms are. You know, you look
Well,
at them.
tell us again, because we...
Well,
Yes.
they're on your credit card. They're on all sorts of cheesy things you can buy in souvenir shops. And what they are is you have a two-dimensional surface and you look at it and out pops this three-dimensional image of something or other. I don't know, Beethoven's head or the
Are you describing a human?
and
What?
it's, you know,
Me? The
fun
black
because
hole? Yeah.
It gives you this illusion that there's something hovering above the surface. But
Uh-huh.
the reason we use this word in this context
Yeah, 'cause
is
you don't
as a
really-
metaphor for
What?
a situation
No,
where
you're good.
Three-dimensional information is encoded
Uh-huh.
in on a two-dimensional surface.
Okay, right.
It's as if one dimension
Sorry,
wasn't really
dude.
necessary. All the information you need, you can fit on a surface. And
Right.
what does that have to do with black holes? I suppose
You just
might
taught
be
me
the next
more.
Question: Why are these two things following each other in the title?
I didn't mean to
And,
violate you. I didn't mean to violate you.
That's a bit of a longer story, but it has to do with the deep questions that were raised by the fact that black holes can evaporate and disappear.
What?
So we mentioned earlier that if you leave a black hole alone, it's going to fizzle away, and what's left over is this cloud of Hawking radiation that it converted itself into. No more black holes, just a cloud of particles.
Wow.
And
Right.
when Stephen Hawking first
But
did
I
his
have a
calculation,
body. So you guys are
it
picking
looked
on me?
like this cloud of particles was going to be exactly the same,
What?
no matter how the whole story started, no matter what kind of star collapsed to form this black hole.
Yeah.
No matter whether you know
What?
atoms in the star were moving this
I'm
way or
still
that
a
way or
black
some other
hole.
way.
Look at my eye.
You could not recover that kind of information. Now, why do we care? It seemed like information was lost.
It was.
Physicists care about that sort of thing very deeply. They care about
Uh-huh.
global principles by which the laws of nature are organized. And until that moment, when Stephen did that calculation,
Advertisements?
there was a principle which is that information is never lost by any of the laws of physics that we know. By this we mean that if you tell me what the situation is now, I can predict with a big enough computer what it's going to be tomorrow, or retrodict what it was yesterday.
What is what?
It's like when you recover, marks of tires at the scene of an accident, and
What are you
try
trying to describe?
Recover what actually happened. People are contradicting each other, and you're trying to figure it out. Who ran the red light? What actually happened? There's a general principle in physics that if you look carefully enough at some object,
Right.
you can figure out what it was before.
So in this analogy you're using of a car accident, where the police will
Right.
go and examine
Wow.
the tracks of the rubber
Holy
on
fuck.
the road,
Holy
maybe
fuck.
scrapes on the car, paint chips, glass on the. This is giving them information about what happened in a past event.
Right.
Now, how is that related to information in a black hole? What do you mean by that information? Because I think the word information means a lot of things to a lot of people. Can you tell us what you mean by information?
Well, I think the best way to think about information is the way that you tend to think about it in everyday life. How much of your hard drive is already taken up by your files. Well, those files represent a certain amount of information each. The total sum is how much space is taken up on your hard drive. If you have too many of them, well, you're trying to store too much information on that hard drive.
Mm-hmm.
And it's
What hard drive?
it's a
computer?
very important concept in physics because it really tells you how complicated the world is. How much information do I need to describe a block of iron or
A lot.
a room full of air?
A lot.
Indeed, perhaps you can also ask the question, how much information do you need to describe any region of space and anything that could possibly happen there?
Well, we could take
So
what we
that
know and build.
information was, the notion was that the information couldn't disappear from a black hole. And that was countered by the holographic principle, which says that you can actually retrieve the information?
The holographic principle came into the resolution of this very difficult situation. So I really want to emphasize first why people were so agonized.
Depends on who controls
about
it.
this.
Let me describe how agonized they were.
Yeah.
'Cause
Okay.
Stephen did this work while he was visiting me at Caltech in 1974-75. He wrote a paper saying
Wow.
if a black hole forms in some manner and then it evaporates, you lose all information about how it formed. He couldn't get the paper published. The referees said, this can't be. It violates the fundamental laws of quantum theory. It
Yeah.
can't be. And so I saw him about 6 months later. We went to a conference in Chicago together.
No
He
shit.
said, I can't get the paper published. And I told him, keep trying.
You know, we don't toss out principles lightly in physics. Things that have worked
did
everywhere.
not like a paper that said that there's something wrong with the laws of nature.
So he had information that disappeared.
That's right.
Yeah, right.
So he did ultimately get it published, and so go on.
It was as if every traffic accident left the same tire marks. No
Yeah.
matter who crashed with whom, whether it was a red car with a green car, a truck with a
Right.
bicycle,
Whoa.
you get exactly the same
Christmas.
pattern on the street afterwards. That's crazy.
Just happened.
Right? And not only is it crazy, it contradicts everything else we know in physics. And the reason people panicked is that it's very difficult to violate a general principle a tiny little bit.
Right.
It's very hard to do that. You know, you have to explain why it's violated in this particular. What do black holes have to do with this? You know, what's so special about them? Why do they get to do something that nobody else,
Yeah,
no other object
yeah.
ever got to do before?
Yeah.
How can we prevent this from this sort of disease from spreading all?
Oh, wow.
So, I mean, I'm just trying to give you the sentiment here.
Holy
Okay, so the holographic
snap.
principle rode to the rescue here? Is that what you're
That's right. I mean, there was a long debate. First of all, is information
Holy
really lost or
snap.
not? You know, this claim was not made lightly.
For some 20 or
I
more
am-
years, this became a conundrum that was central, a
Totally.
central tool in trying to understand how you unify general relativity with quantum theory. If anybody could really understand it really clearly, that would probably be a key step toward understanding this merger of these two fundamental theories.
Wow.
Now, there are two steps,
Jordan.
really.
No,
when I
Robert.
make a black hole, and then I wait and let it evaporate.
Robert, help
I'm a
me
very
out.
patient person. I let it evaporate.
Sorry,
And,
buddy. No, come on.
And
I
there's
didn't
really,
mean to cut
in
you off.
both of those
Apologize.
steps, do you have
You're
a
right.
danger of losing information?
Right, right.
Now, historically, what
Right,
happened
right, right.
is that the evidence accumulated that in the second step, when the black hole evaporates, turns into this radiation cloud, information is not actually lost. That made it more credible that it's also not lost in the first step. The first step is the place where you take something like a star or 10,000 elephants
Right.
and you compress it
Right.
into a black hole.
What?
And
I'm still a
you
black
want
hole.
it to be true if you're an old-fashioned physicist who believes in the preservation of information. You want it to be true that by looking at this black hole in some careful way, you can tell whether it was a star that made it or 10,000 elephants. And indeed, there was a possibility that this was true around the same time when Stephen discovered Hawking radiation. Jacob Bekenstein discovered that black holes contain information on the surface of their horizon. And now that's where the hologram comes in. Now, for
What up?
everything to fit together, for it to be true that that information on the surface of a black hole was enough to remind us exactly which elephants went in or which star
Can I
collapsed,
stay?
it had to be true
I might
that the
stay,
amount of
buddy.
information that fit inside the horizon was no more than the surface area measured in certain units called Planck units
Yeah.
of the horizon.
Let's
So
get
you
to
can
it.
imagine
Measure
putting
me.
tiny tiles on the horizon and labeling them 0 or 1 if you
I'm not going to stop till I figure out how long I'm going to live by my body.
and there could not be more
But if I
information in a
can't,
region of
it's,
space
you know,
than zeros and ones that fit on a surface surrounding that region. And in the end,
God.
you can throw away the black hole. It had to be true no matter whether you turned the stuff that
God.
was in this region of space into a black hole or not. Who cares if I actually convert my elephants into the black hole? It's enough that I could.
I want to
It's
get off
enough
the
that I
elephants
could.
and get onto the car tracks again.
yeah. Nah, you guys got me
It
lost.
sounds like you're saying that
You know how to lure me in.
there are, to use the analogy, car tracks of some kind left on the surface of the black, the event horizon, right?
That's right.
What do you mean by that? Take us
A
from that
collapse.
analogy to something a little more concrete.
trans-
because it
my
sounds
body
to me like
disappears, disintegrates?
Something goes too close to the event horizon. It starts zooming in to the black hole. There's maybe some flash of light or something that
Unfortunately, the question that you just asked is among the hardest in physics right now.
Yes.
That's
Sorry,
what I'm
buddy.
here That's- for.
I didn't mean to pressure you.
Too bad.
Good one,
But,
guys.
Yeah, so the funny thing is that we've known since the mid-'70s how much information fits on the surface of a black hole, and we have great confidence
Mhm.
in that number.
Really?
Um,
Yeah, that's good.
But it's much harder
Thank you.
to say
But help me.
what
Maybe
the
I don't
actual
know.
objects are that are carrying that information. Are these little wiggles that sit on the
But it's something you can read, you can.
The best way to read it is to let the black hole evaporate and then measure the radiation. It's like, it's like something's locked in a box. Best way is to open the box,
What
let
if
it
I
come
just
out,
violate
measure.
everybody?
But that doesn't mean that your question wasn't an important question. It's one of the most exciting areas of research to understand what it is.
I'm not trying to
before.
violate you, but like, I'm bringing it up in a way that I know you guys are watching me, and like,
You've said two things.
I know what's going
One,
on.
that there's information on the surface of the hole. And the other is the best way to measure the information is to let the whole thing evaporate and then measure the radiation. That sounds like two different things to me.
Right.
Well,
Right.
one is that there's information
Because yeah,
there. so how
it
come you
wasn't
can't
even
read it
violent.
there?
Yeah, it's
You have
just
to
an
wait till it
impulse
goes
thing.
away
I
to
get
read it.
attacked.
The real question that I'm trying to get at is whether
it's like,
the information has already.
I could just
Never
bring you
mind
to
whether you
this
read it or
black
not.
hole.
You
I
can
am.
ask
I
whether
can
it
bring
has
you
somehow
here.
been
Like I'm
erased.
here. I'm here.
Right?
You may not be able to read it at the moment,
If
but
it
it's
was
there.
true, as we might naively think, that the amount of
I'm here.
information
I'm here.
in a region of space grows like the volume of the region. You know, you have computer chips that store your hard drive, whatever, some bits of information. You can pile them up into a big pile. Now, if you make the volume of the pile twice as large, you can store twice as much information in those computer chips. Right? It goes like the volume. It has nothing to do with the surface area of the pile. Who cares, right? You're filling, but
Yes.
fundamentally,
I need more
seems to be
volume.
true.
Wow.
That the surface area gives you the absolute limit of how much information you can store. If you
Robert,
try to do better.
You were going to add to that.
Well, I mean, I think it's important to stress that, it's a principle. It's not yet a fundamental theory, because what
Wow.
we're seeing is if you want to marry
Wow.
general relativity with quantum theory,
Wow.
you have this huge problem.
Yeah.
And we know the principle to its solution is this idea that there are extra degrees of freedom, some extra stuff
Yeah.
that's not
What?
in Einstein's theory, which is sitting close to the horizon. It's basically this hologram.
What?
So you need some kind of a theory that really has both
Okay.
of these ingredients in it. And for
Right.
instance, string theory is one such theory. And there are certain models in string theory that actually precisely do what kind of the doctor ordered in this case.
Wow.
And so there we can actually literally see this information in the black hole, and we can see the evaporation. These are not the kind of models yet that we would like to use for the astrophysical objects. But to really answer this question in full detail, we need this kind of theory of everything, where all these phenomena are acting together.
Yes.
And that's why it's such an extremely
Thank you.
important question, because a full, satisfying answer really requires such a fundamental description of nature.
So you can get information from, the information is
And I don't
encoded
even have to be
somehow
videoing
on the
it.
surface of the black hole that
But
tells, if you can read it, if you could read it, what's gone into that black hole in its history. Does this apply to any other parts of the universe? Does this apply to
no, man,
our
I like this
universe as
shit.
we
I
know
really
it?
do, man.
Is there some event horizon here that has all the information about us?
I do.
Well, actually, yes. Yes, that's a big topic. But there's a sense in which we live in an inside-out black hole.
We live in an inside-out black hole.
There is an event horizon that surrounds us.
No.
And it comes from the fact that
But I
the
add
universe
to the
seems be
actual
filled with something
everything.
called the cosmological constant or dark energy, which is driving the acceleration of the universe to
Of these
the
concepts,
expansion
man.
of the universe to accelerate. It's like you're on the
Yeah.
gas pedal. We used to think that we're on the
No,
brake.
not a
Actually,
gas
it's the gas
pedal.
It goes faster and
A
faster.
quality of life,
And as a
dude.
result
Are you
of
fucking
that,
serious?
things that are far enough away from us, they're like
Okay.
they're like something that's crossed inside a black hole.
You
They're,
get two
they're in a
types.
place where space itself is receding so fast from us that not even light can travel back to us from there. So
Yeah.
there's a sphere of no return surrounding us in the universe.
Yeah, there really
And,
is, dude.
All of
You
the
can blame.
questions
You're gonna
that
fucking
we're
blame this
confused
on
about
weed.
that have to do with black holes and information.
You're gonna blame this on
We
weed?
have to ask again about that sphere, and we're even more confused
What?
about
Oh man.
Okay, you know what? We had a late start, that's why I let us go longer than the announced time. But I do think we have to break up now.
I'm sorry,
I do believe
dude.
that some light has been thrown into dark places by tonight, thanks to
I'm
our
sorry,
very
guys.
wonderful
What?
panel and to the great
Who's going
Stephen Hawking,
next?
and thank you all.
Appreciate it, yo. Are we gonna go to infinity? And beyond? All right, let's get it. Sorry, guys. Who's this?
It's 8 o'clock. Do you know where your universe is?
Fuck, dude. No.
Start by imagining a tropical lagoon.
Okay.
To the fish that live here, this watery world is all there is.
Right.
This lagoon is their entire universe. They have
Yeah.
no idea there's anything beyond. Well, they are fish. And that theirs is actually just one of a huge number of bodies of water on Earth's surface.
Mhm.
Some like theirs, and some very different.
Facts.
So now that you are a fish, what if you got a clue that this world of ours is just a tiny lagoon in something much bigger?
Oh,
Could
wow.
your fish brain handle that?
Facts. Yes.
We humans always assume
My fish
our
brain
universe
handled
is
it.
one of
It
a kind,
handles it.
unique.
It handles it. Are
Even
you
the word
kidding me? I'm a
universe
black
reflects
hole. Sorry.
We think that one and only universe came into existence nearly 14 billion years ago with what's called the
Nope.
Big Bang.
Nope.
In the 1980s, a group of young physicists, including Andre Linde, Paul Steinhardt,
So he's just talking about the multiverse. I don't get this. Hawking radiation. Okay.
This program covers the basics of quantum communication and quantum computing, and it's particularly designed for people who want.
Okay, what up? Are you here, dude? No way.
Right. First of all, I honestly don't have much idea what I'm doing here.
Right.
Joe asked me Friday afternoon to do this, and I said, no, I'm going home
Friday?
for the weekend.
It's Wednesday.
Spend a pleasant weekend with my wife. We're going to go to the theater. I'll have absolutely no time to prepare. He said, it doesn't matter for these people. Don't worry about it.
Why? You need
They
to
don't matter.
leave? Do you need to leave?
So,
Do you need to leave,
number
sir?
one,
Do you need to
I'm
leave, sir?
unprepared. Number two, I don't know who I'm speaking to. I see in
Philosopher
the audience
Chris
a bunch
Payne.
of my black holy friends.
Philosopher Chris
But I
Payne.
assume I'm going to ignore them completely. I was told there's maybe
Nope.
a biologist or two here. Is that
You're
right?
not going to ignore me.
And an astrophysicist. I don't know. Okay, so it's a mixed group,
Right.
which is
Mixed-
fine. That's
mixed
good.
with the grips.
And the last thing is, quite frankly, I thought we would be sitting around a table. He said a lunch thing, and I thought we'd be sitting around a table like we do at Stanford in a civilized way, and one person stands up and talks while the others eat lunch. I did not expect to be in an auditorium giving a lecture.
Okay.
So, let's start, and it would be very helpful if you ask questions, because I'm like a wind-up doll. I wind
Kip.
up with questions,
Kip.
and then I like to answer them.
Kip.
But I'm going to begin
Right.
trying to tell you why my friends and I are joined together here to explore a set of questions
These
which
are
has come up,
students or friends?
I would say about black holes, but to say it's about black holes is much too narrow. It's
These
much
are your students or friends?
What we're addressing is a problem which has been around for close to 100 years.
Are you paid right now?
Problem
Where is
of
this at?
how to synthesize or how to put together quantum mechanics and gravity. It's been for a good number of years.
Jim
there
Short's
was very
nice, bro.
The subject kind of exploded with
Me?
the advent of Hawking's and Bekenstein's
Yeah.
discovery of black
Yep.
hole thermodynamics.
Yep.
And I'm going to tell you a little about that.
Okay.
But I'm also going to try to tell you exactly why we're here, to explore a certain paradox.
No.
Paradoxes are very interesting. In fact, it's generally the way forward when you simply don't have anything else, when you have no experiments, no empirical data, but you have a set of concepts, and a set of concepts clash.
yeah,
When a set of
yeah.
concepts clash, then you may have something to learn. Light traveling at the speed of light in every frame of reference, atoms not decaying down to the point where the electron falls into the nucleus, quarks not getting out of the proton and neutron,
Right.
the cosmological constant being 123 orders of magnitude smaller than the start of life, how life forms. All these are paradoxes.
Wow, start of life,
Sometimes
yeah.
they're really clashes
RuneScape.
in principle.
Level
And that's when we
123.
stand to learn something really new
Old
and really
British
exciting.
game.
That's hopefully
What's up,
what's
guys?
going on.
It's the #1 MMORPG.
Now, whether we'll be smart enough to crack it, I don't know.
Smart enough to crack me? No. What?
Whether we'll all discover perhaps
What?
that we were making a foolish error. No, whether we would discover that Joe Polchinski was making a foolish error. I don't know.
Joe Pazinski?
I don't think so. No, I don't think so. I think there's a big paradox.
Okay.
The big paradox will get solved. My guess is the solution will
What?
be that we were going on the right track before the paradox, but
Why did you
we
mention
were
Joe
missing
Pazinski,
something
or why?
enormous, some
Who's
big,
he?
huge piece of the story, and that we have a good chance to learn it now.
Okay.
So what is it all about?
Yep.
Well, it's about quantum gravity, and the first thing I want to say is that you should not think of quantum gravity as being quantizing gravity. Quantizing is an operation that we do on known classical theories. We take a known classical theory, we invent some hocus pocus called
Water.
Poisson brackets, and Poisson brackets, a formula. There's a rule, there's a set of rules. Dirac invented them. That has gotten us nowhere with quantum gravity. It's gotten us almost nowhere at all. And it's probably because quantum mechanics and
Hold up.
gravity are Poisson brackets, and Poisson brackets, a formula. There's a rule, there's a set of rules. Dirac invented them. That has gotten us nowhere with quantum gravity. It's gotten us almost nowhere at all. And it's probably because quantum mechanics and gravity are linked in a much, much tighter way, joined at the hip, as they say, in a way that doesn't allow us to separate them. Of course, we can study classical gravity.
Sorry,
there's
guys.
No doubt about that. But
He
some
finished
of
his
us
sub a
begin
little
to
later?
feel,
Yo,
I
you
think,
eating, bro? You
probably
gave it
everybody
away.
here,
Hold up, what?
that because quantum mechanics and gravity are linked in a much, much tighter way, joined at the hip, as they say, in a way that doesn't allow us to separate them. Of course, we can study classical gravity. There's no doubt about that. But some of us are beginning to feel, I think probably everybody here, that quantum mechanics and gravity are joined in a much, much deeper way, in an inseparable kind of way, and that it doesn't really make sense to take the classical theory and just apply to it the standard rules. Well, if the standard rules aren't helpful, and if
Right.
there's no experimental data, all we can do is explore these paradoxes which come up now and then. Most of the paradoxes have been about black holes. Why black holes? What does a black hole have to do with
Philosopher Chris Payne is a black hole.
anyway?
What's up?
My friend, who I
How
hardly
you
know,
doing? How you doing?
I don't think I really know him anymore. I used to know him
Really?
in 1976. Freeman Dyson thinks that it's a complete waste of time to think about quantum mechanics and gravity in the same breath.
Huh.
Quantum mechanics is, of course, applicable for applicable for very tiny things. Gravity is applicable for very big things. Why mix the two all together?
No, you don't get it.
And of course, the answer is it's just intolerable to have two theories
I can tell
which
you.
seem to clash and simply don't want to fit together.
Okay,
It's
so what are you going to do?
intolerable for curious people, for
Interesting,
people with
yeah.
a kind of itch that want to put things together into a neat framework, a neat universal framework.
Is this what you put together?
So, we're just obsessed with the question because we're curious about it.
This is what you have?
That's the only
This is what you do for
reason,
work?
As far as I can tell, I don't think quantum gravity is
Are you
gonna
serious
solve
though?
the,
Like, you really serious about this stuff? Okay. You sure?
climate change problem or the cancer problem or anything else.
Are you sure?
We do it because we're curious about it.
Are you
Okay,
sure?
now, why black holes? Black holes
Climate
happen
change
to be
or
the place
cancer?
where
What?
quantum mechanics and gravity come together. Despite the fact
No.
that black holes are very big and very
What?
heavy, the structure of the way that they contain
Yeah, I'm going pee,
information,
dude, sorry.
the way that they interact with the rest of the world through radiation and other things is highly quantum mechanical. And so black holes seem to be the natural doorway, the place where we get really surprising paradoxes from that we can explore in hopes to learn more about the connection between quantum mechanics and gravity. That's the point. All right, so let me begin about black holes with some tension that was already there in the classical theory of black holes. It's not a real paradox, but it's a bit of tension. So let me show you what the tension is. The tension has to do with the difference of descriptions from outside the black hole and from somebody falling into a black hole. Here's a black hole. What I've drawn is the horizon of the black hole, and the horizon of the black hole is a place from which, on the outside, somebody can shoot radiation or something else can shoot things out which will escape. And the inside is the place that gravity is so strong that anything you shoot either in or out will wind up at some nasty singularity at the center. We don't need to be more precise about it than that. It's a dividing line. It's a point of no return. Anything that falls through is trapped. Anything that is outside has a chance to escape. Now, the property of clocks and measuring rods get very distorted near a horizon in the following way. You probably all know this, but let me just remind you that if an object is falling into a black hole, from the perspective of the outside, from the point of view of coordinates,
If I just smoke until
which are
I
built
die,
to
will I just
describe the outside
enter a black hole?
what happens is the object asymptotically slowly approaches the horizon. Now, this
Interesting.
is because clocks slow down in a funny way near the horizon. Nothing is observable about that slowing down to the observer falling in. The reason is his clock slowed down, his heartbeat slows down, every internal
know?
clock that he has slows down. So he sees nothing, but his comparison with outside clocks far away watching him is such that, first of all, he asymptotically slower and slower and slower and slower approaches the horizon.
What?
And at the same time, Lorentz contraction takes place.
What's
so
Lorentz?
after a long time, this blob over here, this is all classical now, becomes a thin little blob asymptotically approaching closer and closer to the horizon.
Yep.
In fact, not only will that observer be, I was going to say stretched out. Stretched out is not quite the right word classically. Just plastered against the horizon like this. But everything that ever fell in to make the black hole has exactly the same property. It's all contained in infinitely thin, well, not infinitely thin, but progressively thinner and thinner shells that approach the horizon asymptotically, never quite getting there. Takes an infinite amount of time from the
Can you feed me? Do you have a
outside
snack?
observer for anything to get to the.
I didn't order a pizza.
I know. But that Parker promo saved me so much in my insurance. Brought you a little something special.
Snack.
So in a sense, nothing ever gets there.
Nah.
And our description of the black hole from the outside should be then
Yep.
a shell called the horizon,
Yep.
inside of which there is nothing that will ever be important to us, because from our perspective, nothing ever fell through.
Nope.
And
What?
all the matter that ever fell onto the horizon is in this progressively thinner and thinner, it's a kind of sedimentary structure that just falls toward the horizon, never quite getting there. Now, there are
You
two
guys
things
won't
which are
remember me?
infinite. First, for a classical black hole, the first is the time that it takes for anything to get to the black hole surface.
Like, really,
And the
though, dude?
second is the amount of information that you can hide in this thin sedimentary structure that just approaches the horizon. There is no limit classically on how much structure of this kind you can have
Leonard.
at the horizon of a black hole.
Leonard.
Structure, I mean information, bits of information.
Leonard,
Bits of
come on.
information in classical physics can be encoded in arbitrarily weak signals of arbitrarily low frequency or energy, arbitrarily low.
Leonard.
And so
Leonard
weak
Skinner.
signals can carry any amount, any
Is that what
number
you
of
promote?
bits, any number of bits of information.
Is that what you're promoting? Is that...
And so the hidden information at the horizon of a black hole can be infinite in classical physics.
What? No.
Hidden
Huh? Yeah, I'm a black
has
hole.
another word. The word is entropy. So in classical physics,
Chris
some
Payne.
people sometimes think that
What?
Bekenstein
Infinite is the
discovered
word.
that black holes have entropy. Not at all. What he discovered is that
Black
they
holes are
don't
here.
have too much entropy. That the amount of entropy
It fluctuates,
that they have is
dude.
in fact finite. So we'll come to that in a moment.
Well,
So
it's a
those two things that are
superposition.
infinite,
I demonstrate a
time that
superposition
it
right
takes to
now.
fall through the horizon from the
And
outside,
as I live,
and the
we're
amount
called
of
neutrinos. Neutrinos are something you should look into.
For those people who know about black holes, this is familiar and a standard story. For those people
it's
who
not.
don't know anything about relativity, what I'm about to say next will be useless. But for those people who are somewhere in between, let me draw you a diagram
But
to show you how
It's one of the ways. I
consistent
can really describe it to
that
you in the best
it can
form.
take a finite amount of time to fall through the horizon for the infalling observer.
Because if we talk
and
about
yet
how these
infinite
atoms
amount
are
of time as
formed
seen
and
from the
quarks are formed,
Did I neglect to say, I don't remember if I said,
I formulated
that
to
the
that.
amount of proper time that it takes something to fall through is quite finite. That's the tension. A finite amount of time that the infalling observer experiences falling through the horizon, and an infinite amount of time as seen from the outside. All right, so it's a simple picture that would help.
Right.
That's Minkowski space. Why am I interested in Minkowski space? Because Einstein taught us the first thing
Oh.
you want to do when you want to understand gravity is understand acceleration. Understand physics in
Yes.
flat space.
What is he
accelerated
getting
coordinate
at?
System. An accelerated coordinate system
Yes.
in
Whoa, the
Minkowski
crosshair theory.
space looks like this. These are the lines of constant position, and the lines of constant time
But
look like this. It's a kind of hyperbolic structure. This is
What
an
are you
infalling
doing?
reference frame.
That's
Time
not
goes this
me.
way.
I'm a
space
black hole.
goes this way, and those are uniformly accelerated frame of reference.
Okay.
Now imagine, this is t equals
Mhm.
0, this is t equals 1, this is t equals 2, t equals 3, dot, 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 until you get up to this line, and that's t equals infinity.
Right.
A little bit odd. Now somebody falls through, or no, somebody
What?
moves along this direction here. There's no horizon here, there's no black hole here. This is just flat space-time. But how long does it take for this blue observer here
Uh-huh.
to pass the light cone over here?
What's that
Well,
light cone?
from the point of view of his own internal clocks, it's clear. It's a finite amount of
You
proper
talking about
time. The length of
T?
this line is finite. Nothing special. This observer falling through doesn't care about this odd set of coordinates. On the other hand, somebody standing outside, and staying outside involves accelerating. You cannot stay to the left of this light cone without accelerating. In the same way that I cannot stand on the floor of this room without accelerating. Accelerating means experience and acceleration. So Einstein said, if you want to understand
By
gravity,
moving?
understand acceleration. Here, we're trying to understand acceleration, and we have a funny situation. If you stay outside this light cone and watch somebody falling through, it takes an infinite amount of time.
Why do you need
On the other hand, there's nothing infinite about
to know
the
the
perceptions of the
acceleration
person
of
falling
the?
through. So both are true. Both
Right.
are true.
Yeah. Okay. Sorry.
Classically, it was never regarded as a tremendous paradox. It was just regarded as a curiosity.
Right. No shit.
This is the structure of a black hole geometry
Wow.
very near the horizon.
Holy
You
shit.
don't have to know very much. All you have to know is that the region back here
Yep.
maps to the region behind the horizon.
What is
And
that?
notice that somebody who's out here can never send a signal to this side of this light cone. That's equivalent to saying that something that falls through the horizon can never send a signal out. Any signal winds up going in and not out. All right, so that's the setup.
Yep.
Infinite time, infinite amount of information can be stored arbitrarily close to the horizon. All right, now, as I said, hidden information is called entropy.
Okay.
Well, I think it was in 1972 that
Yep.
Jacob Bekenstein asked a very fundamental question, somehow no one asked it before. If a black hole can store an infinite amount of information, it
Yes.
just keeps collecting and collecting and collecting,
Yes.
either think of it that way or falling into the black hole, either way, you have a situation which is somewhat like early quantum mechanics or before pre-quantum mechanics.
Yeah.
In pre-quantum mechanics, the radiation field
Was too
of a given
stupid.
amount of energy could contain an infinite amount of information. It was called the ultraviolet
Sorry, guys.
Because each mode of the radiation field, no matter what its frequency is, can store arbitrary amounts of entropy.
Mhm.
What will happen classically is if you have some energy contained in radiation, it will just migrate more and more and more into the ultraviolet modes, where there's simply an infinite phase space to absorb the entropy, to contain the entropy. Same thing would happen here.
What? I can disintegrate?
Any amount of entropy that's in space here
So
will
I'm
just get
believing that?
sucked more and more and more into the black hole. And if you didn't account for the fact that the black hole itself had entropy, you would conclude that entropy was lost to the world. It's not lost to the world, it's absorbed into these infinitely thin layers here, and it can't get out, not without getting very close to the speed of light. But Bekenstein didn't like that. It didn't feel right.
Who's
He
Bekenstein? I got
suspected
the
that
Bekenstein
somehow
brain.
black holes are like anything else and have a finite entropy. I'm going to take you through Bekenstein's argument, because if I don't teach you anything else,
Okay.
this is really one of the most beautiful Gedanken pieces of physics that I know
Okay.
of.
Sorry.
And
That's
it
cool.
can be
Good
taught,
for you, man.
easily taught to a physicist who doesn't know about black holes.
Right.
In fact, it can be taught to a high school student that doesn't know calculus.
Uh-huh.
So I don't see any high school students that don't know calculus, but you might take this home and explain it to your teenager. Why do black holes have a finite entropy, and how much is the entropy? And here's the way the argument goes.
Why do what?
What we're going to do is we're going to build up a black
I
hole
did not
from
take.
scratch
I
by
took
dropping in
pre-calc.
particle by particle by particle and asking, after we've built up the black hole to a certain size, what's the
I
amount,
took pre-calc.
what's the number of particles that we need to send in? Why particles? In a simple situation, a single particle contains one bit of information.
I'm
It's
smart.
either there or it's not there. Well, that's not right. Wait a minute, that's not right.
Well,
I want to
I'm
build
a
up a
black,
black
hole,
hole,
actually. Apologize.
by sending in bit by bit, and a bit means one piece of information.
I'm optimistic.
I cannot do it
Positive.
with high frequency or
You can't do
localized
it? Okay,
photons.
right. Sorry.
The reason is a localized photon has more information in it than just the fact that it's either there or not there.
Okay, right.
Namely, it has information about where it might fall into the horizon.
Yeah, a little bit above.
So what you want to do to send
you're
in
in it.
one bit of information into a black hole is to send it in the form of a photon whose wavelength is so long that you can't distinguish where it passed through the horizon. Okay, so let me write some simple formulas on the blackboard and you'll get the idea because it's very simple.
Okay.
The first formula is the formula for the radius of the black hole in terms of its mass. That's equal to the Schwarzschild radius, and many of you have seen it, twice the mass times Newton's constant divided by c squared. That's why black holes are so small. G is small, C is big.
What? We already
Black
went
hole
over
for a
this.
given mass. The mass of a black hole the size of a black hole, the mass of the Earth, would be about as big as a peanut. That's what the C's are doing here and the small g.
Yep.
Okay, so that's one formula.
What's the C? What's
Next
the C?
formula, I'm going to imagine building up the black hole from a small, tiny little thing by throwing in one particle, one photon at a time, one
Yep.
massless photon at a time.
Yep.
But a photon whose wavelength is about equal to r at that time.
Yeah, me.
Why? Because I don't want that photon to have any information about it other than the fact that it fell into the black hole.
Yes.
Okay, so the wavelength is equal to r. How much energy does that add to the black hole? Well, the energy of a photon is, let's call it delta E, the change in the energy. That's h bar c over lambda. Now notice I'm doing quantum mechanics now. H bar has come into it.
H bar.
The change in the energy of the black hole due to sending one bit of
Lambda.
information in
And then C?
is
What's
h bar
lowercase
c over lambda, where lambda is equal to r.
Lambda.
What about the change in the
Lambda.
mass of a black hole? Well, we use E equals mc squared.
Yep.
So
You
the
just
change
pulled
in the mass of the black hole will have
changed it
two
right there.
additional powers of c downstairs.
Lambda God.
And the change in the
Einstein
mass
did not believe in God.
is h bar over rc.
Okay. So I'm
Okay,
singing.
next step. Let's
Yes.
compute the change in the radius of the black hole.
What are
We
you
know the
doing?
change in the mass.
Okay.
So the change in the radius due to dropping in one photon,
Yes.
the change in the radius
Uh-huh.
is going to be 2g over c squared
I'm G with it.
times h
Leonard.
bar
H bars.
over rc. Haven't even used any calculus yet. And I'm That's the change in the radius of the black hole, adding one bit of information to it. Namely, a photon is either there or not there. Okay, let me clean it up. There's a c cubed downstairs, and there's an r downstairs.
I just yawned
I want to get
downstairs.
the r out of the
In
right-hand
the drive,
side.
the human drive.
That's easy to do. You just multiply by r.
Wow, yeah, sorry.
But r times delta r is a familiar thing. It's
Uh-huh.
the change in r squared, which is
Humble.
the change in the area of the horizon.
Yeah.
What's that? Oh!
What do you say?
You're right. Squared, which is the change in the area of the horizon. What's that? Oh! It's the change in r squared, which is the change in the area of the horizon. What's that? Oh! You're right.
Huh.
Somebody's very quick. Yes, indeed. You need some calculus to know that r delta r is delta of the area.
No, no, you don't need.
Now,
Oh.
set everything under the sun equal to 1.
You don't
except
need
the important
calculus.
one. Well, I said 2 pi, 4 pi.
You
I
don't.
know.
You don't need calculus.
Change in the area. Notice
That's a
what it
funny
says.
joke, though.
The change in the area of the black hole due to one bit of information is a universal constant. It does not depend on the radius of the black hole, doesn't depend on its mass. Each time you add one bit, you add another unit of area to the size of the black hole, to the horizon area.
Yep. So you have to just block
You
my
can
internet, or what?
write this a different way.
Why?
You can say the number of bits that it took to
Am I
make a
exposing
black
it?
hole of radius
But
r.
I'm a black hole.
And I'm going to call that the entropy of the black hole. It's the number of hidden bits of information. That, S
No.
for entropy.
No.
I don't know how S ever got to be entropy, but
Leonard.
The entropy of the black hole, the number of bits of formation,
Susskind.
is equal to the area, the final area, since each bit
Leonard Susskind.
increases the area by
How we
this
doing,
much.
man?
Then, by this much.
Yep.
Then the entropy of the black hole
I like
is
your
the
class,
area
man. This is good.
measured in this unit. The 2 is not important here.
I don't think
Actually,
anything is
two is
actually.
important.
I don't think you'd actually could be. You didn't even really describe anything.
H bar
Apologize. You're just fucking running through it, dude. Do you get paid to do this?
Strictly speaking, there's a 4 downstairs.
There is. Oh, what's going on?
Not coming
Oh.
from this argument. Coming from
Wow.
Hawking's,
Yeah. No.
very
Yeah. Definitely.
sophisticated
Are you good, man? You good? Are you okay?
This is the basic idea.
Leonard Susskind, are you okay, man?
Entropy of a black hole, the number
Wow.
of the maximum number of bits of information.
Hey, man,
that you
finish
can
the
hide.
4, buddy.
And sending in photon by photon this way does maximize the information that you can get in
People are taking notes.
the maximum amount of information, or the entropy of the black hole,
I mean,
the area in the unit, which is
that's
the
just
Planck
bizarre.
unit.
You good?
10 to the minus 66
You gotta control.
square centimeters, a very small unit of area.
Wow. Had him stirred up.
That was the discovery of
He's
Bekenstein.
stirred up by doing
Later,
that in front of
Hawking
people too.
put, some additional substance.
Are you okay,
into
buddy?
it.
Have you been all
In
right?
fact, what
Can you hear
Hawking-
me?
I don't.
I can talk
I
to
wasn't
you.
Around. I was certainly around at that time. I was
Yeah,
also
you
an
were.
old man at that time.
Do you know God? Do you
I
talk to
wasn't
God?
around Cambridge when this
Talk
was
to
done,
God, sir.
or Princeton. So I don't know exactly who figured out what and when and where.
Wow.
But once a thing has
You gotta
both
chill.
entropy and energy, energy is its mass, mc squared.
Not
It has
mass.
both entropy and
No,
mass.
dude.
It's
No,
going
man.
to have temperature.
What?
I'll just remind you,
Okay.
dE
So then it
equals
will
temperature
spook you.
ds. And if you know how
No,
the energy
no.
changes as a function of entropy, or how the entropy changes as a function of energy, then you know the temperature.
That's crazy.
And what you find from a little bit of thermodynamics,
Why?
another
Why
equation,
are you so aggressive,
the
sir?
Hawking temperature, T
Are you
is equal to
frustrated
1
now?
over 8
No,
pi.
no, I'm sorry.
Now
I'm just bullying you.
actually
I'm just
putting
being
in numbers.
stupid. K-Pain 8.0. Yeah, what up?
H
All right.
bar.
Good call.
And now
What
I've
up?
forgotten where the C's go.
Yeah, H bar, Kate Payne 8.0, pi, the circle boy, T from the last one.
Like me, the speed of light is equal to 1 over h bar G, m, mass. Mass of the black hole.
The mass?
The temperature goes down with mass, down with energy. That's
What?
negative specific.
A mass? Yo, you can.
Hmm?
You've held the black hole. These are all theories. I am the black hole. G? G.
Important thing to note.
Huh?
Well, all of it is important. But h bar is in the denominator.
Okay.
In other words, in the classical limit, the entropy or the amount of the storage capacity of the black hole to find information becomes infinite. But quantum mechanics, as in many other contexts,
Yeah.
makes things which classically are infinite, makes them finite.
Yeah.
Notice also that the temperature is a quantum effect. The temperature would be 0 in classical physics, and the entropy infinite. That is the description of a black hole from the outside.
Yes.
From the outside,
Hey, buddy.
a black hole is just an object with a certain energy, a certain entropy, and because it has a temperature, it radiates. It radiates black body radiation, unlike the sun, which radiates with wavelengths vastly smaller than the sun. So you could use sunlight to resolve the sun in the sky. The black hole radiates with wavelengths comparable to the whole size of a black hole.
Yeah.
So if you try to look at a black hole with its own radiation, it looks pretty fuzzy. That's not why this thing is called fuzz or fire, is it?
No.
It's not, I don't think.
It's
So, okay.
okay, buddy.
Okay. That's the description from outside. Just an ordinary thing,
Huh?
warm, cooling thing. Just for some numbers, incidentally.
Huh?
The
Huh?
entropy of a solar mass black hole, I think, is somewhere up near 10 to the 70th. I don't remember exactly.
Huh?
10 to the 68th.
70.
So that's big. You can't think of anything else. In
7.0.
nature that's, the size of a black hole.
Cape Paint 7.0 emerged.
Its temperature is very small. I don't know, 10 to the minus 8 degrees or something like that.
Sorry.
And it's an odd object. Has some other amazing
No, it's not.
properties.
Oh, yeah,
Thermalizes
well, yeah.
faster than
It's
anything
what
else,
I
but
can
that's okay.
distribute.
The central
But I have
question
written
is,
stuff.
if this is what, well, let's think about it for a moment. What it's telling us is that this infinitely thin sediment and its infinite capacity to hold information was not right. Somehow there's a finite capacity to hold information. And one way of thinking about it is to say that you cannot store anything on a vertical scale here smaller than the Planck length. That's basically what it comes down to.
Yeah.
There's a fundamental length
What?
on the horizon or just adjacent to the horizon, and
Yeah.
information cannot be squeezed smaller than that. That's what this says.
Yes.
Of course, another very odd thing is in almost every context where we think about entropy in this room is proportional to the volume of the room, not the area of the room. And that's kind of telling
The
us
volume of
somehow
the room.
that there's nothing inside the black hole. That there's just nothing inside the black hole because the entropy is proportional to its area.
Wow.
On the other hand, classical black hole physics also tells us that it's meaningful for somebody to fall through the horizon. It takes a finite proper time, and so now we are getting into paradox land.
Yep.
The exterior of the black hole has a brick wall or a shell that nothing can penetrate through it.
No. You can't make fun of me for
Everything gets
anything.
Stuck at this. This is called the stretched horizon, incidentally. Stretched because it's a little bit bigger than the horizon.
Okay.
It's called the stretched horizon.
What is
And
it?
the picture is that a black hole is just a hollow sphere with absolutely nothing in it, because its entropy is proportional to its surface area,
Yes.
with some kind of microscopic degrees of freedom. It could be string theory, it could be fuzzballs, it could be who knows what. Some kind of microscopic structure. It's hot.
Yeah.
It has temperature. Incidentally, you might think that it has low temperature.
Who's hot?
It doesn't.
You called me hot?
Photons which come out here
Oh
are
no.
redshifted as they go out.
That's just
why
a
the
funny
temperature
joke
is
though,
so low when
dude.
seen from far away. But the temperature close by, that same temperature is blue shifted, and it's enormously hot. So
Wow.
that's our picture of the black hole from the exterior. It took a long time
Okay.
to develop it.
Alright, no
It
shit.
took a long time to develop it and get the ideas, what I
Wow.
think is correct.
That was good. That was interesting. You got the red one out of me, you got the blue one out of me.
But in all of the studies of black holes and black hole information and so forth in the last 25 years,
Yep.
or 20 years or so forth,
26.
the emphasis was on this picture from the outside.
Whoa, whoa, whoa,
And people
whoa.
forgot
Consciousness
to
maybe
ask,
started at. Whoa.
Wait a minute. How do we describe the infalling observer in this same picture?
Yeah.
The infalling observer,
Yeah.
one possibility
Yeah.
is that the black hole really is just a hollow thing with nothing in it, not even any space-time in it,
No.
in which case nothing could penetrate it. That's one answer. But that's not very satisfying for the simple reason that Einstein's theory of gravity and this picture here certainly suggest that a freely falling observer would take a finite time to go through. So the puzzle arose of how to reconcile the idea that things can be on the inside of the black hole, planets, stars, whatever,
Yep.
if the black hole is big enough.
Right.
Things can be in there from the point of view of an observer falling through the horizon with the picture from outside that it's just this hollow thing with microphysics on the boundaries.
Huh.
That led to an idea, which I think most of the people who work in this subject accept as correct.
No.
An idea called the holographic principle.
The black
I'm
hole
just going to state it very, very briefly.
is me.
Basic idea is that this boundary structure out here
Sorry.
functions as something like a hologram. I'm not going to try to do better than that for this audience now.
It's not a hologram.
Here? No, he knows all this.
I'm a legend.
He put this
Philosopher
in a very,
Chris
very
Payne.
sharp context. The idea had been around for a few years before he got his hands on it, but he really nailed it and got a very clear idea of it.
Thank you.
The idea is, yes, there are things on the inside, but their relationship to this structure, which is holding all the information that ever fell onto the black hole, is, roughly speaking, this is a metaphor, it's not a theory,
Okay.
metaphor of the hologram.
Right.
The information can either be thought of as being stored on the film, or the film can just be thought of as a representation of the three-dimensional reality, and I'm not going to go into that any deeper than
Of the
that.
three-dimensional
because that would take
reality?
us all day.
So I want to contact you or something?
Okay.
Like what?
So that's the picture as it was roughly a year and a half ago.
Uh-huh. Year and a half ago.
Not quite the whole story. In addition, this
Huh? Whose story?
material, or whatever it is,
Whose story?
being hot, can also radiate. And in the process of radiating, it loses energy, and the whole thing gets smaller and smaller.
Okay,
until
so
it
maybe
evaporates.
I started looking into astrology
amazing
pretty.
evaporating black hole.
Wow. I did.
Okay.
Holy shit. Mm-hmm.
So let's come to the quantum mechanics of this and what we think what the dilemma is.
know a lot about
what
these
the,
things.
What the conflict of principle is. The first thing is to put yourself in an infalling frame of reference that's just passing through the horizon.
What horizon?
One thing
What is this?
that quantum mechanics
What horizon?
requires of the description of empty space.
What's a horizon?
The infalling observer, according to this theory,
What's
just
a horizon?
experiences empty space, nothing more. Falls through experiences an empty space, and empty space has a property. It's called entanglement. It's quantum
Sky meets the
entanglement.
earth.
If you don't know about quantum entanglement,
These are the heavens. Quantum entangled.
you can read.
Are you in my
Dennis
heavens, Leonard?
Overby's description of it. It's as good as anything else.
Are you in my heavens?
But whatever
Whoa.
quantum entanglement is,
Holy
it's a relationship between pairs of systems. It's not a relationship that has to be there, but it's a relationship between pairs of systems that can be realized. A pair of electrons, just a pair of regions of space,
Holy shit.
Which-
Real.
says that those
Maybe.
regions are highly correlated, but in a deeply quantum mechanical sense. I won't
don't
try
know
to
if your name
explain
is real. I don't
entanglement
really-
except
it's-
to say that
it's
it's
okay,
what
buddy.
Einstein called spooky action at a distance. It's not action at a distance, but it is spooky.
What's spooky?
And here's what vacuum
What?
quantum field theory, the theory of empty space, tells us. It tells us if somebody passes through, they should see the interior regions of space.
Yeah.
Let's call them A.
Einstein's
Santa
spooky
Barbarians
action. I
have
watched
some
tons of videos on that way
notation
back.
which involves any number of twiddles and primes and stars and it's very bad.
Crimes? What's a rhyme? Crime.
And B.
And B?
B,
What's B?
of course, is the obvious notation for
You threw me
zone.
off guard. Threw me off
It's
guard.
supposed to be a joke.
Yeah, I get
A
you because you asked
is the
what.
interior.
You don't
A
want to
for
reveal anything.
interior,
What do you have
B
to
for
give off
zone,
right now?
and why B is called a zone doesn't matter at all. The interior, just beyond the
It is a
horizon,
zone. You just
exterior,
faked me out.
two
You
regions
just
of
faked
space
everybody
are
out. It
highly
is. It's a
entangled.
joke.
I will
It's humor.
represent
It's
that by
funny. It's
drawing a
God.
line between them.
It's-
There is no
it's
line
weird.
between them.
It is weird.
But they
It is weird.
enjoy this property of entanglement between them. What entanglement means is that if you measure B, you could find out what you want to know about A. If you
Yeah.
measure A, you can find out what you want to know about
Yeah,
B.
yeah.
They're entangled.
Yep. Okay. What up, buddy?
All that's fine.
Hey,
No problem there.
Hey
until the
guys.
black hole starts evaporating.
Hey, what?
And as it evaporates,
No. What does evaporating even mean?
what happens is the entanglement
Why do you keep
between
saying
A
this?
and B, between the interior of the black hole and the near horizon region, the region just outside the horizon, gets
Liquid
replaced.
into
Basically,
vapor?
these degrees of freedom go flying off.
Oh, no
They go
way.
flying off into the radiation.
Am
And
I?
after the radiation is emitted, in particular,
What?
after about half of it has been emitted,
Whoa.
half the radiation that will ever be emitted, instead of A being entangled with B,
Yeah.
A, the interior of the black hole, and B are entangled instead with the very, very distant Hawking radiation.
Wow.
The Hawking radiation is impossibly far from the black hole by the time the black hole is radiated. And so, one is left in a dilemma. It looks like something awful has sorry, one more step.
Sorry, buddy.
A has become entangled with the radiation far away.
Of your.
But now there's a famous quantum mechanical theorem. It's called the monogamy of entanglement. Two things.
What?
Three
No.
things, and two of them are entangled with each
No.
other. The third cannot be entangled with either. So now we have a puzzle. If in order to make sense out of this holographic picture of the interior of a black hole,
Yep.
we
Say it.
require,
You have to
from
say
the
it.
point of view of the inflowing observer,
You have to say it.
A and B be entangled. But at the same time, we discover that these degrees of freedom become entangled with very distant radiation. Then
Nah.
the result is that the entanglement between B and A must be destroyed.
Yep.
That sounds
Forgot
like
about
a
it.
disaster because the destruction
It's a joke.
of
It's a joke,
the
dude.
entanglement between these two near regions here would really perturb the nature of the vacuum between the interior and the exterior very seriously. It would make it hot, it would make it very dangerous. It would imply that somebody falling through the horizon here would not see sensible physics there. They would see something awful. Yes, Stephen. Both. I'm simplifying a little bit.
Wow, yo, so you literally are freaking telling me.
No. Yeah, B becomes entangled with the radiation
Dang.
and can no longer be entangled with A, which really means it can't be entangled with a stretched horizon. But you know, let's keep it simple.
Nope. Nope. Right now, that is
So,
bizarre, dude. Do you
Instead
want
of
to wait? Do you want to
this
hear it?
bond being there,
What's going to be the third
entanglement of
thing?
B with A.
What's
we
going to be
have
the third
B
thing? Nope, buddy. Nope.
out
Sorry,
here,
buddy.
the
Go
Hawking
back. Go
radiation
back.
far away.
Do I have to rewind the
As
video?
I said, that sounds like a terrible perturbation on the horizon of the black hole,
A horizon.
unless there was one possibility that information theoretically, in counting where bits of information are stored, unless the interior of the black hole is really encoded in the distant Hawking radiation. Then we will simply say B is entangled with the Hawking radiation, but the Hawking radiation is just another way of speaking about the stuff behind the horizon.
What up?
That's called an A equals RB theory,
No.
and it stands for the interior being constructed somehow
Red, blue.
out of the radiation far away, which is entangled with B.
Yep.
Now,
you
I
pointed
won't
out
try to
earlier.
explain that, except to indicate to you how absurd it is. What it's saying is that somehow the interior of the black hole is really being represented, a nearby black hole, you know, a black hole at in this room, that its interior would be represented in terms of degrees of freedom, which could be, I don't know how many times bigger than the universe far away. That doesn't sound reasonable.
No, it does.
Nevertheless, I think it's true.
Wait, what?
It's where we're being driven. That a degree of delocalization. First of all, let me say this.
Sorry.
Even the holographic principle was a delocalization of where information was.
No.
A thing which we all accept, the idea that the interior of a region is described by degrees of freedom on its boundary, that already is a degree of delocalization. But this is an extreme degree of delocalization.
Okay.
That the information describing Alice falling through the horizon over here
Yep.
is contained not on Alpha Centauri, not at the, much, much further away. Seems absurd.
Huh? You seem absurd.
What's the resolution of this?
What are you talking
After
about? How are you talking about me like
the
this?
black hole has become entangled with a very, very distant radiation.
No.
Well,
Eh,
one possible answer,
It's interesting.
to my mind, a clumsy, heavy-handed, brutal dumbbell
Broke chalk.
idea is the firewall idea. Now, the firewall idea is a misnomer. I don't think you should think there's some terrible fire just outside the horizon. I think the firewall idea really should be phrased by saying, once you disrupt the entanglement between B and A, then the right picture, according to the firewall enthusiasts, is that there just is no interior. The interior has been scooped up and put out here in the radiation, information theoretically.
Yes.
There is no interior. Somebody falling in just hits a blank wall, not a firewall, but a dead end.
Yep.
You're not burned, you're terminated. Right.
How?
Okay, but it doesn't matter. I mean, the idea, that's one resolution.
What?
Don Moroff seems to be the only person who truly
You're burned
believes
in a
this
black
with
hole?
any
Is that what you're
real,
saying? You're terminated
intensity.
in a black hole?
Joe says things like, well, I don't really believe it, but all the evidence seems to be pointing in that direction, but I don't really believe it.
Belief? You're
And
talking about
other
belief?
People, myself, Juan Maldacena, the Verlinda
Hold up.
brothers. I mean, these are really substantial people, very
Ugh.
real heavyweights. They think the firewall is a crock.
A crocodile?
And I think the firewall is a crock.
A crocodile?
But damn it, we can't figure out what's wrong with Joe's argument.
Are you wearing Crocs?
Many people. Excuse me. That was a bad thing to say, right? It has
What up? You guys up late? Sorry.
We think it's a crock, but we can't figure out exactly what's wrong with it. I myself suspect that there's something true to, and others think there's something correct about the idea that the distant Hawking radiation is information theoretically and holographically a description of the interior of the black hole, but there are other paradoxes. I have not explained the full
Sit down and talk with me. It'd be
ammunition that the
interesting,
firewall
probably.
people have to bring to bear on this. They have a number of arguments.
Huh.
I think it was Feynman who said
No.
if you have more than one argument, they're probably bad because one argument. But in this case, I think
I
the
just
more
am.
arguments,
Holy
the
shit.
stronger the case is.
I
And we
am
don't
a
know what's
black
going
hole.
on. There are different theories. I could tell you. One of them has to do with wormholes. Some, really nutcase people who believe in wormholes. Other people think
Believe?
that quantum error correction is important. They're also crazy. I belong to both groups.
Quantum error?
But my own guess is whether or not it's wormholes and quantum error correction. I don't really think it's
What?
It's these.
So you're talking about this correct,
firewalls.
but
That
no.
just seems a little bit too simple to me.
Yeah, it does.
My guess is we're going to learn something truly deep about the connection between quantum mechanics and gravity from this exercise.
Yeah.
And,
Sorry, guys.
I can't tell you what it is with any certainty right now,
Huh.
but it's exciting. It's
Hmm.
exciting. It's interesting.
Yeah.
One has the feeling that at any time some young person will come along, put his finger on it, and that it will really be some new perspective into the quantum mechanics of gravity that I think is unexpected.
Yes.
I talked longer than I expected to, actually. I was expecting to stop and field questions.
Oh,
so
snap.
I can do that now for a little while.
Nice question. What does it take for two quantities, two zones, what have you, to be entangled? What is the condition?
Well,
Audio.
Or not entangled?
A sense. Touch the senses.
I'm not sure. Are you a biologist or a physicist?
No, astrophysics.
Well, here we are. So, my black hole.
That may have come out not the way I intended.
Oh.
So systems have wave
What?
functions.
No
Wave
way.
functions depend
It's
on
savage.
degrees of freedom of the system, and if you have a pair of systems, then the wave function depends on both variables. So it's a psi of, let's call them
Didn't
x and
mean it
y,
like
but
that,
these don't
buddy.
have coordinates, they're just two variables.
Right.
An unentangled state is one which is a product, psi of x times phi of y. This
The
is a state
eyes.
in which
Just
there are
look into
no
my eyes.
correlations.
It's there.
Statistical independence, but quantum statistical independence between the two systems. Any state which is not of a product form is called entangled.
Yeah.
Now, there are degrees of entanglement.
Okay.
How strongly are they entangled? Just a mild deviation from product would have a little bit of entanglement. There are situations